for you. Watching out on you, breaking all the rules. One day soon you'll see, from my point of view. Why do we always have to figure it out? The past, the present, and the future all at once. And I don't know the reason why we fight. And I don't know the reason why we lie. And I don't know the reason why we hide our faces. I don't know your rules. You don't know my rules. All my little stars shining just for you. 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 Why do we always fall in love? Why do we always fall in love? All these crossroads in my life I cannot account, leading me into new directions. So much love and so much pain I had to face, as I had to make my
She's from NCCS. Fine. 5 minutes. Requesting everyone to please start settling down. We are starting in 5 minutes. We'd like to request all the delegates who can hear us outside the hall to please start proceeding inside and take your seats. We shall be starting in less than 5 minutes. Thank you. Good morning, ladies and gentlemen. Requesting you to please take your seats. We shall start now. I'd like to request and remind everyone to please just check your mobile phones if it's turned on a silent mode as we get ready to start. Welcome, ladies and gentlemen, to day 2 of the International Conference on 5G Network Security, organized by NCCS, National Center for Communication Security. We begin our day with our first session. I'd like to start with introducing and inviting our moderator, Shri Rajesh Kumar Verma, GM, Bangalore, BA, BSNL. Mr. Rajesh Kumar Verma is a 95 batch of Indian Telecommunication Services officer with more than 25 years of industry experience in various telecommunication fields. He holds a BTech degree in electronics engineering besides MBA from IIM Ahmedabad 2010. He has extensive working experience in planning, installation and operation of IP-based networks. During his 1-year tenure in NCCS, his key contributions include security testing of 4G network elements, finalization of test procedures, and empanelment of testing labs. Currently, he is working as General Manager, Consumer Fixed Access in BSNL Bangalore business area. Welcome, sir. May I request Shri Manas Kumar Panda to please hand over a bouquet to sir. Shri Manas Kumar Panda is ADG NCCS. So with this, we now invite and introduce our speakers to you. We have Shri Uma Mahesh Mudigonda, a Principal Technical Program Manager at Microsoft with over 20 years of experience in the networking industry, spanning both technical and leadership roles. He has worked with leading operators and vendors across the world, helping them design, deploy, and manage complex network solutions. He has more than a decade of expertise building services in Microsoft Cloud and is currently driving the adoption of Microsoft Operator Nexus amongst operators. He is passionate about enabling operators to leverage the power of Azure to transform their networks and businesses. He holds a Master of Science by Research degree from IIT Madras. Shri Uma Mahesh Mudigonda. Welcome, sir. Please allow us to welcome you with some flowers. Also joining us is Shri Sarvanan Velrajan, who currently works as the Principal Consultant at Ginkos India. He has over 25 years of experience in networking technologies, and he is MBA in Technology Management from University of Phoenix. He worked both in USA and in India for startups and established companies, driving multiple digital transformation initiatives. He is the author of the book An Introduction to 5G Wireless Networks. He's a much sought-out professional speaker and trainer, and he's currently pursuing his PhD in edge computing. Welcoming Shri Sarvanan. Sir, that's all. One more person. That's it. So please accept this flowers as a warm welcome to you. Thank you for joining us. And with this, I'll hand it over to our moderator. Sir, over to you.
Good morning. Good morning to all of you. So, looks like still some of us are enjoying cool breeze of Bangalore, but still I can see a good crowd, and that indicates that yesterday's sessions have been insightful and interesting. And I'm sure that today's sessions will also be equally insightful and interesting. So in the first session, today's first topic is deployment of 5G in cloud technological options and management and orchestration, that is MANO, by Sri Uma Mahesh from Microsoft. As we know that there has been a rapid transformation the way software applications are developed, deployed, and maintained. And same thing is happening for telecom network functions also. Not long ago, in fact, the telecom network elements used to be sort of black box. But now, when everything is moving towards use of open source modular deployment, general purpose hardware, usage of general purpose hardware, and then comes here the cloud technologies, where the network functions 5G with the 4G and 5G, it is completely moving to deployment over cloud technologies, cloud infrastructure. So Mr. Mahesh will take you through that how the Microsoft cloud platform is going to meet the requirements of telcos for hosting their network functions, because network functions require certain requirements. I mean, it has to be carrier grade. There are certain challenges to maintain the latencies and security and all those things. So more insights will be from Mr. Mahesh on this. Over to you, sir.
Thank you, Rajesh Kumar ji. Good morning, everyone. Thanks for giving me this opportunity to present our learnings with respect to Microsoft Cloud. And yesterday we had some wonderful sessions and great insights with respect to the challenges, mostly on security and other aspects with respect to 5G deployment. Right? So before I start detailing about the telco challenge, right, I want to take a few minutes explaining our journey in Microsoft Azure with respect to different enterprise IT applications over the last decade, right? So if you look at the current evaluation of telcos, it's not very dissimilar from what the enterprises were going through a decade back, right? So initially enterprises had their services deployed behind appliances. A typical one would be a hardware load balancer. And then as they saw the challenges with scaling and agility, they started disaggregating their functions and then using software-based deployments, right? This journey helped them to reduce their capex, bring in some level of agility, but only to an extent. The complex multi-vendor integration was an operational challenge. And in addition to that, the limited functionality with respect to what was available in a private cloud as opposed to the wide range of services which were offered in hyperscalers like Azure, the gap was huge. As a result, we have seen enterprise IT applications migrate from leveraging appliances to leveraging private cloud and then scaling up with hyperscalers like Azure. And during this journey, during this 10-year journey, we had a lot of learnings with respect to scale, operations, security, DevOps pipelines, and including our own processes, internal process as well. Just before, at the start of this session, we were discussing some of the questions that came up on how secure Azure is, and what about privacy, what about reliability, what about DevOps pipeline, what if someone hacks into the network, right? So we have addressed most of these challenges over the last decade by actually building a very strong and secure zero trust framework inside Azure for enterprise IT applications. And not just for enterprise IT applications, even our own internal first party services, which predate Azure were in their private cloud or were using appliances. And personally, I have helped migrate some of these services into Azure public cloud, right? And the way we do it is by ensuring that the entire stack is secure and you have the ability to integrate with with the ecosystem that is offered with Azure. So we want to bring the power of cloud to telcos. We want to enable telcos to modernize and monetize their network investment. And we do this by helping them bring down their costs as well as enabling them to bring in new services. And we are a partner for telcos. The telcos own the actual customer experience. They own the ideation. They own the business model. We just provide the platform for them. Our focus is to ensure that we provide a carrier-grade computing platform for telcos to bring in their network functions, and we meet them where they are or where they want to be it in cloud or be it at on-premises or edge. And then we work with the entire support ecosystem, be it with RAN providers or NEP vendors offering containerized network functions or virtualized network functions, right? And we understand that it's a journey. Different telcos will operate at different pace, and that's perfectly fine. So our focus is to bring all the cloud technologies that we have built over the last decade and then enable it for telco workloads. At the bottom of the stack is our carrier-grade hybrid platform. This carrier-grade hybrid platform enables telcos to bring cloud-native network virtual functions from a vendor of their choice and powered with the AIOps that is now part of Microsoft stack to enable modern applications. And this actually enables telcos to do three primary things. It helps them reduce costs, increase their operational efficiency, and helps them create new revenue opportunities, right? So with the offering that we have, we bring the cloud economies of scale and efficiencies for telcos to untap their potential. So we're introducing Azure Operator Nexus, a hybrid cloud service that enables operators to deploy their carrier-grade workloads on-premises and onto Azure. We deploy cloud-managed storage, compute, and networking on telco premises as well as in Azure. The choice to deploy which workload where is up to the telco, but there are a few factors which actually influence their decision. The first one being loss of physics. So you want VDU to be within 20 kilometers of the BBU. So you'd rather deploy it in the far edge, right? And you can deploy certainly applications near edge. And there are other constraints. For example, there might be security and regulatory constraints which will force a particular telco in a particular country to deploy in a particular location, right? And there can be other use cases that telcos who are in the trial phase, they may try deploying and validating most of their services in cloud. Regardless of where a particular service is deployed, the cloud-grade capabilities that we provide are constant. So here are some of the key advantages of Azure Operator Nexus, right? We drive operational efficiencies. With our carrier-grade platform, telcos will be able to bring up their network functions in a matter of hours rather than weeks. We are able to bootstrap a complete NFVS stack from dock to live in a matter of 4 hours, right? All this because we use the scale and efficiency that Azure offers, which was earlier for enterprises, now which is being used by telcos as well. And then telcos will be able to leverage the AIOps capability and run smarter applications. And all this without any compromise with respect to security, privacy, reliability, or governance. All the Azure infrastructure that has been built over the last decade helps telcos in ensuring the required RBACs, the required policy governance, and the required pipeline to integrate with the rest of the Azure services. And the beauty of leveraging Azure for telcos is that they will be able to tap in to the 60,000 odd partner ecosystem that we have, right? So they will be able to harness the latest and greatest technological advancements, for example, the AI ops, the large language models, etc., and then enhance their services offerings. And they will accelerate their time to deploy using all these advantages. So Analysis Mason was a third-party survey which identified that by leveraging Azure Operator Nexus, telcos will be able to bring down their operational expenses by a third and increase operational efficiencies by 58%. So we have 90 plus certifications, 65,000 odd partners, and tens of millions of subscribers who are leveraging Azure, and then we invest in the telco DNA. I'll go into a little bit of more detail with respect to what exactly Operator Nexus is, right? So I'll go right from the bottom of the stack, right? So with Operator Nexus, we offer telcos APIs to deploy their mobility network workload functions onto Operator Nexus, either in the far edge or near edge or in public Azure cloud. If you look at the platform, it is carrier grade. It is pre-built and validated on carrier grade hardware with proven 5G and 4G network functions which have already been validated, right? And on top of the COTS hardware, we deploy a hardened Mariner Linux, primarily hardened and enabled for telco workloads. On top of that, we provide Nexus Azure Kubernetes service and virtual machines to enable telcos to bring in VNFs and CNFs of their choice from the vendor they pick. And all this is integrated with the Azure functionality that is offered, which is API, everything is in API. We have end-to-end observability, which can be integrated with Azure services such as Azure Monitor, and also bring in third-party services and third-party solutions onto this one. So this ensures that operators are not able to bring the required workloads, but also are able to operate at Azure scale. Everything is in API. You will be able to, as I mentioned, you will be able to actually, from dock to live, once all the cabling is as per the BOM, bootstrap the entire stamp, an 8-track stamp, in a matter of 4 hours, from networking to compute, and then the underlying infrastructure, and you will be ready to deploy the network functions of choice by the end of the day, right? And the scale at which we operate with respect to the APIs and the kind of RBAC support that we provide also ensures that you will be able to integrate with the existing OSS and BSS systems that are already being deployed by the telcos. So one fundamental concept and questions that comes up with respect to the offering is, what about security? So at Microsoft Azure, we have this zero trust security strategy. I was having this conversation with the gentleman just before this session, right? The idea of zero trust security is providing defense in depth, right? At each point of enforcement, there is defense in depth, and there is enough authentication and authorization at every layer, right? And we have Azure and Azure AD for identity management. I'll cover in the next slide detailed security modeling. And then we have our own solutions with respect to data security, privacy, and we have connectivity options which have proven the test of time over the last decade or so. So this is a slide that I included today morning after listening to some of the security genuine security concerns which were actually established during the sessions yesterday. So if you look at our stack, right, and look at the layers and the available across the stack, both on premises in and Azure, we actually ensure that the Mariner image that is custom built for telco workloads has the right set of API, has the right set of features. We cut down lots of unnecessary functionality and kept the features to the bare minimal, right? So that ensures that the surface attack area is reduced. Now with respect to the protection that we offer, right? So we also have what is called as Microsoft Defender for endpoints and also Microsoft Defender for containers. And we have the Azure Express route, which ensures a secure connectivity between the operator exchange that you choose to come into Azure and into Azure. This has been proven over the last decade and is used by multiple enterprises, including some of the governments and banks for secure hybrid connectivity. And last but not the least, right, the Azure security ecosystem, right? The Active Directory, Azure Sentinel, Azure Policy, the whole enchilada of offerings that we have in Azure ensure that the necessary security for all the workloads and most of the security threats that we went through in different sessions yesterday. We have gone through similar kind of exercise over the past decade, and we have brought all those learnings into our offerings for telcos. So we are discussing about what about privacy, what about high reliability, what about disaster recovery. So when we release any service in Azure, we go through what is called as a product release criteria, which contains 4 stringent requirements, right from security review to privacy review to disaster recovery options, and the APIs that we provide, the compatibility, the backward compatibility. All these are time tested and have been proven in the enterprise workload, and we are working, we brought the same technology for operators in our Azure Operator Nexus. So this is a sample blueprint for deploying 5G networks in the cloud. I'm not going to talk about each box in this slide, but this is essentially a blueprint for deploying 5G networks into Operator Nexus. As you can see, right, on the far edge, we have DU and CU. And if you will, you can move the CU and deploy it in the near edge, right? And similarly, some of the network functions can be migrated to a public cloud region if you want, right? And I also want to focus on the right side of this slide. It talks about all the various services and the PaaS offerings that Azure provides, which help maintain security, reliability, and performance, right? If you look at security and governance, we have this Microsoft Defender, and any service that we offer in Azure is via open APIs specification and REST APIs, right? And any resource that we expose for any customer to operate is based on ARM resource. And ARM stands for Azure Resource Manager. Azure Resource Manager enables operators to maintain inventory of all their resources. It enables RBAC, role-based access control. It also helps integrate with a variety of automation tools. And most importantly, it also allows the operator to enforce policies for governance. They can dictate what kind of users can bring in, can deploy what kind of workloads. And to ensure secure access to credentials, we have key vaults, and then Azure AD provides the identity management. And the most important feature of late with respect to the whole pipeline for AI/ML integration. We have Azure Data Lake, we have Synapse, Azure Data Explorer, and a series of pipelines to enable ISVs and operators to build AI ML based solutions and integrate them into their existing applications and deploy them through the standard Azure API models or Azure marketplaces, and leverage the ecosystem of Azure Monitor and Power and Logic Apps and Azure Operation Service Manager and Azure Operator Insights to get an end-to-end solution for their network needs. I'll go into a little bit of more detail into each of the features with respect to Azure Operator Nexus. What we do is we provide a simplified automated experience for the telcos. So everything is an API for us. So when I mentioned that we are able to bootstrap the NFV instance from dock to live, from cabling to actually ability to deploy NF workloads in a matter of 4 hours, the way we do it is we also ensure that we are also cognizant of the fact that we are operating and bootstrapping a remote device which is not directly connected in our data center network, right? So the process that we follow is we ensure that as the devices bootstrap, they bootstrap with the image which is stored in Azure. We connect to the devices directly over express route and then push the image that needs to be downloaded onto the compute servers as well as network devices, and then the device bootstrap, and once that bootstrap we have complete control over that particular stamp, and then we do all the automation necessary to create the required networking constructs for the workloads. For example, yesterday there was a question on how do you create the required network configuration for slicing, right? So we provide APIs which go and configure VLANs and routes on particular devices, and in a matter of a few minutes, we will be able to configure all the required devices to provide the connectivity, be it with respect to layer 2 connectivity, be it VLAN details, or BGP configuration, or BFD configuration, or ACLs, or route policies. We have abstracted all the complexity with respect to networking, and we are exposing simple set of REST APIs to enable telco operators to deploy their workloads and bring in their networks in a matter of hours rather than days, right? And of course, we have unified observability, all the metrics and logs pipelined into Azure, and you will be able to correlate them with the rest of the Azure resources. You will be able to correlate between metrics and logs from network device to metrics and logs from the compute server to metrics and logs from a network function, be it CNF or VNF, right? And we also have a pre-certification process where multiple NEPs test their workloads in our labs. We certify them for the use case. They have validated all the required configuration and scale, and telcos will have to just pick and choose and deploy them in their network. Of course, we have APIs to integrate to their existing OSS and BSS solutions. But I want to enforce the advantage with respect to the common platform as service and data fabric that we offer to telcos irrespective of where the workloads are deployed. They can be deployed at far edge or near edge or in Azure public cloud regions or Azure points of presence. You will get the same functionality. So here is the rich partner ecosystem that we have currently for Operator Nexus. We are working with a lot of system integrators, as well as we are pre-certifying network functions from NEP vendors, right? So I want to spend a few minutes describing our learnings, right? We have been working with a tier 1 telecom operator in US for more than a year and a half, and they have actually deployed our services in their data centers. And here are some of the highlights that I want to talk about, right? So we're able to remotely bootstrap Nexus instances from Azure regions in US. We're able to do it in a matter of 4 hours. Earlier, it used to take at least 3 months to bring up the entire stack and make the stack ready to deploy network functions. And not just that, the way we have defined our APIs, they are vendor device agnostic. We have multiple instances where we support multiple devices doing different kinds of operations. As of now, this particular operator has deployed 2 different SKUs with 2 different device models. 5 minutes? Done, okay, last time, thank you. And then we were able to deploy SMF network function in a matter of 45 minutes. Earlier, it used to take 3 days with MOPS, right? And this particular telco is onboarding 5G NFs from 7 different vendors, right? And we are able to integrate everything into Azure Monitor for Observability. Of course, we have our own set of learnings here, right? Through our journey with this particular telco operator, we had our learning. There was a request to actually have a detailed disconnected operations, ability to access network devices when connectivity to Azure is broken, even if it's for a short time. There was a specific ask with respect to providing an identity management solution in disconnected operation. For any reason, if the telco wants to log into the devices and then make changes to the devices, since all our devices bootstrap from cloud and have secure connectivity to the cloud, we couldn't provide the TACACS connectivity which they were used to. So we had to invent a new identity solution, again integrated with AD and FIDO2 to ensure that the required security needs are met. In addition to that, there are specific requirements with respect to monitoring that the telco was using, which integrate with the rest of their legacy monitoring solution. We integrated that into our solution, and we are providing all these offerings. So this has been a great journey so far, and we have brought the power of cloud to telco operators worldwide and enable them to deploy the network functions either on premises or in cloud with the same cloud scale capabilities. Thank you very much.
So the next topic of today's first session is challenges of 5G multi-edge computing by Mr. Saro. So 5G architecture offers flexibility to deploy the applications and functions in a distributed manner, and to meet certain requirements of certain use cases. But that offers certain challenges. Mr. Saro will discuss those challenges and what are the options, why, where to deploy, and then what are the challenges and possibly what are the mitigations. So welcome to you. Please.
Thank you, sir, for setting the stage. Good morning to all of you. Come on, I expect a lot more energy from this audience. Good morning. Superb. Are you all doing great? Yes. Had a great time during the networking dinner yesterday? Yes. Superb. I missed it, by the way, but I heard a lot of stories from the dinner yesterday. So in the next 45 minutes, I'm going to quickly walk you through some challenges related to deploying multi-access edge computing infrastructure in 5G networks. And some of you might have heard about MEC, some of you might not have heard about MEC. So what is MEC? Good old days, it used to be called as mobile edge compute. And with 5G, it has got a new name called as multi-access edge computing infrastructure. And for those of you who are old enough to understand some of the challenges that we had in 3G networks, those were the times when we were trying to improve the speed of our wireless networks, especially accessing web content from our mobile devices. That used to be a big thing, right? And during those times, we were exploring solutions like caching and WAN optimization. And these solutions were deployed in the core network. There is a term called GI LAN, right? So we were deploying the WAN optimization solution and caching solutions in the GI LAN to enable the speed of access of web content. And from there, when we switched to 4G, the problem shifted from web content to videos. Remember the YouTube buffering days? And one of the solutions that got deployed in some service provider networks to solve that problem is what is called as video transcoding. Again, the video transcoding solution, which will dynamically adapt the bitrate of the video that gets streamed to the user's mobile device. If you're accessing it from your mobile device, it will offer at a lower bitrate. If you are accessing it from your television, it will offer at a higher bitrate. So it dynamically adapts to the device from where the content gets accessed. And that solution was deployed again in the GI LAN in the core network. Now coming to 5G, the problem has grown multifold. Now, we are not just talking about web content or video streaming services, we are talking about applications like augmented reality, industrial Internet of Things, smart communities, holograms. There are several other services that are talked about in the context of 5G. So it's not just enough if you deploy the computing infrastructure or your storage infrastructure in the core of the network. You have to bring that infrastructure to the network edge. And that is what has happened in the last couple of years in terms of bringing compute, storage, and networking infrastructure closer to the users. And that's the role of MEC, multi-access edge computing infrastructure. You can run your own applications. It can be video streaming application, it can be a gaming application, it can be an extended reality application. So it can be any type of application that any developer can develop and host to closer to the users. So that's where MEC is used in 5G networks. Now, some of you might have heard about MEC and the potential of MEC. While service providers love to hype any new technology, right? When 5G was rolled out 4 or 5 years back, it had a lot of hype. And now we are hitting the reality. While common man thought that 5G is for increased speed on mobile devices, the area of focus for 5G is enterprises and industries, right? But probably it's our bad luck. The COVID struck and we went through an economic turmoil. So enterprises and industries were not in a pace to adopt or consume 5G services in the manner that we all expected, right? So there is a dip in that adoption of 5G. But 5G as in consumer services, many people have switched to 5G and they are seeing higher speeds on their mobile devices, right? So multi-access edge computing, there is a difference between the hype and the reality. It's still slow in terms of adoption. Large service providers are experimenting with it and there is not yet many commercially available services that are rolled out, right? So what makes MEC unique and complex? I did talk about the unique aspect of MEC, right? The variety of applications, heterogeneous applications. In the past, it was just web content or video streaming, but now we are talking about several other applications that are brought and deployed closer to the users. So the variety of the applications that get hosted on the infrastructure makes it very complicated, right? Because see, some applications may be bandwidth sensitive, a few applications may be latency sensitive, and a few other applications may be sensitive to both bandwidth and latency, right? Your infrastructure has to adapt to the needs of these applications, and that is where it becomes very complicated. Then performance requirements. Now, what is the performance requirement of 5G? Less than 10 milliseconds, right? So you need to achieve that less than 10 milliseconds target by deploying edge computing infrastructure in multiple locations in the service provider network. I'll be talking about that in the subsequent slides. So there are some performance requirements attached to 5G, and MEC helps in meeting those performance targets. Then management and orchestration. All of you are familiar with downloading apps from the App Store and loading it onto your mobile device. It's so easy, right? It has become very convenient thanks to Steve Jobs, who brought in this App Store concept, and we all are used to now loading apps onto our mobile devices. But let's shift the context to the service provider side. The service providers started their journey towards softwarizing their network, right? probably some 7-8 years back. And the problem at hand at that time was getting some virtual network functions from a couple of dozen OEMs, testing, validating, and then making it available on cloud environments so that network services can be delivered on top of those virtual network functions. That was simple enough, right? Couple of dozen OEMs and a few hundred virtual network functions. We have not solved that problem completely yet, right? While now talk about MEC and the type of applications that we are going to host on top of MEC, there's going to be several hundreds and thousands of application developers. That's the North Star and the goal that we all have from the communication industry, right? We want to have a lot of developers develop network-oriented applications, that can leverage the capabilities of the network. And Uma Magesh talked about exposing functions via APIs. Some of these applications can consume those services via APIs and dynamically provision and activate those services on the network infrastructure, right? So you're talking about several thousands of developers and potentially several lakhs of applications and millions of consumers consuming it. But the model is quite different from what happened in the virtual network functions era. In the virtual network functions era, there was still manual work. There were still bodies who were testing these apps, certifying them, and then rolling it out to the users. But we are talking about an era where everything is completely automated. That's where the nightmare for manageability and orchestration comes in. Because if you have to create an ecosystem where it all is completely automated so that the services work like clockwork, you can imagine how long it's going to take for us, right? So that is another complexity of rolling out apps on MEC. Then installation locations. The mini data centers the MEC can be visualized like mini data centers. These mini data centers have to be deployed in several locations, probably one in BMS Engineering College, one near that lamppost outside of the college. So there are several locations that the service providers have to acquire and make power, cooling, all of these services, electricity, that meets the expectations of these high performance servers or low performance servers, right? So made available in several locations. So that is another challenge. Then security, a subject that is near and dear to all of us in this conference, right? So security is a nightmare. Touch any topic, security creates a lot of nightmare. And yesterday, I remember Mr. Narendranath said, security should not be viewed as a separate requirement. It has to be dealt with like a functional requirement. It should not be looked at as a non-functional requirement, right? So coming from a development background, I always looked at security as a NFR, non-functional requirement. We implement all the functionality and then we'll be challenged by somebody saying, oh, have you taken care of the security aspects, right? So that problem also has to be addressed in the case of MEC because you are allowing multiple developers to deploy their apps and make it available for the customers of the service providers without somebody manually verifying all of those, right? So that increases the challenges for MEC. Now, I'm going to quickly deep dive into 4 challenges in the next half an hour or so. And then probably if you have more questions, we can cover that later on, right? So the biggest challenge for service providers in rolling out MEC infrastructure is costs. And you might have seen the story even in India, right? Service providers are not sitting in cash piles like the Apples and the Googles of the world. They are almost getting to in fact, we did have a service provider who was almost close to bankruptcy. So that's the state of affairs in the service providers. But this is a study done by GSMA and in 2019, and they thought rolling out MEC infrastructure by the service providers, it's going to consume a lot of CapEx cost. If they are putting the MEC infrastructure on the edge of the network, it's going to consume like close to 74% of their CapEx. If they have to put a MEC in every single cell site, right? And it's going to consume 3% of their CapEx if they are putting that in their aggregation points. And less than like 0.01% of the CapEx if they are putting it in the operator core, right? So that's a study that they said and that they have conducted. To give you some numbers, how much does it cost to roll out a cell site? It costs anywhere from $250,000 to $1.2 million. Depends on several factors, right? Size and form factor, which vendor, and all of that. And the cost of rolling out a MEC infrastructure in a cell site can range anywhere from 10,000 US dollars to all the way to 250,000 US dollars. So service providers, first of all, don't have a lot of cash, and it's still, the ROI for the investment on MEC is still not established, right? And there are several other challenges. So let's see what service providers have decided. So you might have seen stories of service providers partnering with the cloud service providers and rolling out MEC infrastructure. So it's a win-win game. For service providers, they are able to provide that infrastructure so that they can create new use cases, create new applications and services. And for cloud service providers, they are getting into a new vertical where, because enterprise workload migration to the cloud, people are all used to it and it's an existing business. So for cloud service providers, the incentive now is to open this infrastructure for edge computing and allow many other applications to be hosted on that infrastructure, right? So be it Verizon or AT&T or T-Mobile, they're all partnering with the cloud service providers to roll out the infrastructure, primarily to save costs. They don't have the money to spend, and but at the same time, there is a business need for MEC infrastructure. So, and by partnering with the cloud service providers, it's a win-win game. Right? The second challenge is the latency challenge. In fact, this is a challenge that is near and dear to a lot of technical people, because the latency of access is very important for applications that are running on 5G. Yesterday, you heard about a lot of stories about how URLLC is very important for 5G and all that. So latency is a very critical parameter. Now, talking about latency, depending upon where you are deploying the edge computing infrastructure, the latency will be quite different, right? For cloud, I've said 20 plus milliseconds, but it's typically 50 milliseconds or even more, right, if you're accessing something from the cloud. And all the way to the left-hand side, where if you are putting a edge computing infrastructure on the cell site, it will help you to achieve 5 milliseconds latency. Now, there are certain applications that require 1 millisecond latency. How do you handle that? So there are two solutions. One, they call what is called as on-prem edge. On-prem edge, visualize a smart community or an industrial, a manufacturing plant. You can put an edge computing infrastructure on that private wireless network within that plant or within that smart community. That's called as on-prem edge. And there is another category of edge computing infrastructure called as on-device edge. Now that will be hard to visualize, right? On-device edge. What is on-device edge? Imagine a smart car or an autonomous car that is going around in the streets, right? Which is happening actually in US at this point in time. You can put an edge computing infrastructure within the car so that the car can quickly make those smart decisions, right? Whether the object that is moving on the road is a human or it's a vehicle, so it can differentiate. It can make those quick decisions by processing the feeds that it is extracting from the cameras that are present all over the smart cars, right? So such decisions can be made by deploying edge computing infrastructure on the device, right? In this case, it's an autonomous car, right? So you can push it to less than 1 millisecond by leveraging these two options. Now, latency is a challenge, and how are we solving it, right? So the cloud service providers offer multiple forms of their computing infrastructure. So take, for example, Uma Magesh talked a lot about Nexus platform and its hybrid, and I have few examples from Amazon. If you look at the offerings from Amazon for cloud edge computing, they have 3 distinct services for hosting 5G applications near to the users. Number 1, it's called as local zones. Local zones are extensions of their regional data centers that are hosted in communities, right? Imagine a smart community or within cities. These data centers typically are in remote locations. For example, in India, there may be data centers concentrated in Mumbai, Delhi, Chennai, Calcutta, right? Like very few zones. But I'm talking about these local zones that are brought closer and deployed within metro areas and closer to people. So that's local zones. That's one location where you can host your edge computing applications. Then this obviously is closer to the core, but not within the service provider environment. The second option is AWS Wavelength. And AWS Wavelength is deployed within the service provider environment, and which means it's close enough to the core, right? So that's an offering where the service provider has to bless this deployment because it's deployed within the service provider premise. And then comes the AWS Outposts. The AWS Outposts are almost like on-prem. Okay? You can deploy it in your private 5G wireless network or in your industry or within your enterprise to host your own applications, right? So these are the different flavors of offerings that come from service providers, cloud service providers, to address the latency challenge. Now, to complement this, the telcos will also have their own version of the cloud infrastructure, which they may position for enterprises or customers who are storing sensitive data, who doesn't want to deal with the public cloud service providers also at all, right? So for example, there are offerings from Ericsson, Nokia, Dell for edge computing infrastructure, which are customized for deploying in private wireless networks, which may be an additional option to handle both latency as well as some of the privacy and security related challenges. The third challenge is manageability. I already set the stage for the manageability challenge, right? Few thousands of developers developing several hundreds of thousands of applications accessed by millions of users. That's a problem. And the requirement is you have to automate the complete end-to-end workflow. The solution is DevOps. Have you heard of DevOps? Multiple times even Mr. Uma Mahesh talked about DevOps. So it's not easy to achieve the DevOps adoption, right? It's not easy at all. In fact, even for virtual network functions, some service providers claim that they have a, for example, in Verizon, we were trying to create a marketplace. A marketplace is where OEMs will come and upload their virtual network functions, and the marketplace will take those virtual network functions, do automated testing, and once the test is done and we are all happy with the outcome, then the virtual network function gets automatically pushed to customers for hosting their services. In fact, some of you might have heard about this service called SD-WAN, Software Defined WAN. So Software Defined WAN is providing WAN connectivity solutions to enterprise customers, and that's an offering from service providers. So we were piloting this for SD-WAN type of offering because if you have familiarity on SD-WAN, SD-WAN allows you to change a Cisco firewall to a Palo Alto firewall on the fly. Right now, in the enterprise case, you have to buy a Cisco firewall, and if you want to replace it, you have to throw away that hardware and bring in hardware from Palo Alto, right? That's how you replace your firewall. Whereas when you go for software-defined WAN, you can change a Cisco firewall to a Palo Alto firewall on the fly through a couple of clicks. Now, in addition, if Palo Alto rolls out a new rev of their firewall software, how do you do that? Because the new rev has to be pushed to all the enterprises who are using your SD-WAN services, right? So that was the type of automation that we were trying to do in Verizon, and we have, to some extent, 70–80% of that workflow is automated, right? It's still not complete upload to make it available completely automated. It's not there. But imagine we have to solve the very same problem for the apps that are hosted on edge computing infrastructure. So DevOps is a solution. Some aspects of publishing the apps, validating, at least doing some security related testing and ensuring that it's an authentic app, it does the functionality, it doesn't break anything, that can be automated. But can I make my network functions accessible by these apps without doing manual verification or without ensuring that it has any privacy related compromises that the application will make? So we have not, that's a big question, right? But DevOps gives us some hopes of automating this pipeline and reducing the nightmare of manageability of these applications. I'm not saying it will completely eliminate, it will reduce the nightmare that the manageability challenge brings in. The last aspect is security. Okay? I'll spend a little more time on this topic because I know many of you are interested in this topic, right? So MEC security, it's no different from the security challenge that we have with other network functions. But remember, the MEC infrastructure gets deployed closer to the users. So if somebody wants to walk away with this mini data center infrastructure, they can really do. They can break the locks, they can take away this infrastructure, right? So you need to focus on the physical security aspects also, not just the software or the network-oriented security. So that is one of the challenges in the case of MEC infrastructure. Then comes application or infrastructure related security, which is in the morning we were having very interesting conversations on how do you protect your data from getting compromised from other virtual network functions that are running on the same cloud environment. Now that problem goes up by 10x or even 100x when you're talking about MEC, because in an MEC environment anybody can run their own applications, right? So application and infrastructure protection is a big thing. You need to ensure that the right application is also loaded. Somebody cannot push an application, for example, a gaming application, which is a spoofed version, which is hijacking data from the users or stealing data from the users, right? So you need to verify the authenticity of the applications that are running on top of the infrastructure. So that brings in a bigger challenge because somebody can spoof and push. I mean, in the world of artificial intelligence, anybody can spoof anything, right? So that brings an additional security challenge. Then data protection challenge, we all have discussed about this in the past. So that exists in MEC also. But the difference in the case of data protection is, in the case of storing data within your private data centers, still you are having the infrastructure within your prem. Somebody cannot like walk in, put a USB stick, and then change the data or download all the data, right? Imagine MEC infrastructure that is hosted on public environments. Somebody can come with a hard drive or a laptop or a pen drive and they can steal sensitive data, right? So data protection problem again gets a new dimension in the MEC world. Then user access protection, who can access which application, right? Because there may be paid enterprise users of service providers who would want to access certain application. There may be other applications that are available for everyone like us, right? So different types of applications are hosted on MEC. Not only that, have you heard of an application where you can run virtual network functions also on the MEC cloud? Some of you who are near and dear to 5G would have heard about the ability to host, for example, the VDUs, right? Virtualized your distributed units when you are doing RAN virtualization. Some of those components can run on the MEC infrastructure. And you have to ensure that that is protected from the other applications that are running on the same infrastructure, right? So who accesses what? Then comes the network protections, right? In fact, morning while we are having a discussion with Uma Magesh was saying it's our 5G infrastructure offers MPLS-like protection. And Mr. Krishnan was saying, oh, what if MPLS was compromised, right? So we are dealing with a very tough audience, I guess. It's very hard to convince them on foolproof security, right? Obviously, there will be gaps and exposures in the infrastructure, but network does provide a lot of opportunities for people to access sensitive data and applications, right? So network protection is another challenge. The solution is zero trust. Now everything has become zero trust, right? Nobody trusts you, including your own family members. That is the stage we are currently in, and MEC infrastructure is no different. And service providers are leaning towards putting in zero trust mechanisms on the infrastructure that is hosted or made available for MEC, right? So the physical security and surveillance is must in the case of MEC, because you are putting them in public location. There has to be cages, there has to be locks, and not only that, there has to be a surveillance camera and all that, right? So that is a must to ensure that the device is protected. Nobody walks away with the device. And the second aspect is trusted platform modules. Remember I talked about application related security issues, ensuring that the right application is running on the cloud environment. So you have a new capability called trusted platform modules, TPMs in short. And the role of TPMs is, it's similar to HTTPS. For those of you who have paid close attention to HTTPS, you see that lock icon on your browser. And what is the role of the lock icon? The lock icon says a certifying authority has validated the genuineness of this website. If you are accessing hdfcbank.com, this content is served by hdfcbank.com, right? That's what that lock icon means. So if there is a lock icon, then it means the content is coming from the right entity, a genuine entity, right? So a similar mechanism is made available for applications that are hosted on MEC infrastructure, and that's called as trusted platform module. You can digitally sign this image, the application that you're running, you can digitally sign it, and the keys are stored in the cloud infrastructure so that when somebody pushes the image into the cloud infrastructure, they can validate the genuineness of or the authenticity of the application that is running on the cloud, right? So it's very similar to having a central authority who will ensure that it's a certified instance of the application and it can be allowed to run on the MEC infrastructure. Then data encryption, this is something that we all are familiar with, and there is nothing new that is getting introduced in the case of MEC, but the data, whatever you store on MEC has to be encrypted. In the past, sensitive data is encrypted, non-sensitive data is not encrypted and all of that, but when it comes to MEC, whatever you store in that infrastructure has to be encrypted because it is there in the public domain. Multi-factor user authentication, right? So again, it's all part of zero trust, which means you may be giving your username and password to access a service. That doesn't mean that you are accessing that service, right? So how can I ensure that you are accessing that service though you give a valid username and password? Which means the device from where you are accessing it has to be yours, and you are the one who are like using that device on that particular day to access the service using your own username and password, right? So that's what is the role of multi-factor user authentication. Today we have a mix and match of several techniques that are being used. One-time password is a very common thing that's used by many services today. But you have fingerprint recognition, facial recognition, iris scanner. There are multiple methods by which users can be authenticated beyond the traditional username and password based approaches, right? So especially for enterprise grade services, multi-factor authentication enablement is a must to allow access to enterprise grade services. What do I mean by enterprise grade services? You are deploying a private wireless network in a manufacturing plant, and you are hosting certain applications on top of it, and you are allowing the people from within the plant to access it, and you are also allowing people from probably their corporate office to access some of the services. So you are validating every single access, and Uma Magesh talked about role-based access control, right? So you are exposing the right level of data to the right recipient. Then network segmentation and secure tunnels. So network segmentation. Now, people who are close enough to security and networking, you will know that with MEC, you are increasing the attack surface. You are increasing the attack surface, right? Because there are so many points from where you can gain entry to the service provider network. The MEC infrastructure is owned and operated by the service provider. So there are so many entry points into the network now, which creates additional management challenges for the service providers, right? So network segmentation means you can partition your network and make these services hosted separately in a separate network domain so that you are reducing the impact of security breaches. For example, even if MEC infrastructure is compromised in one location, then the problem is contained to that particular location versus the person getting access to all the other MEC infrastructure or even some of the VNFs that are hosted in your 5G core, right? So That is what is achieved through network segmentation. And then using secure tunnels, because you are dealing with apps that are created by several hundreds of users or even thousands of users, certain traffic has to be routed to different enterprise, right? For example, if Google is making some of the apps that are hosted in MEC, then for example, Google Meet type of application, right? Video conferencing type of application. They would want to get analytics back into their data center so that they can run these complex algorithms that process those analytical data and derive insights, right? So in order to do that, you set up secure tunnels with the different enterprises that are publishing these apps so that they have a mechanism to collect data. They have a mechanism to even program the QoS for these applications. So in 5G, you can dynamically modify the behavior of these apps, the amount of resources that these apps are consuming from the network. So those can be programmatically controlled. So those can be programmatically controlled by the enterprises who are hosting those applications, right? So using a secure tunnel with the enterprises, you are able to allow those interactions and exchanges happening between the apps and their management systems. So these are some ways in which the security challenges are being handled, right? So physical security, trusted platform modules, data protection, multi-factor authentication, and having network segmentation and network tunnels. And this is very evolving. I'm giving you a snapshot of where it exists today, but it's a very rapidly evolving field. And like I said, when we get to a stage where a lot more commercial grade applications become available on MEC, you will see many more, we will learn about many more challenges, and we'll obviously come up with newer solutions to address those challenges, right? So with that, I want to summarize saying the top 4 challenges can be addressed by having a hybrid MEC platform. What do I mean by hybrid? Partly funded by service providers and partly funded by the cloud service providers so that you can achieve the scale that we are all envisioning. Then having MEC deployed in multiple locations of the network, right? Be it edge, aggregation, transport network, or to the core in multiple locations so that you can meet the latency and performance requirements of the different applications. Then use DevOps concepts for automating the entire workflow, right, to achieve the scale of operation. This probably 10 years from now, I'll be standing here and talking about the same problem, but I'm hoping we would have solved at least 80% of the problem there, right? We would not have still achieved the 100% automation status in terms of pushing apps, making it available on the fly, and managing all of them without any human intervention, right? And zero trust framework to improve security, right? So those are the areas of focus in terms of handling the security challenges related to MEC infrastructure. Thank you, and I return control back to Mr. Rajesh.
Thank you, Mr. Sadhu. Hello, thank you. So both the speakers gave a very practical insight on how these 5G functions as well as the applications are getting deployed and what would be the landscape of these deployments. This also, I mean, there are important takeaways for even for that our NCCS DOT to align that our security requirements and that framework considering that how these deployments are going to take place, moving from the standalone deployments to this distributed deployments, distributed computing, and all those things. So now floor is open for questions and answers.
I can ask. So this question is to Mr. Uma Mahesh, sir. And I want to know, you definitely have implemented so many security features, but how do you give assurance? I mean, through assurance, you have to give through any certifications or auditing, right? And you can't tell these features are implemented. But how do you give assurance to your customer that they are really being implemented in an effective way?
So it's, as I mentioned in one of the slides, we have close to 90 plus compliances to standards, right? And assurance is one of them. So just to reiterate the point, right? So most of the challenges that we have seen or gone through, right, are exactly the same set of challenges that we in Azure went through with respect to enterprises, be it financial, be it government, be it defense, banking, all these compliance requirements, GDPR, security, assurances, all these are something where we have precedence of implementing them in Azure over the years.
Sir, what I was looking for, like sorting those like empaneled, right? I know Microsoft Azure also one of the empaneled, I mean GCP cloud providers. Like that, do you have any other certifications from, let's say, outside of India? Like INSA also have some scheme for cloud
Yeah.
providers.
I
That is
can,
what
I
I'm
can
looking
provide
for.
the list offline of the 90 that I mentioned in the slide.
Oh, sure. Okay, thanks. And sir, one more question to Valedictory, sir, regarding MEC. So yes, here, sir. Yeah. Okay. So, like to MEC evolving topic, I mean, so I want to know whether MEC has been deployed anywhere. I mean, let's say, US or somewhere like any, or how they have deployed, what deployment model in there.
So MEC infrastructure is deployed today, and I showed you some snapshots of Verizon, T-Mobile, and AT&T partnering with cloud service providers to deploy the MEC infrastructure. Right now, the focus is private wireless network because that's where the real money is. And they are not, though there is experimentation in terms of allowing gaming companies and video streaming companies to host their applications on this infrastructure. But the real money sits in the private wireless network, and that's what the service providers are chasing by partnering with the cloud service providers.
Sir, I was curious to know when in MEC, let's say whatever already deployed, whether they deployed at the edge or the data center located in the central location or where, that is what?
It's deployed on the edge.
Deployed on the
deployed
edge.
on the edge.
Okay. Thank you.
Good morning. And first of all, congratulations for a very excellent presentations by both the speakers. My question is to Mr. Saro. See, you said that security is really a challenge, and authentication or authorizations of the users has to happen at the edge. But normally, the user credentials, etc., they are stored at a central location. So is that responsibility of storing the user credentials at a central location also get shifted to the MEC platform, or it still continues to be at the center and there is an interaction from the MEC to a central location while doing the user authentication and authorizations?
So if your question is on the database where the user credentials or the user profile, subscriber profiles and all of that is maintained, that will continue to be in the central location. Okay. That's not going to be disturbed because it's shared by many other services and applications, right? So these applications that are hosted on the MEC will do a handshake, validate the subscriber or the user who is accessing the services before providing them access to the service.
Thank you.
Thanks.
So this is actually, in my slide, I couldn't get time to elaborate on that, right? We had an ask from one of the telcos to provide disconnected authentication, right? And that's where we solve this problem by using Azure AD and copying the public keys from Azure to the devices and providing FIDO2 authentication in an offline way, right? So disconnected authentication without replicating the identity on the whole in the local edge is a challenge that we had, and we were able to solve it with this solution.
So here is, this is pronouncing from academia. Sir, I have two questions from Umesh. One is there any, a lot of discussion is going on because eSIM provisioning platform should be in cloud or something else. So do you have any certain of information that eSIM cloud, SMSR, SMTP, SMTP Plus are residing in the cloud in the USA or something?
So as a platform, right, as I mentioned, it's a busy slide that I put in there, right?
Okay.
On the number of functions that can be migrated from far edge to near edge and some from near edge to cloud, right? That we leave it to the operator, and there are different telcos who are experimenting with different kind of options of deployment.
Okay. And the second question is regarding the bootstrapping procedure you are talking about in the device.
Yep.
So it is based on the PKI infra with certified virtual identity, something like that, that is creating the device?
So, okay. What we do is, with respect to the device bootstrap, right? We ensure that we have an initial connectivity to the device
Okay.
with our secure connectivity, and then we get the initial password, right? And once we get the password, right? And today it's password, tomorrow it can be certificate, but password is much easier because it's set by the value-added reseller, and then we connect to the device through that what we call as out-of-band channel, right? Once we establish the out-of-band channel, it's completely onto us, and we can bring in whatever security mechanism or whatever mechanism to actually provide certificates onto the devices to ensure that subsequent access is only through a desired mechanism and not through the initial out-of-band mechanism.
Okay, this means chain of trust is initiated from the device to the platform.
Yes.
Okay, okay, thank you, sir.
Hello. So I have a question for sir. Good morning, sir. That was a very insightful session you given to us. So you were talking about the remote data center is something far away to access the data and to achieve the latency. Then you talked about this edge data server, but premises server data, something you were talking about, how that we can be achieved with 5G network, sir? Can you explain little in depth?
Okay. So when I say on-prem infrastructure, you have to imagine an industrial setting, right? A factory where there are a lot of autonomous vehicles that are moving goods from one place to another, or finished products from one place to another, or there are prototypes where you can also do quality assurance in real time using machines. For example, by taking a video capture of the finished product, it can be analyzed in real time, and if there is a malformed product, it will be removed from the conveyor belt by the robots on their own. No manual intervention at all in ensuring that the quality checks are performed on the finished product, right? So these type of use cases require less than 1 millisecond latency, which means when the camera sees a product that is malformed, that is going in the conveyor belt, the robotic arm has to instantly pick that and move it off the conveyor belt, right? So sub-millisecond type of latency. And that is where on-prem MEC infrastructure will really help, because the movement of video stream from the camera to the edge infrastructure and the response back from the edge infrastructure to the robotic arm, so that the robotic arm can pick that product and move it outside of the conveyor belt. So all that is possible only if you host the infrastructure on-prem. So that is the context for an on-prem edge infrastructure. So it's not like homes. It may not even be for enterprises, right? A regular enterprise.
Thank you, sir. Thank you so much.
So one online question from Mr. Mahesh. May I know what open API standards are being used to provision and operate Azure Operator Nexus?
So we have published a managed network fabric REST API specification. It's publicly available, documented on Azure. You can search for it. And we have all the details with respect to the APIs and the syntax and the examples there. Managed network fabric, Azure API specification.
Good. Well, Rajan, I am Venkatramaraj Chelle. I would like to know the two aspects of the MEC. One is the commercialization. When you see the network mobile operators and 2.5G and 3G, many have come with a revenue sharing model, the servers for ring back, many other services. Tomorrow is the Edge's MEC is going to bigger role for telecom networks, and it is either 5G advanced or maybe 6G. It is the main player for the telecom network, the major player. So, how you think? Are you going the path of revenue sharing model for commercialization of and the deployment of speed faster way because of revenue crunch and other prospects which are not ensured that the realization of revenue? That is more important for which you are not seen in 5G. The operators are really finding trusting revenue. The second point is security prospectors. SK Telecom Korea has implemented the many quantum applications like PQC under the chip-based QKD and other. Do you have seen anywhere such applications, any other telecom network, or you have anything thinking about the introduction of the quantum survey applications in MEC?
Okay. So I'll answer the second one. It's straightforward. No use of quantum computing technology in the telecom at all. And even on the OTT side, right, the Googles of the world, they have still not completely commercialized quantum technology for services, right? They are still in experimentation stage because it's still fault prone, right? Talking about the first question, right, in terms of revenue sharing, you mentioned 5G advanced, 6G and all of that. These are all, at least 6G is 10 years away, considering the traction that we have with 5G. 5G advanced probably happen in a few years. Every 5 years, there is a dramatic change in the investment cycle as well as the type of applications and services that gets rolled out to users, right? So right now, it's all done in a revenue sharing mode. Will things change when there is a killer app for 5G when it gets discovered? Will the commercials change? Will the deployment model change? The answer is yes, right? Remember Ericsson's of the world and Nokia's of the world who are already supplying infrastructure to the service provider. They do have an MEC offering. They do have an MEC edge platform that can be deployed to create a service provider installed and operated MEC environment. So that's still there. But it's not deployed in large scale because of the budget constraints that the service providers are dealing with.
So last question from Senate, sir.
My question is to Mr. Uma Mahesh. See, when the cloud deployment is done, you talked about APIs which will, to a great extent, limit the interaction between the infrastructure and the application. But within the infrastructure also, there are different layers, hardware, virtualization, and then the applications. Are there any steps which have been taken to limit the interaction at each level? And is there any mechanism to check those things?
So each level we have APIs, right? For example,
Right from COTS onwards.
right from the terminal server to the network device, to the server, to the API, the OS layer, to the Kubernetes layer, to the end application layer. And each one comes with its own role-based access control and privileges, right? So it is the reason we are able to actually bring up that cloud instance I mentioned in a matter of 4 hours and then deploy an SMF in a matter of 15 minutes is because everything is an API. It's a question of seriously executing one API after the other. And then right from downloading, and this includes downloading the image from Azure onto the devices, right? Everything is API driven. Because without APIs, we can't scale to the level we plan to scale.
Now, basically, we have come up with ITSARs for our NFV. There we tried to address these issues, how we harden each interaction between each of these levels. I request you to have a look at it and then give us some feedback in case if we need to look at, we need to have a fresh look at it, we can still do it.
Sure.
Thank you.
In fact, if I may add to that, again, this is from the experience at least 5-6 years ago when we were certifying VNFs for cloud service providers and also rolling it out on the cloud. Hardware vendors like Intel do offer capabilities through which you can pin an application to specific tenant instances and you cannot run that application on any other hardware instance or any other tenant, right? So, because on the software level, it is all easy to visualize the APIs, and you can ensure that the right application is accessed by the right service and all that. But at the hardware level also, hardware vendors do provide capabilities that validate the authenticity of these applications that are hosted on that particular hardware instance. So that's an area where I'm sure that area would have emerged further in the last 5-6 years. But we did have something from Intel at that time itself. Thank you.
Okay.
Thank you so much for that very interesting session. We are just in time for our tea break. So I'll request our moderator, Rajesh Kumarji, to please give away mementos to our speakers. Thank you so much, Mr. Uma Mahesh, sir, please. Sarvananji, please. Shall we take a group picture, sir, please? Yeah. Thank you so much for that very insightful session and your valuable time here with us today. Thank you, sir, for moderating that for us. We'll break for tea now, and we'll see you back at 11:15 for our next session. Maybe 2-3 minutes here and there because it's 11:08 already. So let's do a 10 minutes tea break, and we'll see you back in 10 minutes. I want to request everyone to please visit the exhibition area. They have some really nice products and solutions for you, which you must not miss. So please visit the exhibition area throughout the day. Whenever you get time, please spend some time there. Thank you. Break was refreshing and you're ready for some more knowledge. I'd like to invite for our next session our moderator, Sri R. Babu Srinivas Kumar, Director, SAS2 NCCS. He's a 96 batch of Indian Telecommunication Services Officer with 25 years of industry experience in various telecommunication fields. He holds master's degree in engineering besides security. He was instrumental in drafting security standards for SIM cards, 4G PGW, telecom transmission terminal equipment, 5G core network functions, network function virtualization, cell broadcasting center, and currently he is working on IoT security standards. Welcome, sir. May I request Sri Manas Kumar Panda to please hand over a bouquet and welcome, sir. I'd like to introduce and invite our speakers. We have Professor Chester Ribeiro, IITM. He's an associate professor of the Indian Institute of Technology, Madras. Prior to this, he was a postdoctoral researcher at Columbia University. He has a PhD from IIT Kharagpur in the area of hardware security. His area of interest includes security aspects in the operating system, architecture, and VLSI. He is particularly interested in applying learning algorithms and formal methods to analyze the security of systems. Welcome, sir. Also joining us in the session is Shri Sanjeev Dhalam, an ICT professional with 23 plus years of wide-ranging experience of telecom industry with various perspective of technology, both from strategic and execution level. Currently, he is heading design, planning and delivery of core networks and telecom network security across all lines of business of Airtel. The key expertise includes security risk assessments, defining security roadmap, SOC operations, threat intelligence and hunting, conducting governance and compliance management, network transformation, network design and planning, managed services, NFV, SDN, 5G, LTVS. Welcome, sir. Dr. Mukesh Taneja, who works as a Vice President at Mavanir, Bangalore. In his role, he leads the various ORAN-related systems engineering activities for 5G, 4G products. He has been in the industry for 26 plus years and has worked in the areas such as cellular systems, 5G, 4G, 3G, 2G, 802.11, AXACAH, IIoT, LPWA, IP, MPLS, and data science. He has represented in his company in 3GPP, IEEE 802, 1M2M, and some other standardization groups. He has authored 60 plus patent applications and research papers, received his PhD from the University of California, San Diego in 98. He also completed the Executive General Management Program from IIM Bangalore. He is a senior member IEEE and continues to engage with IEEE activities. Welcome. And with this, I'll hand it over to our moderator. Sir, please.
Thank you, ma'am. Good morning to all. Yeah, there are three topics lined up this session. The first one is about security challenges of cards and possible solution by Professor Chester Ribeiro. So, I remember in olden days, when 10, 20 years back, the telecommunication network functions are implemented in some kind of custom-built or purpose-built hardware. So the NEP will give you the hardware, you will take care of OS and the application also. So it's some kind of monolithic design. But what happened after some time, some of the telecom-related performance requirements demand something like ATCA type of architecture, advanced telecommunication computing architecture. Then what happened is that the operators, they are looking for the ways to cut down the cost. They saw the success of NFV from the IT industry. They borrowed that concept and it became the network function virtualization. So here, the fundamental thing is COTS hardware. So we have seen a lot of vulnerabilities, 16 and 17, something like meltdown or Spectre kind of attacks, Spectre kind of vulnerabilities that were present in the Intel and every chip. So Professor Chester Barrow, he will talk about the security challenges in the COTS hardware. In fact, there are so many ongoing projects in IIT Madras, especially related to the embedded hardware. So, Professor will talk all those things. So, over to you, Professor.
Yeah, good morning, everyone. Thanks to BSK Sir for introducing me. It's a pleasure to be here. So I would be speaking about security challenges of COTS and possible solutions. Right. So if you look at Wikipedia, so what they define COTS as ready-made hardware or software that is easily pluggable and adaptable by purchasing organizations. Right, and there are several advantages of this. For instance, COTS, with the use of COTS, as was mentioned, it reduces costs quite drastically. So now you don't need to essentially go with a monolithic kind of design. You don't need to build everything in-house. You can just purchase. And for those of you who are working in government organizations, the only challenge would be to navigate through the GEM portal. But then you can essentially purchase this and install it, configure it quite easily for your specific application. Right, so low cost, quick deployment, but also COTS would come with a lot of other features, like for instance, the support that you actually obtain. For instance, if you actually purchase a hardware firewall, then continuously you would be getting updates, you would be getting support from the OEMs for that particular hardware. And also it's easier to find expertise. So if you purchase COTS, you are not the only organization which is purchasing the COTS hardware, but the same hardware would be essentially utilized by many others. And therefore, if you want people who can actually use that specific hardware, it's more easy to essentially find, right? So developing your system over COTS hardware or COTS devices has a lot of advantages, but it also comes with a disadvantage. And the disadvantage is that it also opens up security threats, some of which are essentially unique to COTS devices. Right? So what are these security threats? And this is what we are essentially look at in this talk. So at a very high level, right? So if you look at any COTS device and you look at the stack, the compute stack of that device, you have hardware and then you have software. The software comprises of the system software such as the operating system, the hypervisor. It could also be a simple hardware abstraction layer, and then you would have applications on top. So each of these layers could possibly create different security threats. So you'd have hardware security threats arising from the hardware, and then software security threats. Now, in each of these layers, whether it's software or hardware, the type of threats could be either accidental or deliberate. Right? So we have accidental software threats. We also have threats which are deliberately introduced into devices at the software, and the same for the hardware as well. So in this talk, we'll be essentially looking at these four things: accidental, deliberate software threats, accidental and deliberate hardware threats, right? And we'll essentially see possible ways these challenges or these threats can be identified and detected, right? I'll also reiterate over here that we are IIT Madras as such is very closely associated with NCS, trying to build up frameworks to validate COTS devices for these different threats, especially in the software threats. But we also have a research unit where we have PhD students and master students who work on blue sky research, looking at how to enhance these enhance the security evaluations of COTS devices. So in this talk, I'll briefly talk about these research activities in IIT Madras as well. So to start off with, we will look at software threats, and then go to the hardware threats, right? So we'll start with the accidental software threats and then go to the deliberate software threats. So the accidental software threats are those which are essentially introduced unintentionally. So you have users who are developing software, and as we know, with software comes a lot of vulnerabilities that may be introduced, like memory vulnerabilities or wrong use of crypto algorithms or access policies or many such things like that. So these fall under the category of software vulnerabilities, right? So with each software that you develop, unintentionally you may essentially introduce some bugs which may result in these vulnerabilities, which may at a later point be exploited. And there are several such databases, like you have CVEs, you have open source vulnerabilities, you have NVDs. So these are essentially databases which keep track of these various vulnerabilities in various applications. So anyone working in cybersecurity, looking at vulnerabilities, would be aware of these databases. And any software that you are purchasing, any COTS software that you are essentially developing, would need to be validated against these databases. Now the challenge here is the 0 days. Like as defined and as well understood, 0 days comprise of those vulnerabilities which have not yet been discovered. And here is where the threat essentially lies. Because in my COTS device, if there is a 0 day, I do not know about it, and this 0 day this vulnerability could have been available for several years, and at any time it could be utilized by an attacker to maybe compromise the entire device. So the challenge with software vulnerabilities that are accidentally introduced is mostly with the 0 days, right? So specifically for COTS devices, the threat of software vulnerabilities is far more amplified, right, compared to your monolithic software or built in-house developed software. And the reason for this is the aspect of transparency and the homogeneity of COTS attacks on these specific devices, right? Another aspect with respect to COTS is the aspect of liability. So in many cases, not all, but in many cases, there's little or no liability to the developer of the COTS hardware, right? So for instance, going back to the Stuxnet problem, the biggest losers were the Iranian nuclear plant. The attack actually affected Siemens and possibly Microsoft as well to a much lesser extent, right? So the onus of security laid on the end user and not the COTS developers, right? And in many cases, there are also the aspect of certification. At least now this issue is reduced, but in many cases, in the previous talks, there was this aspect of certification and so on. And without the certification, it's very difficult to essentially provide some sense of assurance of what is required of COTS to meet the required security guarantees, right? So this was essentially the accidental software threats introduced into COTS devices, but you could also have deliberate software threats in devices through the presence of backdoors and Trojans. So what does this mean? So essentially this means that before you even purchase a particular device, it essentially comes shipped to your premises with some malware built into it, right? And this malware could be in any layer. For instance, this news article on the top essentially says that you have a malware embedded into your BIOS of your system. Another one talks about malware through in cranes, right? That is used for spying. So we'll just take an example of this particular malware, which essentially says that Android devices had this malware when you essentially purchase your phone as well. So what essentially is this malware, and how did it land up in almost every phone that was ever purchased? So the malware is essentially called the Triada Trojan, and it was introduced, or it was essentially got into the Android framework at the time of before the device was essentially purchased. So you had Google over here, which was essentially developing the Android, which created the entire system image, and then utilized third-party vendors to add additional features to the Android, right? So the entire system image was then shipped from Google to these third-party vendors, which then incorporated additional images into the Android. And during this particular course, this malware Triada was also installed as part of the firmware itself, right? So when the Android image went back to Google and then installed on the phone, on the mobile devices, it came itself with the Triada malware present, right? And what did the malware essentially do? So the malware was part of the OS, it was part of the firmware. It could essentially display ads, it could send spam, it could monitor user behavior, it could communicate with a command and control server. Essentially, it was able to monitor users of the mobile device, and essentially, based on that, in this particular example, it could display some advertisements or send some spam and so on. Very customized spam for specific users. Now, it's important to note that detection of such intentional malware is extremely difficult, because these are not your regular malware which make use of vulnerabilities or bugs. These are malware which is essentially burnt into the system right at the time of deployment as well, right? Since it's part of the operating system itself in this particular case, it's very difficult to essentially detect such a case. So how do we go about this? So how do we essentially address this problem of software-based threats in COTS devices? So I could think of three different aspects. One is regulatory, the second is processes, and the third is technical. So the regulatory aspect essentially ensures that we have some regulations, maybe from a nationwide, which mandates, say for instance, revealing the source code of all the software that is ever used in a particular COTS device, or have specific schemes such as Make in India, or that you can essentially use only Make in India products. But such kind of regulations are not a great thing to do, because it kind of limits the number of COTS players that can essentially provide you the right hardware for your deployment, right? So the other aspect is the aspect of processes. So this is something what is essentially happening. So we have the certification processes which is going on, where IITM is closely established, closely associated with NCCS. You also have, could think of the changing the legal liability so that COTS vendors could be more accountable for whenever there is a problem that has been witnessed, or that has essentially occurred, right? What I'm going to focus on in today's talk is the technical aspects, right? So how do you essentially detect a threat? It could either be black box or white box. How do you essentially prevent such a threat, and how do you respond to a threat, right? So black box detection of threats in software would look something like this. So the idea is that I purchased a COT device, and I want to essentially evaluate it for different software threats. So what I do is I feed random inputs to the COTS device. This could be random, or it could be very specific inputs sent from a database or predefined. And then I essentially detect for anomalies, or essentially match certain signatures to identify if the output corresponds to a threat or corresponds to some malicious activity or not. Right? As an example, if you look at the crypto validation suite that has been defined. So if you want to validate, let us say something as simple as an implementation of AES, there are well-defined inputs that are essentially defined, and it's expected for these inputs you obtain certain specific outputs, right? So you feed in inputs, look at the outputs, and then validate whether this implementation essentially meets the criteria. Okay, so this is good. This is something which can be done very fast, but black box vulnerability detection has a lot of limitations. It is very unlikely to find zero-day attacks, and more difficult also to find intentional backdoors, right? So zero-day attacks are something, as we discussed, would not be standardized. There won't be a database of all zero-day attacks. And the intentional backdoors are essentially very well hidden within the system itself, baked into the hardware, and very rarely would it get triggered by random inputs. So we would need something further than just black box detection, right? And a white box detection of threats would give you much finer granularity. So here the idea is that you got COTS software, which is the software in the device, and either by the mandate you obtain the source code from the vendor. Now we did mention that obtaining the source code comes with its own limitations, but nevertheless, if you had managed to obtain the source code, the other option is, if you can't find the source code, the other way is to essentially extract the binary from the COTS hardware itself. So you for instance could read the flash memory present or the secondary storage device that is essentially present, and in many cases you will be successful, and you'll be able to obtain the binary of the software which is burnt into the COTS device. Now from the binary you can essentially reverse engineer, or the other terminology is to decompile and go backwards. So compilation is a process where you start with a program written in C or C++ or Java, and then compile it down to a binary or an executable. The reverse engineering or decompilation works in the other way. So you start with the binary and go backwards to obtain a high-level code, or optionally you could also reach something known as an IR, which is an intermediate representation. So the IR looks very much similar to an assembly code, but with a lot more semantics essentially present, through which you can essentially validate, you can essentially run these static tests or static tools such as IDA Pro, Anger, or Radar 2 to essentially detect various vulnerabilities, right? So many of these tools use symbolic execution, fuzz testing, SMT solvers, so that you get a much more fine-grained detection. Now with these kind of techniques, it's more possible to detect 0 days, detect backdoors, and so on, based on certain templates, right? So white box detection is far more acceptable, far more needed when you want to validate COTS software, right? So I'm going to actually very briefly talk about the work that we've actually done. The point is that either black box or the white box kind of software comes with its own limitations. So you're not 100% guaranteed that all 0 days would be identified, or all backdoors, all Trojans can be essentially identified, but we need to do something more than that. And as of now, as on today, commercially such tools are not available. So this is something we are actually working on at IIT Madras. I'll briefly talk to you about 3 such initiatives. So the first one is based on AI, using AI for security assessment of devices. So just like before, we have the COTS software, or the COTS device, we extract the binary through, let's say, the flash reader or interfaces such as the JTAG. Now we use a representation known as vectorization to represent this particular binary in a particular format, which is amicable to AI models for analysis, right? So with the AI, though we have not fully gauged what is the capability of AI, it could offer several advantages. Like for instance, it can even identify functionality. So notice the difference here between the regular thing which we've seen in the previous slide, where we said that you can identify 0 days, backdoors, or Trojans based on templates. But here I'm saying that AI can essentially be utilized to identify functionality, right? So what does it mean? So it means that you could code, or let's say you have a malware which is a ransomware, and it may be coded in any different way. There is no template, it may be coded in any way, and the AI agent could potentially identify this, right? So as on date, this is the research that is going on. The preliminary results show that such thing is possible. So for example, in our lab, we were able to do this. So we've taken a simple sorting algorithm written in, say, quick sort, and another algorithm written in heap sort. Notice that the algorithms are totally different, right? But the AI agent would be able to identify that these two pieces of code, just by looking at the C code, is able to identify that these two are essentially performing the same functionality, right? If you have such a power, then you'll be able to focus on functionality rather than templates. The second work which I'll talk about is the aspect of using emulation for security assessment, right? So here, what we've seen is two things. We've seen the black box, which essentially uses some kind of a dynamic analysis, and we also use seen the white box techniques, which are essentially static analysis, right? Each of this has its own limitations. The black box kind of technique, which is dynamic, it's very easy to get coverage. You just need to feed inputs to it, and you get the result output, but you don't get the granularity that you essentially want. On the other hand, with the static analysis, it does not really scale, because many of the tools that are used for static analysis would not scale or would take exceptionally long time for huge software, right? So this is a problem with the dynamic and static analysis. So we are working on an intermediate method where what we want to do is extract the software as before, obtain the binary, now use static tools like Anger or IDA Pro to build a knowledge base of the hardware. So what do we mean by this knowledge base? So the knowledge base essentially is a means by which you can kind of emulate the hardware behavior. It will tell you what the hardware is expecting, where the various peripherals are present in the hardware, where is the USB port, where is the Ethernet port, where is the hard disk, and it will be able to kind of emulate the specific hardware. So very similar to kind of a digital twin, but it is essentially a software which can kind of mimic the hardware behavior. So now when you have this, you have the binary, you have the knowledge base, you are able to essentially execute this binary in an emulation, in a simulation, but provide and obtain fine-grained analysis, right? So you can identify, for instance, every instruction that gets executed in your simulator. You'll be able to identify through these instruction sequences, you're able to identify specific patterns which may behave to correspond to, say, a trapdoor or a malware or a backdoor or Trojan and so on. You'll be able to identify what memory, each and every memory access that has been done and so on. So with this, what we essentially assume or hope for is that we would get a very deep perspective of what essentially is happening within the device. Right? The third activity which is ongoing, which is in a different perspective. So here we are saying that we do not want to essentially look into the binary, we do not want to look into the COTS software and just identify all the vulnerabilities and all the problems and all the threats that are present. But rather what we want to do is have more of a prevention technique. So we want to take this particular software and retrofit some security aspects into this given software. So as before, we extract the binary from the COTS, but now we retrofit the binary with some extra security measures, right? And then we reflash the binary into the COTS device, right? So your binary may still have vulnerabilities, but due to the retrofitting, we are adding security measures which would kind of prevent the exploitation of these vulnerabilities, right? So just to give an example of what can be possible, here is an application footprint in memory. As anyone who writes programs or C programs would know, the application footprint in memory is typically monolithic. You have all functions, all data and everything within one contiguous range of memory, right? And the problem that can occur is that if you have a bug or a vulnerability in one part of the code, it essentially means that the entire application is compromised, right? So what we can essentially retrofit is create some fine-grained containers where each function would be in a separate container, right? So this way we are restricting. So if there's a bug or a vulnerability present in this function called goo1, the exploitation or what damage can be done is also restricted within the same thing, right? So this is one example of what can be possible by retrofitting security in an existing binary. However, there are a lot of other aspects as well. Okay, so we'll move from the software to the hardware. Now, just like software where there is accidental and deliberate threats in software, you similarly have accidental and deliberately introduced threats in the hardware as well. So we'll start with the deliberate threats, which is kind of more researched or more studied compared to the accidental threats. So the deliberate threats in hardware, or the hardware threats where deliberately there is something essentially introduced in the hardware, could be motivated by two things. One is by cost cutting, and second, a malicious intent. So cost cutting, the main problem that we essentially see is the aspect of counterfeit electronics present in COTS devices, while the malicious intent corresponds to the presence of hardware trojans. So we've already seen the aspect of backdoors and trojans present in software. A similar kind of trojans also can be present in the hardware as well, right? So we look at each of this. So what is counterfeit electronics? So I'll start with this news article which was published in 2018. This is essentially called the Big Hack. Essentially, this is a Supermicro motherboard, and what was essentially found out was that there was one small chip, essentially the red circle present there, which was present, but nobody knows why it is present. So it has been introduced somewhere during the entire manufacturing process of the motherboard, right? And as the news article says, this small chip can be used to essentially identify or leak information to an external source, right? So this is essentially very scary because we have designers which have essentially designed this particular motherboard, but when they finally obtain the hardware for the motherboard, there is this extra chip among the 1,000 of other chips that are present, right? So such kind of abnormalities or such kind of additions that we see over here may not be restricted just to motherboards and PCBs, but can also be present in ASICs as well. So if I look at an IC and the manufacturing process of an IC, it goes through several processes, right, from the specification to design, fabrication, and so on, before it is essentially deployed and monitored. Now, many of this is not done by one organization, but they take the help of several organizations, many third parties that are essentially involved in developing an IC. So there are several IPs involved, there are tools, there are standard cells and models. So each of this could possibly be a threat, right, or introduced a deliberate hardware threat within the IC. Now when this particular, let's say a particular company which created the specification and then eventually obtained the IC, what it would get is this black box, this IC. It'd be very difficult to identify that there are 20 or 30 more gates that have added to the IC which could possibly act as a Trojan or a backdoor, right? So as an example of what a hardware Trojan is, we look at this particular example. So let's assume that we have a crypto module and that blue box over there is essentially the IC. So you have a crypto module present within this particular IC, and you have a stored key within the IC, which is stored within the particular IC. So the crypto module essentially takes an input, which is an external input from a user or from a particular application. It encrypts the input based on the key, and you obtain the ciphertext, right? Now, let's say the designer has essentially designed such an IC or designed the using Verilog or so on, designed this particular IC and sent it for fabrication. Now, during the process of fabrication, let us say the fabrication, which is typically done by a third party, would introduce a small addition to this particular circuit, right? So during the fabrication, a multiplexer is essentially introduced, and what you see over here is that if the select line to the multiplexer is 0, then the IC works as normal. The input gets encrypted, and the output is a ciphertext. On the other hand, if the select line to the multiplexer is set to 1, then the key is essentially sent out as ciphertext. Now the critical information missing in this particular slide is the trigger circuit, right? So the trigger is based on is extracted from the input and looks something like this. If the input is equal to a very specific string, in this case say cafe beef, then you select, set the select to 1, else select equal to 0. So what is the problem over here, right? So if you pass this particular IC through testing, And let's assume for argument that the crypto module is, say, the AES. It's highly likely that the module would pass all the tests, right? So for instance, the input to AES is 128-bit, and therefore you could have 2 power 128 possible inputs to this particular IC, out of which exactly one input is what essentially triggers this particular Trojan, right? So finding this input during your testing process, however deep it is extremely difficult. So it's more easy to essentially identify life in another planet rather than essentially finding this trigger. Okay, so this essentially is what an example of a hardware Trojan. Last 10 to 12 years as such, there's a lot of research that has actually going on to make things more complicated. So we call this as a combinational Trojan because the trigger essentially is a combinational circuit. But there could also be sequential Trojans, there could be cheat codes, a lot of other aspects which could kind of give you a backdoor entry or into your IC and as well as leak information about what is essentially happening, right? So one thing to essentially note over here is the fact that if right at your hardware itself is compromised, whatever you do at the software level, whatever authentication, whatever antivirus solutions or whatever security measures you have would not be of much use. The other aspect that I want to touch upon from this deliberate perspective is the aspect of counterfeit electronics and counterfeit ICs in particular. So this is again a deliberate aspect introduced mainly from cutting costs. So what do we mean by counterfeit is that you purchase a particular COTS hardware, assuming that every IC or every device present within that hardware is authentic of a high quality, but in reality they may be of low quality or disguised as a specific component. They may be defective parts, or it may be reused parts or refurbished parts. Yeah, just give me 5 minutes. Okay, so this is a big threat as seen by the Silicon Expert article. So it's estimated in 2013 there is $125 million worth of fake electronics that is present, and the counterfeit electronics market is growing at the rate of 30% and made extremely bad with the semiconductor shortage that we actually see now, right? So there have been some studies which showed, for instance, in this paper itself, they've talked about how the lights of a runway were damaged suddenly, and when the study was made, it was gone back to due to fake hardware or fake devices that is present. Another example which they essentially showed was the aspect of medical equipment which failed suddenly, and the postmortem report, hopefully of the medical equipment, showed that it was due to fake devices. Okay, so what do we do about these counterfeit and hardware Trojans? One of the most best ways, although a lot of research is going on in this way, is visually, by visual identification of the ICs. So here are some examples I've essentially taken from the net. So what you see over here is that visually, just by looking at specific ICs, you could see essentially or notice differences in certain aspects, such as the logo, the font, indents. So for example, in this IC on the top right, there are two ICs which are exactly the same, but there is a small difference in the indent, right? Similarly, the one at the right bottom, there is a slight difference in the alignment. The one at the left bottom is where you actually see that if you scrape out the paint on the top or the writings on the top, you get something else, right? And this is a cause for concern. Now, even if the top layers or the looks of the IC look exactly same, there could be possibilities of problems inside the IC as well. And this is where we use X-ray images. So here what you see is an example of two ICs which are from outside look exactly the same functionality, but when you take the X-ray images of these, they look quite different, right? Another example is here. of another IC where you see certain anomalies in some of the pins, right, which are marked in circles. So these can only be noticed through X-ray imaging. Right. With respect to hardware Trojans, here are two examples. So on the extreme left, that is the golden IC image, and the second one is the IC image from a device under test. You see some minor changes which are occurring, right? So this, the second image is where potentially you have a Trojan that has been introduced during the fabrication process, right? And the last figure, the figure D, shows the regions where there is a suspected Trojan. Here is another example of a SIM card doping level footprint, where you essentially see gaps in the IC itself. So these gaps can be actually used during fabrication to essentially introduce a Trojan or modify a NAND gate to say a NOR gate, things like that. So minor changes like this could manipulate or change the behavior of an IC, and maybe, and this you observe is right at the bottom layer, could compromise the entire devices or keep the device at the hands of the attacker. Right? So all of this, both the hardware Trojans as well as the counterfeit electronics, was deliberate threats. We could also have, just like software, accidental threats in the hardware as well. So hardware these days, typically written in Verilog or sometimes system Verilog, or we use BlueSpec. It's becoming more and more complex, right? So the complexity of a hardware now is almost equal, or sometimes even much more than the software. And it's quite natural that when you have such complex hardware present, you could introduce bugs, you could introduce vulnerabilities, and so on. Right? So this particular paper called Hard Fails, published in Usenix Security 2019, essentially catalogs around 30 different hardware vulnerabilities. So these vulnerabilities are essentially present right in the hardware. So one example, just to take something, is say the 8th bug, where there is an overlap in address range for specific GPIO. Right? So typical testing would not essentially identify this, but if you have a user of this particular device which knows about such a problem, then he could essentially use this hardware bug to create a software exploit. Yeah. Here is an example of the Apple M1, the M1 processor of Apple, which was quite recent. Essentially, the vulnerability is called Pac-Man, which kind of originated right in the hardware itself. Right? So with the help of Pac-Man, attackers could essentially inject malicious code in the software. So you have a hardware vulnerability which can be exploited from the software. There's little that is essentially done to prevent such kind of hardware vulnerabilities. We don't have a VAPT or equivalent test suites as of now for hardware, but this is an ongoing research. So I'm going to conclude with this, this particular slide. Very critical. So COTS has a lot of advantages, but it also comes with security, potential security risks as well, and therefore COTS hardware has to be subjected to a security validation. There's a lot of effort going into developing tools or reusing tools that for validating software in COTS devices, but we should also focus on developing our own tools for software validation, and we should keep these tools undisclosed, because this is our secret weapon. So if you publish a particular tool, or if you essentially make this tool open source or something which other users can do, the attacker could now take this tool and design their own vulnerability or their own malware, which cannot be detected by this tool. So it's very important to keep these tools undisclosed. Set up centers and research for hardware evaluation. Very less is essentially done from the hardware perspective to detect such vulnerabilities, right? And to detect both Trojans as well as counterfeit electronics. So I'm going to stop here for now. Thank you very much.
Thank you, Professor. One of the interesting and very informative lecture. So you have brought out all the vulnerabilities, possible vulnerabilities in the hardware, and what are the ways one can detect those vulnerabilities. Thank you. So this country has come a long way ever since the 1994, we launched the 2G network. From that day to the today, say there are developments in the rolling out of network. Right? There was earlier there was a significant time lag. So when we launched 2G, other countries were there in the 3G. Now it's not like that. The lag has been considerably reduced. So they say that India is one of the fastest on rolling out the 5G network, fastest country in rolling out 5G network. So 3 lakh sites we have RAN sites we have commissioned so far. So what are the the options available to the Indian operators? How they are going to roll out how they have rolled out the 5G network? So those things will be discussed by the Mr. Sanjeev Dallam. We'll be talking on the implementation of 5G RAN in India. So welcome. So floor is yours.
So in my presentation, I'm going to briefly discuss about the NSA and SA architecture, what are the deployment 5G RAN options available with us, global landscape of 5G network in terms of 5G NSA deployments and 5G SA deployments, then how the networks are evolving from 2G to 3G, 4G and 5G and what are the threat landscape it is leading to. We'll briefly discuss about the zero trust architecture we are talking about in every forum, what are the different 7 tenets of zero trust architecture, layer security controls. So to start with, this is the pyramid of 3 different use cases which 5G is empowering, which is today the biggest use case which is right now live across all 23 circles. We have made live 5G, all 23 circles is mobile broadband, which is running on our 5G NSA architecture. The second is your logistics and agriculture kind of use cases and the automatic factory. So it fits into EMBB, massive machine communication and URLC. Massive machine type communications are available in the market. EMBB is live, but URLLC applications are still to evolve in terms of market adoption. So what is the difference between 5G SA and NSA architecture? The prime difference is SA is having a dedicated 5G core, whereas NSA, the core network is anchored by a 4G existing network. And we have the liberty of anchoring the user on the existing mid-band FDD spectrum layer. So this is the global landscape of 5G deployments across globe. 243 operators have launched 4G networks. Among these, 41 operators are 5G NSA and SA. 4 operators are only 5G SA. So growth driver is initially operators tend to launch 5G NSA network to empower enhanced mobile broadband services. And then subsequently, basis the use case evolution of enterprise use cases empowered by 5G, this SA deployments is being done on the need basis. So if we differentiate the key differences between NSA and SA, global adoption of 5G NSA network is greater than 98%, device ecosystem is mature, core network is being used as an existing core. There is no voice impact, but as compared to SA, voice over NR is yet evolving in terms of its IRAT maturity as well as its testing, etc. Coverage is higher in 5G NSA because it actually gives you the liberty of providing the coverage on the existing 4G anchor layer. Slicing is possible in NSA with the features which are coming in the devices as compared to SA also. So this slide is talking about the coverage enhancement which is being given by 5G NSA architecture versus 5G SA. So 5G NSA architecture is having 30% more coverage because it is actually anchored onto the existing FDD layer. Otherwise 5G SA you need a separate anchor. So anchoring on lower FDD bands helps in increasing coverage from the 5G side. Some of the key factors which are driving the 5G market, the use cases on the enterprise domain are yet evolving, the device ecosystems evolution, the spectrum and infrastructure, and the gigabit side connectivity. Every site need to be connected on the gigabit. So these are the key drivers of 5G market more penetration. If we talk about 5G RAN deployment options, we have dedicated RAN, virtualized RAN, and ORAN. So the difference between DRAN, VRAN, I have tried to show in this particular slide. I'll just give a brief idea. So we have radio unit and a baseband unit in terms of distributed RAN. When we go to the virtualized RAN, it is RU, DU, and CU split, but the CU and DU is from same vendor. The vendors are same. However, in the open RAN architecture, you can have CU, DU, and RU from anybody. This kind of flexibility is extended. What are the threat landscape which are increasing in ORAN is like one of the infrastructure, because you are deploying CU and DU on the COTS hardware, on the NFE infrastructure, utilizing SD and NFE technology. So this kind of threat landscape prevails in ORAN also. And then you are opening up the interfaces. So interface you can have eavesdropping or the interception, etc. So accordingly, while the ORAN is being deployed, the additional security controls are applicable onto these particular layers. This is the current situation of spectrum which is available with Airtel in terms of empowering services. So we have spectrum of 5 to 10 megahertz in sub-gigahertz band. Mid-band we have 60 to 70. We have purchased 26 gigahertz millimeter waves, 800 megahertz, and on 5G 3.5 gigahertz we have 100 megahertz spectrum, which is empowering our 4G and 5G network. So how these networks are evolving? So there are new technologies which are being adopted as part of 4G itself, which is from moving from your standard commercial proprietary hardware to the NFE and SDN technologies. So there are a lot of digitization technologies, automation technologies are being adopted as part of deployment of networks. The increase in trust of threat actors into 5G services, because we are going to empower enterprise services which will be handling the critical infrastructure. So threat actors or nation state actors will have more interest into the communication network. The attacks are becoming highly sophisticated. So is the threat landscape, and so is because telecom is like a utility service like electricity and water. So its availability and confidentiality is very, very important for the nation. So accordingly, we need to continually involve the threat landscape while we adopt for the new technologies. So this slide is summarizing the kind of threat landscape we have on 4G and 5G network. On air interface, we have attacks like fake BTS, tampering of user data. On the internet, again, denial of service attacks can be launched from the botnet army to a particular website, etc. Then on the roaming, we have interconnect threat which lead to SMS call interception of services of customers, EMS threats. So if we talk about, there are three categories of threats which are being introduced new in the 5G while we adopt the slicing concept, mobile edge at the core, and cloudification while we deploy the 5G network. So we are talking about zero trust in the current era. What zero trust is talking about, I picked up from the NIST data. All data sources should be considered as the sources. So communication should be secure from irrespective of any location. Access to individual resources should be granted on a per session basis, and you should have a dynamic policy which is to be granted to the resources. It should not be a static. So a dynamic policy engine should be deployed which assesses the state of the respective asset or resource and accordingly provide the authentication and authorization. Measurement and monitoring of security posture of all the associated assets. Like authentication and authorization are dynamic and strictly enforced before the access is allowed, and you should collect as much information from the interfaces into your security monitoring center for extending your eyes to have more visibility onto your entire ecosystem. I just try to map how this zero trust architecture is mapping in the 5G. So all data resources are allocated in terms of their identities. UEs are identified using IMEI, INSI or SOPI. Communication is being secured through utilizing of service communication proxy, TLS, IPsec, etc. Individual resources are allocated on a per session because we have a 5G AK mechanism which is allocating the resources to the individual user on a per session basis. So I have to try to capture this particular, I will rush through these slides, but anyway. So let me spend a couple of minutes on this particular slide. So there are three key principles of while operating your 5G network. First is the zero trust, which we talked about, that or you should have a strong user access control and refined authorization of telecom users and application to reduce the attack surface. The second factor is in-depth defense. So while we deploy in-depth, the first defense is at the perimeter, deploy firewall on your network boundaries. Then when you are connecting your network to the external roaming partners, you should configure service proxy at the interconnect, hiding your network topology and message filtering. Then since 5G is introducing SB architecture, so inter-NFV protection should be implemented with TLS and OAuth 2.0. And on the infrastructure layer, you implement VM isolation and strong network segmentation for preventing lateral movements. Once any malware enters into your network, so you should apply the controls to protect the lateral movements. The third part is adaptive security. Security is not static. It has to be keep on evaluating to the threat landscape, which is also continuously on the evolutionary pace with the adoption of new technologies. So whatever the controls you are applying may not be applicable tomorrow. So you should develop a dynamic security solution which are continuously optimized in terms of reducing your risk exposure. You should do your risk assessment on a certain frequency basis so that you are aware of what are challenges in terms of process technology you have so that you can address them proactively. And secondly, you should work on in case you are hit by a particular threat actor and you have a security incident, and how you are enabling your quick recovery in terms of your services. So these are the key pillars for designing a security. Try to map what are the security controls should be applied at the different layers. So security has to be applied at different layers. Or the infrastructure layer, we should harden our NFA infrastructure, securing east and west traffic flowing through the infrastructure. At the VNF and CMF layers, already in the multiple presentation, people have discussed the respective controls. I'll just rush through this slide. Application, DOS protection controls, conducting dynamic and static security application testing. At the network layer, you should have a strong network segmentation policy which protects you from the lateral movements and from external attacks. Strong RBAC control in terms of user access control with the zero trust principle. And since with the network slicing and with the networks are getting automatically deployed, so you introduce the concept of management and network orchestration platform. So proper hardening of this Manu platforms are very much critical so that this platform doesn't get tomorrow exploited to sabotage your big part of the network. So vertical segments still evolving, but yes, there are three typical vertical segments which are coming as part of the 5G enterprise use cases: V2X, smart manufacturing, and critical infrastructures. So in all the use cases, enterprise are partnering with TSPs to deploy private 5G core network, and this space need to be evolved slowly in terms of what are the key responsibilities. Vertical industry will be managing what are the responsibilities TSP need to share as part of enabling this vertical segment use cases. This is end-to-end security framework of 5G. So at the end user, we have malware site which channel attacks or onto the user equipment. So access network security, we talked about air interface security, front haul and back haul, your transport network security. SDN and NFV infrastructure are empowering your workload. So security controls are applicable for these particular platform at the access network layer. Some of the same at the core network, since SB architecture is being introduced, so TLS or OAuth security kind of implementation is required in the core network. And then comes the application which is empowered on top of your telecom infrastructure and the general security controls. Okay, so I'll summarize what talk about. So as part of building 5G networks, we should build a zero trust architecture with in-depth security and adaptive security to protect from internal and external threats. Security controls should be identified at each layers as part of your overall network deployment and the services ecosystem. Utilizing your industry-approved, secure and current version of APIs protocol and the infrastructure. Supply chain security is very, very critical, and NSDTS has been playing a vital role in terms of what are the supplies of this telecom equipment and the respective components which are enabling the telecommunication network. Ensuring your all suppliers implement a philosophy wherein they use security product lifecycle. Security is being used as a prime requirement, not an add-on requirement as Ninder sir told. So this is very critical part while OEMs are manufacturing their equipment. And your governance risk and compliance framework is very, very critical as part of the TSP operations. You continually govern what are the security controls which are applicable to be applied on the respective infrastructure, and are these respective functions are adhering to this or not. Continually assessment of your risks which are prevailing at a certain frequency, and then you manage your compliances. This is the overall recommendation in overall protection of 5G network security. So I'll stop here in the interest of time. Thank you.
So thank you, Mr. Dallam. It was very informative and insightful lecture. So you took us to the 5G journey. What are the possible security challenges and what are the principles behind the countermeasures suggested by the various SDOs. So they say that 5% of the network rollout in RAN is on this technology, and the year 2026, this technology will overrun the traditional RAN. So that will be at 2026 will be the inflection point. So what we are going to discuss about is the Open RAN. Okay, Open RAN means, if you go by the definition of Open RAN, it says that it's open, intelligent, interoperable, and the virtualized or cloud-based. So all these things point to the open invitation to the attackers. Okay, but Dr. Taneja has got other ideas. We will talk about the ORAN challenges and possible security measures. Over to you.
Okay. This is on, right? Yeah, yeah, that's okay. Yeah. Okay, thanks. Thanks to the organizing committee for inviting me for this. Okay, so I think I'm going to talk about ORAN, 5G ORAN architecture, and I'm basically going to give an overview of some of the activities in the ORAN standards, and we'll also talk about a few things from the product angle. I think there'll be some overlap with what Sanjeev was talking, and of course with what you folks are already doing it. So I think I'll go fast through those slides. So basically, I'm going to first cover, a bit about ORAN architecture. So like how this ORAN architecture is evolving. I'll talk about RIC, non-real-time and real-time RIC, non-real-time and near real-time RIC, and also talk about network slicing. So slicing, of course, network slicing is network slicing, but it gives you resource. It can also give you resource isolation, right? So it can, depending on what kind of security policies you have, right, that can potentially be useful. And then I'll talk about security, and then talk about some of the challenges with the ORAN architecture. So this is just just a 3GPP network architecture diagram. The reason I put it is, of course, because I'll be talking about the data plane, of course, the RAN, the UPF, and then some of the core network functionality like AMF, authentication server function, AUSF, UDM, right? So we'll touch upon some of those functions. So this is like the ORAN architecture. You will find it in the ORAN specs. So as covered by Sandeep and some other speakers earlier, potentially some other speakers earlier. So you have this RU, DU, and CU. And these are all open interfaces, standardized interfaces. So 3GPP also, so 3GPP standardizes like the F1 interface, right, which is between DU and CU. So you have CU, CP, and the UP like for control plane and user plane, and U1 interface, which is again from 3GPP between CU, CP, and UP. The green ones which you see, those are standardized in ORAN. So like the E2 interface, so basically you will see the service management orchestration framework. So that's where you have non-real-time rigs. So you'll have like, different non-real-time rig applications which can be hosted there. So like the called REPs. And then you have A1 interface for near real-time rig. That's where you can host different near real-time rig applications like XApps. So E2 interface is like basically you are collecting data from DU and CU and you analyze it at a near real-time rig. So E2 interface is being standardized in ORAN. And then of course the front haul, which is that's again being standardized in ORAN between DU and RU. Then you have like Y1 interface, which can be used to give some insight to the other customers from the rig. I think some of the key aspects are like it's disaggregated architecture. It is not monolithic, right? You could deploy. There can be various deployment scenarios. You could deploy DU at cell site. You could deploy DU in a local data center. You can deploy a CU at cell site or a local data center. You could deploy it cloud, at a public cloud, right? These are all open interfaces, all standardized interfaces, either in 3GPP or ORAN. No proprietary interface here. The virtualization, of course, and the RIC is introduced here. It tries to maximize the use of the COTS hardware. Again, this is just this is a 7.2 split, which is widely used in the products right now, where you have like the low-fi in the RU, the hi-fi is in the DU, along with the MAC and RLC. And then you have PDCP, that's where you're doing ciphering and so on for data plane. That's in OCU, along with SDAP and RRC, right? So the right figure, so basically, if you see at the right figure, so that's like just showing a G node B, from a functional angle. So like you have one CU CP instance, you could be supporting like, tens and thousands of potential users with one G node B, right? So here there is one CU CP instance. So CU CP could be, you have like microservices. You could have different microservices being supported there. It could be hosted on a public cloud. And then there are multiple instances of CUUP. There could be multiple instances of CUUP. You could potentially have slices. You can have certain slices going from one CUUP instance, another set of slices going to another CUUP instance. And of course, you have many DUs. Some of the DUs could be at cell site, some could be localized data center. Each DU could support multiple cells. So in a way, like CUCP could be supporting many users, right? Tens and thousands of users. And then DU could be supporting many cells, right, in area. And basically CUUP, that's where you have all the data radio bearers, right? All the DRBs, that's where your data is going through, right? So that's the schematic diagram. And like I said, like you could have different deployment scenarios. This is just trying to show that. So like you could have, the bottommost one is like you could have DU as well as CU at the cell site. Next is you could have DU at the cell site and you could have CU at data center or in a public cloud, or you could have DU also in a localized data center, and CU could be a couple of 100 kilometers away, right, in a public cloud. So so multiple kind of architectures may exist. It also depends on your use case and the other constraints, like the capex, opex, so the other constraints which could help you decide, which architecture one wants. So this is I'm showing a reference architecture, which has been deployed by one of the customer. So in this case, you have So this is like, memory, Dell, and VMware. So in this case, so these are the Dell servers. That's where you're hosting the DUs and the CUs. And then this is the VMware. It's a telco cloud platform. It's from VMware in this case. This has been deployed for 5G SA. For memory side, we have MTCIL, which is memory telco cloud integration layer. You have like DU, CU, CP, UP, MCMS, which is more like memory centralized management service for configuration and so on. As does smart deployment as a service that helps you to configure RU and analytics, right? And the VMware orchestrator. And memory also has offerings for the cloud platform. So in this case, VMware memory also has different offerings. So this has been deployed for one customer with 5G SA. In this case, so CU could also be hosted at AWS. Okay, talking a bit more about the architecture diagram. So of course you have SMO, which takes care of FCAPS. It hosts the non-RT RIC functions. So essentially you have the RFs, which are like non-real-time RIC functions. So in terms of the timing line, the question is, okay, you're collecting certain parameters, you do some analytics, right? So what's the timeline, right? So I'll talk a bit more about timeline, but typically the non-RT RIC applications, basically you're talking about the use cases where it's more relaxed. So you can potentially do it in seconds, minutes, or even hours, right? It depends on the use case. I'll talk more about that in a bit more slides. So this RFs is there, this R1. So basically some vendors will provide you the non-real-time RIC framework for the platform, right, as part of SMO. And these RFs that you see, they can come from different, different application suppliers. So they could create RFs for different use cases. For example, for mobility optimization. So you have like certain thresholds which need to be handled in mobility optimization, or for like network energy saving, which is a very important part, right? So these RFs could come from different suppliers. And okay, so transport, of course, I think it has been covered. So transport is a very important part here in our end. So basically, you have mid-haul between DU and CU. DU and CU could be located, like hundreds of kilometers away. And you could be using MPLS or segment routing or, some other techniques. So there could be like routers and switches along the midway, along the mid-haul. So you have DU and CU, but, they could also be located in the same data center. It depends. In some cases, you could have CU and core network in same data center, right? So there are different deployment options. But there will be some deployment scenarios where CU and DU are quite far away. And you could have, I'll talk a bit more about mid-haul, but in some cases, you could have mid-haul, which is of great quality. Some cases, the mid-haul may be, reasonably okay. And then we do optimize certain, modules to take care of those scenarios. This is just for the front haul transport. So you have RU. So on the DU to RU, basically you have control plane, then the management plane, synchronization plane. So PTP, IEEE 1588 is used as a grandmaster, and you have the user plane to basically communicate the IQ samples, right? And basically in the RU, if you see on the left side, you'll have like basically your NIC card, your 1588 timing hardware, your FPGA, which is running the lower 5 functionality, and then you have a processor which is hosting software to drive it. Okay, these are like more of functional. This is more like the functional architecture of the functional decomposition. So like if you look at layer 2, so you have some important modules here. You'll have scheduler. Scheduler, of course, continues to be very important for resource management. I mean, it's going to help you decide what kind of QoS, QoE we get, what kind of performance one can get at per user level, per application level, what's the spectrum efficiency, and so on, right? So all those algorithms are going into the scheduler part. You have layer 2, MAC RLC, you have OM agent, you have E2 handler, which is for the RIC, your O1 interface for network configuration management, and so on. Your F1 interface, which is to the CU, right? Then you have F1 user plane. So user plane is over GTPU, UDP. You have IPsec between CU and DU. And F1 is like, that's where your control plane protocols. So the other part is, you see this flow control, which is also a very important part of F1U. So basically you have flow control between DU and CU UP. So like I said, CUP and DU could be deployed at totally different locations, right? They could be even hundreds of kilometers away. And in some cases, you could have a very good mid-haul, like with less than 1% packet error rate. Some cases, the packet error rate could be pretty high, like 10% or even higher, right? And there will be also latency over the mid-haul, right? Latency can also vary. So this flow control is basically, giving flow control feedback from DU to CUP. So as the packets come, you give the feedback. And in a way, you try to tell, how much more data CUP should be telling, or at what data rate it should be sending data to DU. So DU also, of course, DU could be at cell site or at localized data center, and it could have, limited buffer, for example, right? So DU gives that feedback. Plus, you can also monitor what's happening over the mid-haul, how the mid-haul is behaving, right? And give feedback according to that. This also supports retransmission over mid-haul. Suppose if you are losing packets, you could retransmit it. Okay, this is the scheduler. It includes downlink scheduler, uplink scheduler, link adaptations, timing advance, uplink transmit control. This is all part of like L2. Okay, this is a logical view. I try to draw. So basically, if you look at it, these are like downlink packets coming. And from the UPF, from the core network, there's one GTPU tunnel per PDU session between UPF and CUP. For PDU session, like UE could support multiple PDU sessions. Each PDU session can have multiple DRBs. And at SDAP at CUP, these QoS flows are mapped to DRBs. And there's a GTPU tunnel per DRB between CUP and DU. And that's where you have flow control. So flow control I was talking is per DRB between CUP and DU. And at L2, we have scheduling algorithms, radio resource management algorithms, flow control algorithms, and so on. And like I was saying, CUP could be supporting pretty large number of DRBs, right? And we could be supporting pretty high number of UEs in a per G0 B. This functional block for CUCP and UP, this could be implemented using microservices. Like in memory case, it's like implemented using the multiple microservices that are supported for CUCP and UP. So this one is more like a schematic diagram from the specs. So your OM agent, then you are doing like at CUCP you have like G0 B procedure management. You are doing cell level procedure management and per UE, management. So at G0 B level, you're talking about things like multi-cell procedure management. How do you handle NGAP interface, XNAP interface, F1AP interface management, and so on. Then of course you got encoders, decoders for RRC, NGAP, all the different interfaces, right, with which you interface XNAP, F1AP. And then you have CUP, that's where you have GTPU, PDCP, that's where you do ciphering and so on. And then the OM agent, right. Okay, this is just showing a schematic diagram from the L1 aspect. So you have like downlink task scheduling, the uplink task scheduling. You have different modules for like PPCH, PDCCH, PDSCH for the downlink channels. Then the uplink one, PRACH, PUCCH, PUSCH. And then you have FEC acceleration, you have front haul related processing, and then you have FAPI, right, for the L1, L2 interface. So some of these, some of the L1 modules, of course, could be accelerated using hardware. It depends on the implementation, but some could be accelerated with hardware. So like in this case, you could have like look-aside acceleration or the inline acceleration. So look-aside is like you got this acceleration application layer. So what ORN is doing is that's, so accelerator is more implementation dependent, but they're trying to, they're standardizing the APIs that can be used. So it's like look aside, this is inline acceleration. So basically you can have FEC accelerator that's having your rate matching, dematching, LDPC encoder, decoder, CRC check and generation, So these accelerators are available and used. But again, it depends on the implementation as well. Okay, so basically I'll switch to the second part, which is to do with the RIC. And a lot of AIML work which is happening in 3GPP as well as ORAN. So the variety of use cases I just listed on some. You will see large number of use cases if you look at 3GPP ORAN spec. Plus, there are also many other use cases that industry has been working on. So like some of the important use cases like network energy saving, which is a very important use case, mobility optimizations, load balancing or traffic steering, the QoS QE optimizations, channel CSI feedback enhancement. So like, also like a lot of work is happening in CGPP RAN 1, like to predict the channel state information, right? So as of now, if you look at the L2 scheduler, we typically use like, many vendors use enhanced proportional fair scheduler, to give certain level of fairness while doing radio resource management. And basically, you do not know how the channel conditions may evolve in future. They could change pretty rapidly, right? So a lot of work is happening to predict channel conditions in future. Eventually, if you can predict channel conditions for future, let's say for next X millisecond, whether it X is like 10 millisecond or 50 millisecond or 100 millisecond, you could do your decision making in different way, right? So I think I'm not talking more about that, but you can look into CGPP RAN. A lot of results are being presented, and the channel prediction could be done by the UE, could be done by the network at the DU, and in some cases only the UE may do, some cases only the DU may do, in some cases UE may do, and network could enhance that channel prediction, right? And then a lot of the algorithms that you use, like the schedulers, and many of the algorithms that are used in Keynote B, without listing down those, so they can potentially be enhanced to take advantage of the channel prediction information that you have available. So because in L2, one of the big challenges, because you don't know like the channel conditions in future, you don't know how the traffic will also evolve. So a lot of work happening in this direction. B management, of course, so improving accuracy of the positioning for NLOS scenario, network slicing and so on, right? There are a large number of use cases where work is happening. So I'll talk a bit more about energy saving and slicing. So energy saving, one of the thing which is done is like to activate or deactivate certain cells or the RUs, right, to save certain energy. But then you have to figure out when to activate, when to deactivate. So it could be like a configurable option, let's say in the night, or like 10 to 6 you deactivate, right, or activate. Or sometimes you try to predict, right, but so it's not an easy option because you really predict pretty well, when you should activate or deactivate a cell, right? So like if you do wrong switch off of the cells and then you offload traffics to some other nearby nodes, that can potentially degrade the performance, so whatever prediction you're doing, it could be inaccurate, right? And these are like system performance trade-off, right? On one end, you are trying to save energy, but on the other end, it will impact the user KPIs, right? Because if you are offloading user to some other nearby node, because you're shutting down some cell, it could impact your throughput latency of the users and so on, right? So in general, it's difficult to get the right set of parameters, like when to activate or when to deactivate. What are the thresholds? Very difficult to find those, in networks. And there are certain local decisions, there are also certain global decisions, because even if you offload to somebody, some neighboring node, which one you should offload to, right? What will be the impact on that once you offload? So it's not necessary that you're going to gain something, maybe you gain something, but there's a trade-off. You're going to lose something because you're going to offload on the other node, right? So like, this is ongoing work and people do it in different ways. So like in this case, this is with reference to CGPP. So you're collecting variety of, parameters from, let's say, UE. So like UE location, the velocity, the measurement reports like RSRP, RSRQ, and so on. And then you're collecting some parameters from the local nodes. So like how many UEs are there? What are the mobility patterns? What is the current energy efficiency metric, right? You could define a metric and you can say what's the current energy efficient metric? What are the resource status, right? And you can also do it for the neighboring status, right? Then the next thing is the training ML module. So you collect all these parameters and they can be different way, right? With the RIC module, what will happen is you're collecting such parameters over the E2 interface. You're communicating such parameters from the E2 interface to analytics server. And there can be other ways of doing it. You can potentially also enhance, the CGPP interfaces are also being enhanced for that. And so basically then next block is like that's where you're doing ML training. And then now the thing is once you do the training, once you collect all these parameters you're trying to train, you're trying to figure out which cell you should offload or which cell you should activate or not deactivate, right? And what are the thresholds to be used or which UEs to be handed over. So basically, you're going to have this ML model, right? So one possibility is you have this ML model at the analytics server, the RIC server. There itself, you do the decision making, and just communicate the decision making to DUs and CUs. The other option which is being explored, so that's already, those kind of things are already happening. Other option which is being explored is you do the training, let's say you could be using deep neural networks, reinforcement learning, or some other technique. You do it at the analytics server, but then you download the model at DU or CU, because there are certain use cases where the timing constraints are very stringent. So in certain use cases, it's potentially advantageous to download the model. You continue doing the training, but you download the model on DU and CU and use it for more real-time decision making. And of course, the model training can continue offline, can continue at a different server, and all the updates can keep coming, right? In future, it's possible that for some of the very critical use cases, you could also do the training also at, or some level of training at CU, UPA, and DU, right? Or maybe do it in more distributed manner. So basically then with the inference, you will get which cell to activate or deactivate, or what's the handover strategy, right? Which use to offload and where to offload and so on. So basically from the RIC way, if you look from the standards angle, so the non-real-time control loops is you're talking like seconds and higher. So you could be taking decisions, let's say every few seconds or every few minutes. With a near real-time RIC, that's where also a lot of work happening there. The control loop is for 10 millisecond to 1 second. So 10 millisecond to 1000 second, right? And the third is real time. So real time is you as well doing something at DU, because if you look at the scheduler at DU, even for 15 kilohertz subspacing, your slot length is 1 millisecond, right? So that's where you're doing decision making. And with 30 kilohertz, I think with TDD spectrum that's there in India and so on, slot length could be it is 0.5 millisecond, right? So that's where you're taking a lot of decision. And with millimeter wave, it's 0.125 millisecond. So in some cases, this could potentially run at DU itself. It will need to be run at DU, or you download, you train somewhere and download the model, but at least the model needs to run there, right? So in terms of RIC, this is non-real-time RIC. So these are the RFs, right? So normally vendor will provide, memory provides, and there could be other vendors, right, to provide the RIC platform. And these are the RFs which are running there for non-real-time RIC. And these are some of the functions. So RIC platform will provide data management. So you're collecting data from different nodes, which can be used for different RFs. This will provide AML workflow functions. That's for non-real-time. This is for near real-time RIC. So near real-time RIC has all these accepts. So this is more like near real-time, right? So you could use it for, decisions like traffic steering, for example, or let's say slicing, right? You could use non-real-time as well as near real-time. It depends on the use case. So again, memory provides, and basically vendors will provide this near real-time RIC platforms in this case, right? And accepts can come from different suppliers. And this will basically this platform will give you access to the data that you're collecting, in the GNOD or from the UEs. It will have all the AIML support and so on. I'll talk a bit about the security aspects, after a few slides. So just to give very top level way of how it's working. So it's basically E2 node is your DU or CU here. And you have this near real-time RIC, and basically the E2 node will advertise what kind of capability it's supporting for the RIC, right? What kind of parameters supports and so on. And then the near real-time RIC application there, it can subscribe to certain certain parameters, and it can tell when to give the reports, like you give it periodically or give it based on certain events. And then the report is given to the RIC, right? And how it could potentially be used, there are many ways. This is one way. So it's in this, without getting into the nitty-gritty details here, but it's pretty straightforward. So if you look at E2 node, so E2 node could be DU or CU. Let's say it's CU, right, where you're taking mobility decisions. And then basically you are getting the reports, and when it's taking the mobility decision, the E2 node is sending an insert message to the RIC. So it's while taking mobility decision, it's going to suspend the activities. It's going to send an insert message to the RIC server, and where the decision making is done at the RIC server, and you get the results, right? And then it continues. And there, of course, it starts timer, and if timer times out, it takes certain actions, right? So decision making could happen at RIC server, and like I said, in other models, there could be use cases where you would download the model itself at DU or CU. Okay, network slicing, that's the third part. I think the next is security. So slicing, I think, as you all know, so there could be different kind of slices. But I think this figure I put is like basically what could happen is you may want to, like in this figure, like it's for more and there are 2 slices, but so RU and DUs are shared. CU-CP is also shared, but you have different CU-UP instances. You see the green and the blue. So slicing, of course, gives you resource reservation, resource isolation. So even in DU, it gives you resource isolation, but you can also have different CU-UP instances, right? So let's say one enterprise has a slice, and that enterprise can say, okay, all my data should go from a different CU-UP instance, right? That's possible. So you can create different CU-UP instances. And some of the slices are standardized, like EMBB, URLLC, massive IoT, V2X, high performance machine type communications, and of course, one can add other type of slices. And okay, I'm going to skip this. Okay, so in terms of resource isolation for slicing, so like CU, I was saying you could have different CU-UP instances for different slices, right? So that's one way of doing resource isolation. And then in DU, also, I mean, the slicing data model allows you to do resource isolation. So in fact, this data model is applicable to different resources that are available in Keynote B at DU as well as CU. So for example, if you look at this figure, it's a data model. So what this is saying is like you could have different resources. Resources like in DU, they could be resource block or the PRBs, right? Part of the spectrum that you have reslot. Or resources could also be the number of users you want to support, or resources could be number of PDU sessions that you're going to support in a slice, right? And so some of those things could be controlled at DU. For example, the PRBs, the resource blocks you're going to have at DU. Some of these will be controlled at CU, like the number of users, number of PDU sessions in that slice, and so on. And this model basically says that, like it basically says like these are all in percentage. So you can say for a given slice, I'm going to use 5% dedicated resources, let's say DU. So in terms of resource blocks, I'm going to reserve 5% resource blocks for that particular slice. And let's say over every slot or over a time interval, right? And if nobody manages those, these are like just reserved for that, So when basically the scheduler that we are running at DU, right? So that scheduler is typically, if you look at 4G world, it was like per flow scheduler. So scheduler gets enhanced here for slice awareness. So these are like dedicated resources for the slice, Then you have prioritized resources. So prioritized resources are like you would have again. You have 2 slices, so there are certain resources could be prioritized for each of the slice, right? And then like you could have prioritized set of our resource blocks. So then that's like basically if the slice wants to use, if the slice has enough traffic, it can use it. If the slice is not able to use because it doesn't have, let's say, data pending in that particular time interval, it may not use it, right? So prioritize is like dedicated, but the difference is like other slices can use it when this slice is not using it. And then you have like the shared resources which can be shared across many slices, right? So basically, I think that gives resource isolation, which is an important part. And this can happen like, so on CU-UP, you get the resource isolation in terms of CU-UP instances. And then you can get this isolation in terms of resource blocks, number of users, PDU sessions, and so on. So again, back to the RIC part, a lot of work happening, using RIC analytics or different AIML techniques, to optimize performance for the slicing. So like one is the slice assurance. So basically, so the user may give, let's say the slice may be given to different enterprises, right? And let's say one enterprise wants slice SLA of 200 Mbps. It may say I'm going to have, let's say, 50 UEs, max 50 UEs at a time, right? And it could also have some latency constraints, right? And there could be another customer which has another SLA, right, in terms of aggregate throughput, okay, number of UEs and so on, right? And then the question is, but if you look from DU and CU angle, we do need to get down into the data model that I was showing. So like what are the dedicated resources, what are prioritized resources, what are shared resources, and so on. So a lot of work happening in the area of slice assurance. I will speed it up. I think time is up. I'll just finish it in 5 minutes, getting to security. Resource allocation optimization for network slicing. Multi-vendor slices. Slices could be by multiple vendors. For example, an operator may want to use slice of certain EMBB type from one vendor and URLLC slice from another vendor, right? So work is happening to standardize that. Okay. So I'll try to go through the security aspects in 5 minutes. So like in 4G, I think it got covered some of it earlier. So you have USIM, I mean you have IMSI, and some of it could be sent in clear text over the air. With 5G, you have SUPI, SOP, subscriber permanent identity, but you use the public key of the home network to basically compute as SOC or a subscriber concealed identifier. So you're not sending the UE identity in plain text over the network, right? The second thing is in 4G networks, some of the decisions were taken by the, like when you do authentication key agreement, some of the decisions were taken by the serving network. In this case, home network is taking some of these decisions. And these are like the algorithms that are used for ciphering integrity protection for user plane and control plane. So like basically user plane, let's say PDCP level, which is UUP. So you do ciphering and integrity protection, which is supported and can be used. And for control plane, which is like RRC and NAS, you can use integrity protection and ciphering again. So integrity protection is mandatory for most of the RRC and NAS messages, except for some RRC messages that are exchanged in the beginning. Subscriber privacy, like we talked about SOP and SOC. Authentication key management. So you have AKI mechanisms because 5G is also going to be used for like private enterprises. It will also give services to non-cellular technologies like Wi-Fi and so on. It happened in 4G also. So you have this AKA. You can also use AKA. You can use ETLS, right? You could have, because you could have devices which do not have SIM card, right? So you can use ETLS because with AK and so on, you need to have SIM card. With ETLS, you could use devices which do not have SIM card, and they could still access 5G network, right? Key management. So like just to highlight this. So now if you look at this, top part is the home network, bottom is the serving network. So now some of the decision making. So like if you see, look at the AUSF. So there are like multiple levels of, the higher levels of key generation, key derivation in this architecture. And then, some of the decision making is happening at the home P element, not just at service P element. I think I'll skip this. Okay, the overrun attack surface. So these are like different interfaces or different functional entities which need to be protected in overrun. And, so some of these interfaces come from 3GPP, some are in overrun. So like the different security protocols that are used, like TLS 1.2, 1.3, IPsec. So IPsec is being used for E2, F1U, XNU, NGU, TLS like for one interface, A1 interface, open and front of AMP plane, SSH, secure shell 2, DTLS, IEEE 802.1x on the RU side. So these are like, different security protocols that are, some of these are standardized, some are being discussed. Again, these are like the F1, E1, and XN, NG interfaces. So these are like 3GPP interfaces. These are protected using IPsec, TLS for data plane, for the control plane, and like IPsec for the data plane. In terms of near real-time RIC APIs, so because you have transactional APIs, like basically, like let's say when you RF, right? RF on the RIC platform, you have gets, your transactional APIs there, which are using REST and gRPC. And then you have time-critical APIs like E2, right? So they're also protected. So like in this case, the A1 interface, you do mutual authentication, ciphering, integrity protection, and with the RF side, the R1 interface. So these are all protected. This is the SMO, again, part of the ORAN architecture. This is protected using MTLS, like again, you do mutual authentication, and then use TLS with the shared key, for example. Okay, so I think the last slide. So some challenges, of course, a lot of AML work continues in this area. Or even analytics work doesn't have to be AML work, right? You want to collect information, use it to take certain decisions, right? Could be pure statistical techniques. And then as we evolve from like non-real time to near real time to real time use cases, like millimeter wave, you're talking about 0.125 millisecond slot length, right? How do you achieve it? And of course, that's of course a lot of work continues in this area, I will say. Other thing is like mid-halls. So typically we work with, good and I will say bad mid-halls. We work with mid-halls that typically operators provide. But so like mid-hall could have packet error rate of 1%. Because see, if you compare with the monolithic vendors, so in the monolithic case, there is no mid-hall in a way, because DU and CU are part of the G node B. So there is no packet, this packet error rate is 0 there, right? Here you could have like mid-hall, DU, CU could be located few hundred kilometers away. You could have packet error rate of 1%, you could have latency, and then you could have packet error rate of 10% and higher, right? So we take that into account. But of course, if you have a network where it's like, extremely unreliable, let's say you have 30% packet rate over the middle, or it's very much higher latency, then of course there's scope to optimize it, right? And that's another work which continues. URLLC, you know, that's like URLLC or V2X and so on, right? How to adapt the architectures for URLLC and V2X constraints. Okay, thanks, I think. Yeah.
Thank you, Dr. Dhaneja. So we'll quickly take up some of the questions. Yes, sir, please introduce yourself and shoot the question.
That there was a chip on a system, so it was noticed after some time. Basically, I mean that the chip is for collection of the data. How it transmits it to the intended person?
Okay, so yeah, so okay, so you're talking about the Supermicro chip, right?
Yeah, you said when Amazon and Apple were affected.
Right. So so ideally this, actually I'm not very sure about the working of this. Nothing much has been disclosed. But the fact is that maybe this has been placed in a strategic point by which you can maybe have control of the network interface or redirect traffic, maybe which was going to the DRAM or to the memory into the network interface. So what is just required is from a hardware perspective, you need to modify the chip select or things like that, right? So in some sense, right, so it's, what I can visualize it as something like a traffic light. You just move traffic somewhere else as well. So,
I agree. Probably they would have been routing it to the intended server.
Yes.
Is there any test, when do we test hardware? Do we test where the traffic is routed? Give us some artificial traffic generator and see whether it gets routed, so that unintended traffic routing can be done?
So that's a good point. Now, most of these Trojans, or all of the Trojans, are typically passive.
Yeah.
So in the sense that maybe you buy a Supermicro chip motherboard today, you'll not notice anything maybe for the next 5 or 6 years, right? When it gets activated due to some way externally, then you'll actually see a change in behavior, right? But the testing phase is not, we typically test for maximum 1 month or so, right? Not for a longer duration of time. So the fact is that your system is going to behave in a normal way until it has been activated. And the activation comes from the trigger, which is external.
That means periodically in our testing mechanism, at the end of the first year, second year, we should measure the traffic where it flows. And if anywhere unintended IP address is flowing, we then should take it as security risk.
Something like that, yeah. Periodic, I don't think it will solve the purpose, because externally your attacker may turn on the Trojan or trigger the Trojan and also turn it off at a later time, right? So, so periodicity may help to some extent, but may not.
So that means random check only will be useful.
Right.
So that should be part of a security policy of wherever we take a chips also.
Exactly.
So is it thought of in any of the security policies?
Not that I know of. Not that.
Do you recommend such a test?
I think it should, right?
Because why I'm asking, we conduct a security audit of the networks.
Correct.
So as we see, nothing will be visible, but next day itself it may happen.
True.
So how to cover up such unintended risk?
Okay, so there are two ways, right? So one is the auditing may not always actually work, because these triggers may come at a random interval, and highly unlikely your audit would actually coincide with that trigger, so trigger time. What actually would be required is something more of a real-time detection. So a detection where continuously you're monitoring, or you have a small gadget or a device which continuously monitors every traffic that is going on at a continuous period. It's not just periodically, but every traffic, right? Searching for anomalies.
Hello. Yeah. Thank you, Professor. Okay, sir.
Yeah, myself Murali Krishna, DDG TC. So I have one question, but linked to two different scenarios. See, one, in case of hardware Trojans, you've seen that unintended chips have been put in at some stage of the entire life production cycle, or at the chip design, not design, at production cycle of the chip. Okay, manufacturing, PCBs, etc. Similarly, in case of software, you are telling that bits of bits of software developed and then get integrated somewhere. It gets some unintended way or intended gets integrated. But the question here is, in case of software, OS developer has to take the ultimate responsibility. Once you know you laid the blueprint of the thing that how it should be, then is it not possible to check at that stage and then before releasing it to the market? That is one. Yeah. Secondly, connected to the hardware also, similarly, before giving you as a manufacturer, I mean as a developer, we finalize the blueprint for the manufacturing of a particular PCB or a layout. Then when it comes back to me, is it not my responsibility to check and release to market?
Okay, so these are very good questions, right? I'll answer the first one. So if you take the Linux kernel, for instance, right? So today, as on date, there are 35 million lines of code. Okay, and out of which any insertion like this Trojan that we've been discussing would be not more than 10 to 15 lines, right? So ideally, you're essentially searching for a needle in this haystack, right? So even though testing is done, it's very easy to essentially bypass these tests, right? The same actually holds for the other aspect as well, right? So in the hardware as well, it actually becomes far more difficult because in the hardware you fabricate a chip and you essentially get back this IC. You do not know what has actually changed. So the current way, as we discussed, using visual means, using optical and SEM means, it is still a challenge because the size of the Trojan is very, very small. It may be like 15 or 20 or to 30 gates, while your design may be having, your entire hardware, your IC may be having about 1 million gates, right? So finding these things is essentially a challenge. But that's something we need to do to actually get the required assurance. Yes, yes. I think the process should be throughout, right? Like you did mention, it should be with the OEMs, but it should also be with the third parties who are related with these OEMs and so on, right? So there should be assurance along the entire supply chain.
Thank you, Professor, for a insightful and I would say rather scary also, because when you said in that context of general, when you say in that context, it's difficult to find, hardware Trojan, that's more difficult to find a life in the planet. So I will ask at this point of times, what are the tools and techniques available to, let's say I'm buying a piece of server or COTS, to make sure they are Trojan free?
Okay, so yeah, as of now, as I did mention, like commercially there are no tools. So what is actually happening globally, of course I know the university perspective because I interact with multiple universities, but I'm sure there are government initiatives in various countries as well, is the aspect of using microscopy, using X-rays to essentially, they open up the chip, they essentially look into these chips, like the images that I've shown in the slides, searching for specific anomalies which could possibly be Trojans, right, or backdoors or anything, right? So currently this is the state of art. There are, in the literature, there are a lot of other things that have been published, such as using side channels, looking at the emission radiated from an IC, and looking for something specific or specific signatures within that. But my honest opinion with these techniques is that it will not scale to large chips or commercial chips. They may work, but not always. So I would say the only way to go ahead is by these optical techniques. As of now, that's the only thing we have in our market. Such checks are not done as of now. I don't think so globally, but this is something that we need to go through.
Good afternoon. Professor. I'm Hari Prasad from SETS Chennai. My question is about the challenges in retrofitting. Is it possible to do that for all the COTS devices, or
Hi, Hari. So, yeah, very good question. Retrofitting, yeah, that is something which it is very much limited. So there is this concept of binary rewriting, which is, first of all, doing anything in the binary is challenging, but now we also want binary rewriting. So it is a challenge. And secondly, if you essentially have a trusted boot, secure boot or things like that, it also requires modification of the secure boot, which is not always possible. Because especially if you look at, say, ARM chips or chips which from organizations like Qualcomm, the underlying boot up process is essential, and the security, the secure boot and integrity of the firmware, it is all validated, or it's in the control of these organizations, right? So it's almost, it's very difficult to bypass these checks. There are ways, but in practice, it's going to be quite a challenge. So this being said, there are a lot of other devices where, which do not have these secure boots or these basic underlying things, steps. In such a case, it would become an easier way. So we would require handles to first bypass secure boot, and then only then could go ahead.
Hello, good afternoon. Hello, so good afternoon. It's question to Professor again. So I am Nitish from Extend Networks. So my questions related to COTS software security flaw check. So you said if we get software code, you will run some tests. And if you don't get, you will binary, it will reverse engineer to high level language and that flaw check will be done. So my question is related to if it is say copyrighted software or patented software, how you will address this kind of reverse engineering or basically get access into the source code. So how it works?
Yeah, I don't have an answer for that because, yeah, but so these I am assuming are government initiatives, and therefore it is part of the process, right? So part of the certification which mandates that even if you don't get the source code, you should be able to at least extract the firmware out. There are a lot of things which the companies or the OEMs itself can do, like obfuscate the source code and so on. This is also happening, yes, which would make things far more difficult for us to understand. Right. This being said, yeah, my thought is that as long as we are restricted to a government policy or things like from a government organization, I hope that there will not be a copyright violation.
Thank you, Professor.
Hardware security. Otherwise, we'll move on to the open RAN or RAN security. So I'll take only one question, please.
I don't remember your name. The question, you have implemented your network with non-standalone architecture. As per my understanding on non-standalone architecture, LTE cell sites will be used in the voice over NR. So ducting effect is already existing in the LTE in 4G. So when a subscriber of 5G is using your voice over NR on in an LTE cell sites, will the ducting effect will come? I do understand this ducting effect in TD and TDD mode can be nullified using a high-rise cell sites. So are you facing practically in the existing 5G non-standalone architecture rollout? Is it my question is clear?
Yeah, it's clear. Sir, on 5G NSA, we are running voice on 4G network only.
Yeah.
The data only rides on the 5G
yeah,
new
that
radio.
I'm aware. That I'm aware.
So it's normal VoLTE, and the challenges of ducting wherein the environmental changes are happening and then you get the ducting effect. Ducting is actually you get the far end signal reflected back.
Correct.
So we have a platform or automatic tool which actually predicts this and then do act on this.
Can you name the tool which is developed internally in Airtel?
Yeah,
so that it will be open to other operators also, like Vodafone Idea. But Jio has gone for standalone architecture, so they don't have any problem.
It doesn't have a relation with the standalone versus non-standalone.
No, but see, I am coming into the practical aspects. Only in a non-standalone, you will be sharing for voice over on cell sites of LTE, where the already existing 4G is having the ducting problem. You understood what I'm trying to tell you?
I got the problem, but the ducting is actually related to the radio.
Correct. That's
right?
what I'm telling.
The radio, whether it is 4G or whether it is 5G, ducting will prevail.
Yeah, but if you have already installed a not an high-rise cell sites, and the customer is latching on that cell site where he is going to use for a voice over NR, then he will have that problem, no? You understand? Think practically. See, everything is dynamic. Like professor is telling, dynamically you have to check the load on the microchip. Random checking is not allowed for the security purpose. So same holds good for a radio's location. This one also, no?
No, that's fine. No, what I'm actually trying to say is the problem stays in 5G, SA versus NSA in equal. It's actually not about that. Ducting is a radio problem, it's not a core network problem.
But SA is not going to sit on the LTE cell site. It will have its own cell site where you would have taken care while installed, because 5G you are installed after facing the problem in ducting effect in 4G.
Yeah.
So you will not provide a high-rise cell site. See, it's a very thumb rule. See, everybody learns from his experience. So you have learned ducting effect in 4G cell site installation. Yeah. Am I right? Even Deticon, which is a German consultant in India, is not aware of the ducting cell site. You are aware of that. And after India has set up, and it is all over the world, ducting effect was talking about. Am I right or not?
Yeah. I think we can discuss this question offline in the lunch itself.
Yeah.
So I'll take my radio experts and then I'll answer this.
Yeah. Second question to the professor, Dr. Mavenor, no? You were talking about RAN intelligent controller is a very important component in the ORAN. I want to know, XApps is an application that is running on the RAN intelligent controller, which is for real time, this one. Because if you see VMware architecture, they have implemented, they have used the concept from the Cohere technology for maximum spectral efficiency in MU-MIO technique. Are you implementing in your Mavenar this one? Is my question is clear?
Yeah. So I think I can't exactly answer your question, but what I can say is, so there a lot of work is happening, in terms of like how you predict channel conditions and how we use it to, let's say, improve spectrum efficiency, radio resource management algorithms, and so on. And we also work very actively in that. Now, the specific question that you said, so the Cohere, I cannot answer here, but I know, but I can't answer here. So, but we do work on those technologies and the algorithms and so on, that I can say for sure.
Because it's a startup company.
Yeah, I know. So, but basically it's about channel prediction.
Because it is it's not a very big company like Nokia and all these things.
See, in public domain, if you go with the public domain information, Mavneer has an MOU with them. If you do a Google search, you will find it, Mavneer and Cohere. But there are a lot of aspects there, like how do you predict channels and how do you really use it to improve spectrum efficiency, schedulers and so on, and so we do a lot of our work also.
Because I asked this question to Paul Raj, who is a founder of MIMO concept itself. He came to IIT Madras for a conference. He was also not able to provide me a proper reply. So that's what, since you are a vendor, I thought you will be able to have a handshake with VMware and found out with
No, so see, we have our own solutions also, so that's what I'm saying. So we have our own solutions in this area, but these are not deployed solutions. So because I can't give the roadmaps here, we can talk separately if you want. But we have a lot of internal work happening in this area. That's what I can say. Yeah.
Okay. This is Pranav Singh from academia. We are basically manufacturer of eSIM, SIM, and even the biometrics equipments. Even the facial recognition system we are having a very in large scale. You are experiencing the technology in DigiYatra. Here, I don't have any question, but I am totally aligned with your presentation. That was very wonderful presentation. We are having our own design house for the chip, and module packaging we are doing here itself in India, in Noida. And first of all, that is the software. You are talking about the process. In fact, how the secure software development cycle could be. The process is already, I think, STQC is given, that is Trusted Electronic Value Chain certificate scheme, and that is based on the ISO 20243. And that is wonderful document, you can say, and this totally keeps the secure software development cycle, even the supply chain till end customer. So second one is that you are very much right. The source code giving to the for the testing is having the IP challenge, but in case of binary, it is decompilation is really having a very much challenge. But in case of processes, we can really implement this, the secure software development cycle process. And second, we are aligned with you. That is as how the testing is going on. We are having the experiences of around 10 years knowledge, 20 years knowledge base for the vulnerability testing. So it is itself we are doing it in our chip and all these things. We are having a security team of 20 software developers and even mathematicians. They are doing this. So really we are totally aligned with this. This was really wonderful presentation. We are highlighting these points from last 10 years to the in each forum. Thank you. Thank you very much, sir.
We are going to take only one question due to paucity of time. Mr. Krishnan, yes.
My name is Krishnan. I'm from Delta Phi Labs, one of the TSTLs in the process. My question is to the professor. We load a lot of drivers for pretty much everything without batting an eyelid. How can we secure, check for security on a driver? I get your JTAG, and it's easy to tap a JTAG pretty much any device. Nobody locks it down in any case, except in certain very tight military or conditions. But for firmware, for pretty much, and drivers specifically, how would you suggest that we should approach from a security point of view?
Yeah.
Thank you.
So speaking from the Linux kernel perspective, I think the drivers is where the culprit is, right? So yeah, we do, and most of the kernel vulnerabilities that are found these days are mostly from the drivers. So yeah, so the validation, I'm not saying it's an easy solution, right? Because by itself, the driver may not have vulnerabilities, but when it gets into the kernel, then the interplay with other modules could actually make things much more complex, right? So, the fine-grained analysis using the static analysis would help, provided we are able to scale up to something as large as the kernel. Personally, at IIT Madras, we are trying various things, specifically for driver, looking at drivers in the kernel, specifically looking at vulnerabilities. We are using more formal techniques, specifically using SMT solving, solvers, symbolic execution at the driver level in the kernel. So there is no foolproof answer for your thing, but that's an area which needs to be worked on.
Thank you all. Over to MC.
Thank you so much for that wonderful session. I'm sure they deserve a big round of applause from all of us for that. Thank you. Moderator, sir, please hand over mementos to our speakers. Professor Chester Ribeiro, sir, thank you. Sanjeev ji, thank you so much. Let's hear that for Dr. Mukesh. Thank you, sir. Yes, we'll take a group picture. Thank you so much for that wonderful and very insightful session. And thank you so much for being so kind and patient with us. I know everyone is hungry, so we'll head for lunch. And we'll see you back at 2:15 for our next session. Requesting you all to please come back by 2:15. Thank you.
14:15. एक मिनट इनका वो जाने रुको 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 Yeah, good afternoon, Miss Park.
Do you hear me well?
Good. Miss Park, can you hear us?
Yes.
Yeah. So we would be starting by 14:15 hours Indian Standard Time. Your voice is also audible here.
Yes. When do we start from?
Another 30 minutes from now. Miss Park, did you hear us?
Yes, and Professor Hunyorian will start first, and then I can handle the last of the session of our slot. So
Okay, thank you.
do you want me to control the screen for the our presentation?
Yeah, you can control the screen. It would be better for us.
All right. Thank you.
Can you switch on your video feed for a moment, just for confirmation?
Okay, sure. Let me give it 1 sec.
Yeah, we are able to see you.
Hello, nice to meet you.
Yeah. Yeah, good afternoon, Professor.
So, yes, I think we will present in 30 minutes.
Next 30 minutes, we would be meeting you.
Okay. So I will waiting for you. And then I assume that Songche will control the screen.
Yes, sir.
Thank you. And then I see the conference that if there is a presentation was done,
for you. Washing down on you, breaking all the rules. One day soon you'll see, from my point of view. Why do we always have to figure it out? The past, the present, and the future all at once. And I don't know the reason why we fight. And I don't know the reason why we lie. And I don't know the reason Why do we always fall in love? Why do we always fall in love?
1 सेकंड हमने चेक कर लिया है सर पहले तो चेक कर लिया चेक तो कर लिया
गुड आफ्टरनून प्रोफेसर
सर
Hello. Good afternoon, Professor. Am I audible? This is P.K. Singh, your colleague
Yes, I
in
can hear you
SG17.
clearly.
Yeah, we are
Nice
also
to meet
able
you.
to listen to you very clearly. We are waiting for another 5 minutes, then we'll start the session.
Okay.
Yeah.
I will wait 5 minutes.
Yeah, thank you.
Thank you.
He was the moderator.
This is online, is it?
Online WebEx.
No, ये मेरा copy है आपका.
ये मेरा है.
A quick one. One is online. The one after that is mine. So I pad up somewhere in between, or for the mic. Or how do you want me to do it? You let me know, right? I'm sitting right here. Yeah, so. Sure. Got it.
I think you can start the proceedings.
Only who is the person who is invited? No. Okay.
Ashish.
First speaker is online.
First and second. There are two speakers in first.
Zo Sunche Park. First one is doctor.
Dr. Hang Yu Yun.
The second is also online.
Both. No, which is second one? Park. No. She's also online.
Third speaker is
Speaker is also online.
Shankar Srinivasan.
She's also online.
अभी जो आया
That is not offline.
ऑफलाइन अभी आया ना रवि अतुल देश पांडे
Of the three, I'm Shankar. I'm the only person who's going to be joining online here, right here.
Okay.
The other two are not joining online.
Atul Deshpande is not there.
Right.
And so also Ravi.
Ravi is also not joining. So it's just me.
He'll take care.
Yeah.
Single-handed.
so I don't introduce them no So welcome back. We hope you had good lunch. Yes. Are you all ready? Shall we have your permission to begin, sir? Okay. So we'll introduce our moderator first to you. We have Shri P.K. Singh, DDG SA DOT. So please join us on the dais. Shri Pushpendra Kumar Singh, an Indian Telecom Service Officer of the 89 batch. He has been heading the Security Assurance Vertical in Department of Telecommunications since 2020. He has a vast experience in laying down the technical specifications for various telecom products, network elements, testing and evaluating them against laid down specifications and international standards. He comes with many years of experience in the regulation and enforcement of the telecom sector while working in Department of Telecommunications field offices at Delhi, Lucknow and Meerut. He has a very good experience in telecommunication security while working in Ministry of Communications at Delhi. Welcome, sir. May I request Shri Ashish to please present a bouquet to our moderator. So we begin with our first speaker. He is present with us online. It's going to be a virtual session. We have Dr. Hyung Yul Yum, Chairman of ITU TSG 17 Security, working as Commissioner Non-Standing for the Personal Information Protection Commission, Government of Korea, from August 2020, and as a Professor for the Department of Information Security, Engineering of the Sunchunyang University, Korea, from September 90. He is currently the Director of SCH Cybersecurity Research Center from December 13. He is a Chairman of the ISMS PIMS Certification Committee in Korea from 2007 and a Board Director for Korea Information Security Agency from 2019. He is also Chairman of Steering Committee for the Korea Zero Trust and Software Supply Chain Security from 2022. Welcoming Dr. Hyun Yul Yum online.
Thank you very much for your kind introductions. So actually this material has been prepared by myself and my team members, Songchae Park, working for my centers. So some of the material, some part of the material has been provided by KISA, Korea Internet and Security Agencies, and also Ministry of Science and ICTs. And first of all, I thank you for organizers for inviting me to this very precious conference on 5G network securities. And then also it's very pleased for me to present these materials. The title of this presentation is Experience on 5G Security Assessments in Korea, since I am a chairman of the ITT Study Group 17 work of security. So I included some of the materials to introduce AITT Study Group 17 standardization work. So next slide. So next slide is a content. So currently, first I briefly introduce the overview of the 5G network in Korea, and then I will give an overview of 5G Security Council in Korea, and then we have a information security products evaluation and certification scheme currently in place in Korea. And then I will introduce a security assessment scheme for IoT devices in Korea. And then recently, Korean government introduced a new certification scheme, so-called the rapid confirmation schemes for emerging technologies, including 5G network equipment, which we introduced. And then ITOT Study Group 17 5G security work will be presented. Next slide, please. Introduction for the 5G network in Korea. So next slide. Korea launched the world first network-wide 5G mobile network on April 3rd, 2019. I believe that 2 hours early than a US network mobile operators. We believe that the 5G system will bring a smartphone near instantaneous connectivity that is 20 times faster than existing 4G, allowing users to download entire movies in less than a second. As of March 2023, South Korea had approximately 29.6 million 5G subscribers. So please note that Korean population is 50 millions. So most of the, I believe that 6% of the Korean population are using 5G services nowadays. Next slide, please. If there is a positive side negative side is a security instance. Recently, I believe that in end of January this year, so one of the big mobile operators, we suffered a DDoS attacks due to the insufficient management. Core network information was exposed to outside, which became a target for the router attacks. Actually, attackers gathered information and then used that information to identify some of the vulnerabilities of the operator routers. We call a BGP ports. Actually, this BGP port should not be visible to outside of the mobile operators. But unfortunately, that BGP port was seen to the outside of the attacker, and then attacker used that a vulnerability to launch a DDoS attacks. Actually, this slide information has been provided by the KISA, Korea Internet and Security Agencies. Next slide, please. So I will briefly introduce a 5G Security Council in Korea and its associated security assessment schemes. So next slide, please. 5G Security Council in Korea is to identify security issues and develop a security measures for safe 5G network implementations to support the world's first 5G commercialization and expansion strategy. Actually, it was established under the auspices of Ministry of Science and ICT, Korea, in August 2019. And then actually, this council has a 3 working group on policy, working group on technology, and then working group on standardizations. Next slide, please. As I mentioned, this slide shows a organization of Korea 5G Security Council, and then policy, there is a policy working groups. Actually, secretary organization is KISA, Korea Internet Security Agencies, and there is a technical working group. Secretary organization is ETRI, Electronic Telecommunication Research Institute, and then standardization working group. Actually, secretary organization is TTA, Telecommunication Technology Associations. Actually, they the TOR is of the policy working group is to analyze a domestic and foreign policy issues related to the 5G securities. And then technical working group TOR is to develop and then review the technical security requirements for protection of 5G infrastructure. And then TOR of the standardization working group is to develop a 5G security roadmap or standardization roadmap and the international standardization activities. Next slide, please. So actually, I am chairman of this council, and then most of the important activities of this 5G Security Council is to conduct a security checking for the 5G network elements, in particular, the base station deployed by 3 local mobile carriers. We have currently 3 mobile operators, KT, and then SK Telecom and the LU Plus. So that is a main objective of this 5G Security Council. And then each working group meet every quarters, and then strict committee meets once a year. And next slide, please. Actually, as I mentioned, members of this 5G Security Council, Ministry of Science and ICT, one of the members, and then Korea Telecom, SK Telecom, LU Plus, three major mobile operators are joining the 5G Security Council, and then KISA, Korea Internet Security Agencies, ETRI, and then TTA, and then IITP, Institute of Information and Communication Technology Planning and Evaluation. Actually, this IITP is responsible for ministry to establish a new R&D topics and then support the R&D projects which will be carried out, for example, ETRI, KISA, and the other organizations in Korea. And then major Korean industry, for example, SK Shielders, Penta Security, are joining this 5G Security Council, and also several associations are joining, and then academia, including my university and the Korean University, are joining this 5G Security Council. Next slide, please. So I will briefly introduce the activities done by 5G Security Council since establishments. First is to discuss a 5G security issues. So by reviewing the overall 5G security issues, including study of the security issues in each subdivision, such as 5G security policies, technologies, and standards, and then discussion on the security enhancement measures. And then as I mentioned before, the most important missions of this council is to conduct a security checking for the 5G base stations operated by 3 mobile operators to check the security and stability and then support them to improve through the technical consultations. Actually, as I mentioned before, we have 3 mobile carriers, SKT, KT, LU+. They deploy a base stations which are normally provided by Samsung, Nokia, Ericsson, and Huawei. So actually, this support for the development and improvement of the 5G security checking items were carried out by this council, actually on-site security checking and then identifying of the supplementing items. There are 116 checking items. So actually, later of this slide, later part of this, I will give a checking items details. And then another mission is to conduct a global corporations. We hosted a global 5G security workshop to share experiences for 5G issues, response directions, and then threat response with other global operators such as Orange in France, KDDI in Japan, Telus in Canada, and Deutsche Telekom in Germany. And then last mission is to provide a response to the security issues. So that is the main 4 areas this 5G Security Council. Next slide, please. So normally, we recognize base station is a very critical network element for the 5G security. So normally, security checking was done to the 5G base stations. Security checking criteria can be classified into two areas, items for checking security functions, and then items for checking operations. There are 54 security checking items in area of security functions, and there are 62 items for checking operations. And if you look at there are several areas for security functions. First area is identification and authentication. So, for example, mandatory change of the default administrator's password. That is one thing we need to check. That needs to be checked by auditing teams. And then there are several other checking items. And also in the area of the operations, there are 7 sub-items in the area of the sub-areas of the log management, security patching, and backup files. So for example, for the security patches, auditing team check if the security patch use the integrity verification function when distributing product updates such as equipment, firmware, OS, and patches. So that is a main security checking items. Next slide, please. So actually, this is the result of the security assessment reports. So this is not a third-party assessment, but a self-assessment. So security assessment will be conducted by operator itself, and then report will be submitted to the council, and then council will review the reports. So currently, assessment target is focusing on 5G security, 5G base station, known as a data unit, and then produced by Samsung, Nokia, Ericsson, and Huawei. And then after the self-security assessments, several vulnerabilities were identified, and then we asked them, manufacturers, to remedy the vulnerabilities. So each manufacturer was asked to treat vulnerability for their product. Next slide, please. And then this is a future for the assessment for the 5G network equipments. Plan is to consider expanding the evaluation target to cover all 5G network elements in core network, radio access network, etc., taking into account the GSMA network equipment security assurance schemes currently by GSMA. And then plan is to continue update the security checking criteria of the 5G base stations, and then consider the security assessment schemes for the IoT devices. Started December 2017, and then rapid confirmation schemes for equipment for the new and emerging technology started in 2023. Next slide, please. And this let me introduce the information security product evaluation and the certification scheme in Korea. Actually, the scheme, next slide, please. The scheme is called Security Confirmative Verification Scheme in Korea. Actually, the objective of this scheme is used to is used by the national and the public institutions in Korea. Actually, if there is a IT products with the security functions, and then if the IT products are certified by the some of those four schemes, I think that governments and then public institution in Korea can introduce into the government network and then organization network. So the example of the four certification scheme includes a domestic and international common criteria scheme, and then security function confirmation scheme, and then performance evaluation schemes, and then rapid confirmation schemes. Actually, in Korea, for the introduction policy, organizations are classified into three groups: top class, and then middle class, medium class, and then low class. So depending on the sensitivity that organization dealing, sensitivity of the information that organization dealing with, actually the introduction policy is different. So, for example, organization belongs to the group A can introduce only IT products that have been certified from the CC Common Criteria Certification, Security Function Confirmation Scheme, and the Performance Evaluation Schemes. Next slide, please. And then actually, that scheme is based on the, we have a legal basis in Article 20 of the basic guidelines for the network national information securities. And then actually, as I mentioned, the following are products that satisfy the requirements. The product registers on the safety verification product list through the pre-accredited certification test, such as a common criteria certification. So details will be provided in next slide. And then this is produced. Actually, there is a next free certification processes. Actually, there are four schemes, so-called a free certifications. And then if IT products are certified by one of the four schemes, I assume you can see my presentations. I will continue, and then organization can introduce IT products, and then so those systems are supervised by NIS, National Information Services. Next slide, please. Actually, this is a governance of the information security product evaluation and certification schemes. So scheme is based on common criteria in ISO IEC 408, and then we have a 7 assurance level, and then examples of information security products may include firewall, IDS, VPN, spam filter, patch management systems, etc. And then left side, you can see the how organization structure is structured for a information security product evaluation and certification scheme. Actually, KISA act as a very critical laws, and then there is a NSR, and then Ministry of the Science and ICT act as a CC policy organizations. Next slide, please. And then rapid confirmation schemes for the emerging technologies, including 5G networks. Next slide, please. But we identified there are so many new and emerging products that has not a common criteria. That means that we cannot introduce that new systems into our public and government networks. So actually this new scheme, so-called a rapid confirmation scheme, has been introduced in 2022 based on act, so-called a Act for Information and Communication Network Promotion and Protections. Actually, so if we can use these new schemes to enable startups or SMEs with new and emerging products to be entered into the public sector, and then resulting in strengthening competitiveness in the information security instance. So actually, we introduce this one. Actually, as I mentioned, this scheme was introduced, and then we currently has a two products certified by these new schemes. Next slide, please. And then there are target of this scheme is to IT product with security functions, employing a new technology and converged technology. There are two areas: security checking. Security checking consists of vulnerability analysis, assessment, and software security weakness diagnosis, and then function. There are functions testing, and then security functions are carried out by the security checking agencies, actually appointed by our roles. And then functions testing also can be tested by the functional testing agencies, so-called KOLAS, authorized testing institute. So next slide, please. So let me briefly introduce the security certification scheme for IoT devices. Since IoT devices could be part of the 5G networks. Next slide, please. So the objective of this security certification scheme for IoT devices is to strengthen the safety of the citizens and the industrial competitiveness through the operations of the security certification systems for IoT devices. So target of assessment is IoT product and the mobile applications that work with the products. And then there are 3 assurance levels. light, basic, and standard. So this is a overview. And the next slide, please. So actually, this scheme is based on ITUT recommendation EXTA 1352, which was approved, I believe, that this year, March, security requirements for Internet of Things devices and gateways. In these recommendations, five security dimensions are defined. For example, authentications, cryptographies, data security, device platform security, and physical securities. Next slide, please. So Organization for IoT Security Assessment Scheme, Ministry act as a policy agencies, KISA act as certification agencies. There are currently two testing agencies. One is TTA, and then other one is KTC, and then testing, and there are testing and the certification criteria. Next slide, please. This is a certification criteria for IoT security assessments. As I mentioned, there are 7 areas. One of the areas is a identification and authentication, and then there are several sub criteria. For example, use of secure authentication information, use of authentication and assurance authority management. And then actually this common certification criteria is compatible with exact 1352. Next slide, please. So I will give my floor to my team, Ms. Sung-Chae Park, to present rest of this presentation. Sung-Chae, you have the floor.
So before Ms. Zoe takes over, I would like to take the pleasure of introducing our next speaker. We have Ms. Zo Sun-Chae Park, Manager and Senior Researcher of Cybersecurity Emerging Standards Center at Suncheon-yang University, Republic of Korea. She has extensive experience in the private sector, cybersecurity, security solution vendors, AI developers, and financial service providers from 2008 to 2021. She is also an editor of X.STSSC, X.SC IoT in cybersecurity, digital certificates, IoT security, and 5G and AMP, 6G security of ITUT Study Group 17. Currently, she is studying an integrated master's doctor's degree in information security engineering at the same university from 21. Welcoming Ms. Zoe Sun-Chae Park.
Hello, do you hear me well? I'd like to open my video first, so let me Hello.
Ma'am, we can hear you.
Yes. And do you see my screen that I shared again?
Yes, we can.
Yeah, thank you. Hello and good afternoon, everyone. My name is Zoe Sung-Chae Park from Suncheon-yang University in Korea. Currently, I work as senior researcher at the Emerging Cybersecurity Standardization Center of Suncheon-yang University, where I'm responsible for international standardization development and international cooperation in the field of security, such as 5G, 6G, and AI security technologies, and etc. Well, and I'm working with Professor Hoong-Yeol Yeom, who serves as the chairman of ITUT Study Group 17, and present earlier than me, and I'm pursuing a PhD degree under the guidance of the professor in Engineering and Information Security Department at Suncheon-yang University. So first of all, thank you for inviting me today and giving me the opportunity to present our our findings on 5G security standardization in ITOT Study Group 17.
Ma'am, just a reminder, we have 10 minutes to go for this session.
Right. Okay. So there's one thing that I'd like to mention before I start my presentation. This is about the term of 5G. ITUT uses the official term IMT 2020 when referring to 5G. So I will refer to it as IMT 2020 for the remainder of this presentation. So there are 6 recommendations for IMT 2020 in Study Group 17 as shown. And today, I'm going to focus on a select few in my presentation. We feel XDOT 1811 and XDOT 1814 and XDOT 1815 are the most important. So I'm moving for the 1811. But 1811 is security guidelines for applying quantum safe algorithms in IMT 2020 systems. And it introduces the security architecture of IMT 2020 systems and a security assessment of IMT 2020 systems when the commercial quantum computers are available. And it also covers the specifications for the use of quantum safe algorithms in IMT 2020. This is a highly significant matter because when the quantum computers are commercialized, many of the current applied cryptographic algorithms will be broken by quantum computing. This particularly applies to public key algorithms like RSA. So consequently, it is imperative to use quantum safe cryptographic algorithms designed to withstand attacks from quantum computers. For example, there are quantum safe symmetric key algorithms and asymmetric key algorithms. So quantum safe symmetric key algorithms refer to the fundamental symmetric crypto systems that have their key length extended, examples of which include block ciphers or hash functions. And you can also see the quantum safe symmetric key algorithms. And under the category of quantum safe asymmetric key algorithms as shown in the right side of the slide. And this is about XL 1814. It provides the security guidelines for the development of IMT 2020 communication systems, thus identifying all components related to security in IMT 2020 communication systems. As shown in the figure, the IMT 2020 network consists of 4 components, such as user equipment, radio access network, and transport network, and core network. And as we can see the slide, this is about the network slices. There are basically customized virtual network setups designed to fit specific requirements and purposes. These slides allow us to allocate network resources and services to particular groups or applications, making management and optimization much more efficient. So as I mentioned earlier, within the structure of IMT 2020, comprised of various components, the security threats can be broadly categorized into 3 aspects. These include well-known threats from software vulnerabilities, configuration mistakes, and flooding attacks. And threats from the infrastructure sharing and security threats from the network level, such as threats related to SDN, NFV, and network slicing and clouding computing. And the various threats can include DOS or DDoS, or more general attacks such as data breach, leak, theft, destruction, and manipulate of information, and etc. And in addition, we can say Oxford 1814 provides the detailed security capabilities and functions to address the various security threats arising from each components. For instance, to address the security threats in user equipment, there are capabilities and functions dedicated to ensuring user equipment security, such as malware prevention. So I'm going to the next slide. So this is about the X.1815 security guidelines and requirements for WIMP 2020 edge computing services. Edge computing is an emerging computing technology which refers to a range of networks and devices at or near the users. Edge is about processing data closer to where it's being generated, enabling processing at a greater speed and volumes, leading to a greater action lead results in real time. So as we see the slides, X.1815 provides deployment schemes of IMT 2020 edge computing services, especially from the operator's point of view. The figure illustrates the deployment scheme of IMT 2020 edge computing services. So I can say it's categorized into 3 types of data centers connected to the management domain in the figure. So edge data center, this offers mobile edge computing capabilities, facilitating IMT 2020 edge computing services, as well as gateway user plan and UPF functionalities. So a local data center, this provides GWU content delivery network for CDN and UPF functionalities. And you can see the area data center. This applies functionalities like gateway control plane, AMF, SMF, or LB IoT or IMS, among others. So the management domain is encompasses a cloud management platform, a network functions, a virtualization orchestrator, and a virtualized network function manager. So lastly, I would like to explain this recommendation also identifies security threats that can arise within the edge computing services and offers solutions for each layers. So that means not only does it cover security requirements for the infrastructure layer, network layer, but it also covers the security requirements for application layer. Additionally, X.1815 provides the capability guidelines for each layer specifically designed for edge computing services. So that concludes my presentation on the ITUT Study Group 17's international recommendations with a focus on 5G. So I will now hand it back to Professor Hyun Yam for our final summarization and conclusion remarks. Thank you for listening.
Thank you. So since time is very limited, so I briefly make a concluding remark. I believe the security and the privacy still are very critical. for building competence and security of the 5G systems. And then security by design and privacy by design principles should be considered for the entire life cycle of 5G. And then also assessment scheme for the 5G security and its assessment criteria should be standardized for improving the security level for 5G networks. And also recently ITOR Working Party 5D has approved a 6G vision documents. So I think that it is now to start studying IMT 2030 security, taking into account experience of the 5G security. Thank you very much for your attention. This is the end of our presentations. Thank you very much.
Thank you so much, sir. Thank you, ma'am.
Thank you, Professor Dr. Hyung Yul Yum and Zoe Sung Chipak for your excellent presentation on first sharing the experience of Korea in handling the security challenges in 5G network, and then giving a comprehensive work of the ITU Study Group 17 on IMT 2020 5G security requirements. It was an excellent presentation, and all our participants are greatly benefited by your experience in handling the 5G security issues. And I'm sure that we also would be modeling our security assessment and other related activities on the lines of what Korea has done. But we, instead of following the common criteria, we have decided to go ahead with our own standards, making use of the international standards from 3GPP, ITUT, and other international standardizing bodies. So we thank Professor and Sungchi Park for sparing their valuable time and making it for sharing their experiences with us. We once again, on behalf of Department of Telecom India, thank both the speakers. Thank you, and a very loud applause from all the participants.
So I'd like to invite our next speaker of the session. He's right here in the hall with us. We have Sri Shankar Srinivasan, who leads the IoT and Enterprise 5G solutions for the APJ region. He actively works with service providers and large enterprises to understand the needs of private cellular networks. Architects help achieve measurable results for their customers. He has donned several roles in the 24 years of his telecom career, including sales, product management, system engineering, incubation lead, and solutions architect across Cisco, Ribbon Communications, and Nortel. May I invite Ms. S. Shrija Mani, RA NCCS, to please present a bouquet to sir. Also joining us on the WebEx platform, we have our next speaker, Sri Atul Deshpande, Senior Director and Product Engineering Leader at Cisco, with over 25 years of experience in building public cloud SaaS and enterprise on-prem products. His primary domain expertise is in mobility, IoT, enterprise storage management, virtualization, and SAN. Presently, he is a member of Cisco India leadership team, representing the business unit and driving cross-functional initiatives, collaboration, innovation, and GTM activities across engineering, professional services, customer support, and IT. Welcoming Sri Atul Deshpande. It's going to be mutual. He's on WebEx with us.
So, Sri Shankar Srinivasan on challenges posted in adopting cloud technologies for telecom networks and mitigation approaches. Over to you, sir.
Thanks. Am I audible? All right. More than talking about security challenges, I've got a bigger challenge in front of me. The food was good, and we've had one session after the food. So I think all of us can imagine what's coming after that, right? So my challenge is to keep you all awake for the next few minutes, let's say about 30, 35 minutes, so that I can make sure you're all engaged for the subsequent conversations as well. All right, so I think if we've heard a few things from all the sessions so far, right? We've heard one API. We've heard this over and over again from all of my colleagues here. So I'm not going to be kind of like they say, beating the dead horse to death here, right? So we know all the threats. A lot of us are qualified enough to talk about 5G security now after the end of these 2 days. But what I'm going to be talking about are, the couple of things that we've heard. Over and over again, we've heard APIs, the need to secure APIs, and how do we do this? The second one we've heard about is the fact that security is a constant evaluation, constant course correction. We heard from my colleague from the academia who said there's no great solution. So you could buy a motherboard and it could pass your security criteria, but 2 days later you could face a security problem. You could deploy the greatest of firewalls and then you could face a problem like what we faced in our own country at Ames or with the nuclear reactor in Iran. So there's no one solution that will keep you secure for the entirety of the network, right? So let's just be very clear about it. It's a constant evaluation. So we're going to be talking about those things mainly, assuming the slide marker works. It should work, right? I presume. You got to turn it on for it to work, yeah. So, all right, cool. So, we're just going to be quickly talking about some of the guiding principles. I'm not going to be talking about the NIST rules or any such thing. Just a very simple way to approach security. The threat landscape, a lot of my colleagues have covered threat landscapes in the past, but I'm going to look at a slightly different way to slice it and dice it, right? I don't have to say Cisco is synonymous to security. I'm not here to sell the company's products. I'm here to talk about 5G security. Along the way, if there are particular products that are helpful for our customers and how have they benefited from it, that's what we're going to be talking about. Okay. All right, so 5 dimensions, right? One of the most common things, sorry, I have a habit of walking, so I hope it's okay. So one of the most important things that you've heard from all of the speakers is, oh, we didn't see the threat, that's why we couldn't protect it. Had we seen what came to us in Ames, had we seen what came to us or what came to the Iranian nuclear reactor, the oil plants and the gas plants that get ransomware attacks every other day, had we seen those as in, had we anticipated those or seen those in some mechanism, potentially we could have prevented it. So seeing is believing, seeing is fixing when it comes to security. Okay. Anticipate what's next. I don't know, DDoS attacks have been around for ever since I did telecom, about 20 years back. Why have we still talking about DDoS attacks? The gentleman from Korea just mentioned on the BGP they had a DDoS attack. It's been around for longest time, right? This is not the first time DDoS has come up in any of our conversations. 20 years now, why have we not been able to attack? Why have we not been able to counter it? Purely because we need to fix and have proactive measures for the future. Okay, so fixing a band-aid is not going to help any of our security measures. Take right action, contextual analysis, right? If a particular transaction between a 5G core network function and let's say AMF, SMF, UPF, one of the core network functions is faulty, take corrective action only there. So you got to segment your network and only take you can't do a knee-jerk reaction and say, let's shut down the network, let's figure out where the problem is. That's never going to happen. And so on and so forth, right? I'm not going to walk through each one. When it comes to guiding principles, I think all of us have said the same thing, but I'm just going to quickly summarize in probably about 30 seconds what I'm trying to say.
network elements come first. If I've got 100 things to protect, and service providers have 1,000,000 things to protect, if I've got 1,000,000 things to protect, you have to have a solution that is scalable and that can look at each of these 1,000,000 things. Remember, we talked about ears and eyes into the network. If you've got 1,000,000 devices to protect, learn from those devices. What can I learn? Can I get the net flow from those devices? Can I get some kind of telemetry data? Can I learn something from the network so I can be smarter and protect the network? Network design. I think one of my earlier colleagues here said, or I think it was mentioned yesterday, network design with security is not an afterthought. There are conversations we have with our customers who say, "Bhai, network laga lo, security baad mein dekha jayega. We'll buy the security layer later on because we have a capex constraint or we have an opex constraint." Sadly, that doesn't work that way. Modernize your network in clusters. That's perfectly fine. We're all under capex opex constraints. There's no industry that's resistant to this at this point. But modernize in smaller clusters, but then make sure you have security even in those small clusters. So you know that A, B, and C are safe. D, E, and F, I'm going to do it next year. That's fine. That's still fine. And look at the entire life cycle. I think one of my colleagues was talking about CI/CD. CI/CD is a common mantra every day, right? Everybody who makes software, whether it's us or Microsoft or Oracle or anybody who delivers software today has a CI/CD mechanism. I'm not here to talk to you about what is CI/CD. The moment you say CI/CD, you've got various touch points. I've got 20 different network elements to upgrade, downgrade, constantly do revision changes, and so on. How am I going to do that in the most secure way? So don't look at the network that I've protected the users, I've taken into account that I've got a safe network. What happens in your life cycle management of an upgrade, of a patch update, and so on and so forth, right? So that's pretty much the slide ends there. The reason I put this, despite knowing, all of us know 2G, 3G, 4G very well, I deliberately put this here for a reason. There are some things that we've never done in the past. 5G is the first time we're doing those things. And the bars are obvious here, right? We've never done things like service-based architecture. Just look at the 2G, 3G, 4G bars here, the green bars here. We've never done anything. Look at all these bars that are falling short of 100%. We've never looked at these interfaces. We've never bothered about the security of these interfaces, right? And now, all of a sudden, we are expected to look at the interaction of how many times in 4G, I think a lot of you here come from Jio, Airtel, and so on and so forth, or even enterprises, large enterprises. How many times have you worried about the interaction between MME and SAE gateway? I don't think any of us worried. We've never thought of, it's the same physical cable. What can go wrong? It's from one city to another. I'm carrying the same transport. It's the same Airtel transport. Why should I be worried about it? What we call safe network or assumed trust, right? No longer, right? The moment you go, we were talking about segmented network or far edge data centers and so on. Nothing can be taken for granted. Threat landscape presented in a slightly different way. This is what a service provider, I think you can appreciate better, Sanjeev sir, on this. You can appreciate better that if you're running a cellular network, this is what you're up against. The customer calls you and says, "Boss, mera data nahi chal raha hai, something is not working." It could be a security attack, it could be a radio down, it could be transport down, anything. How are you going to address each of these pillars here, right? So security is a holistic language that we've got to speak. There was a very interesting survey done, and I was equally surprised about the results. It said there are a large service provider across the world uses about 70 different patch solutions for security. We spoke about DDoS. In all the previous sessions we spoke about DDoS, we spoke about how to secure interfaces or like Kubernetes, we spoke about how firewalls can be put in place, we spoke about CUDU, all the open vRAN interfaces and so on. Don't you have to look at it holistically? Can you put a band-aid here and say, "Acha, this is done, now I'm safe"? No, of course not. You see the threat landscape here, right? So what we're going to do in the next 10 minutes perhaps is just going to take one topic from each of these buckets and we're going to talk about how we try to solve it. Quite obviously, it's a session just to have a kind of a interactive arrangement on what we are trying to do, and we're just going to let's look at the access first, right? The poster boy for all problems. We think all our attacks come from access. Somebody removed the SIM, he did a SIM cloning, put it on his device or her device, started doing a DDoS attack, and now you're under attack, right? One of the simplest things to solve is the access layer. Lots of solutions out there. I'm not talking Cisco solutions and non-Cisco and so on, but remember, an access fix does also have to have some kind of a knowledge from where you've learned. Okay, so lots of products out there which have cloud intelligence. So I characterize the flow of traffic. I figure out that this is a threat. A SIM generating 10 Mbps or 10 MB download as against a 1 MB plan is also an attack to me. Okay, now let's flag it. Maybe it's not an attack, but proactively you flagged it, and that's when you will be able to secure your network. Okay, so endpoint analysis, lots of tools out there that can do it. The crux of the matter is that endpoint analysis is not a one-time fix. Make sure you've got some kind of a cloud visibility to a repository of knowledge. Yesterday, an iPhone 14 had an attack. How many iPhone 14s do I have in my network? Are they potential threats? This has to come through some kind of an AI/ML or a cloud-based service that will tell you that, Mr. Customer, yesterday we noticed in Deutsche Telekom or in SK Telecom, there was an iPhone 14 attack. By the way, you've got 7,000 devices or 700 or 7 million, doesn't matter. Why didn't you just take a look at it? He's not saying they are vulnerable, he's not saying you need to do something about it, but just a flag, right? Let's move quickly into transport, right? We spoke about all of this. I'm not here to talk about the CU/DU split and so on and so forth. Enough has been spoken about that. But what I'm here to tell you is essentially the interfaces today, a lot of these interfaces are protected by IPsec, right? I think we've all heard that. Earlier in a lot of the cellular networks, the X2 interface in 4G was not protected. Now we started realizing the need for it, and XN interfaces going forward and 5G are becoming protected interfaces and so on. That's just on the access layer. On the access transport layer, transport corresponds to all transport hops, including your microwaves, including your interfaces, or even your SMF to UPF, essentially the N4 or even the N6 interface going out to the GI, right? So all these interfaces correspond to transport, and you've got to have some kind of a mechanism to look at the threat attacks and learn from it. The vantage point we are in, and just a Cisco disclaimer alert here, the vantage point we are in is that millions of routers run across the service providers and enterprise networks run on Cisco. Only if I could have my eyes and ears on those, on every packet that traverses, I am now knowledgeable to make certain decisions, right? So that's in a nutshell what we are trying to do, right? Lots of solutions, but we're not going to be talking about those particular products. In the interest of time, I'm going to skip this. Enough has been talked about how VNFs, though the topic is on, there's a lot of discussion on, securing interfaces between the 5G network functions and so on. Remember, service providers are offloading certain network functions to the cloud. I think my colleagues from Microsoft were here earlier saying service providers are trying to offload, let's say, an AMF, or let's say a PCF, right, a policy function and so on. The moment you offload one particular function of a 5G network onto the cloud and having the remaining ones on-prem, you need to worry about this, right? You need to worry about this. The cloud provider is going to give you security. You need to have some kind of a ubiquitous security that sees both, right? Now, the PCF deployed in the AWS, GCP, whichever cloud, Azure, is going to have other kind of threat attacks. You need to be aware of those. You need to have visibility to those. So you're going to be talking about those things. You're going to take into account those things when you design the network. So, the slide is not very legible. What I'm trying to say here is the first thing is visibility to the packet core instances, what are the potential throughputs that you're seeing between these. If the signaling link is supposed to be 10 Mbps and it's showing 100 Mbps, you don't need an API gateway to do that. You don't need API gateway to tell you there's a large signaling volume between the two nodes. A very simple payload assessment will tell you how to do this. Okay. So a lot has been said about slicing. One thing I didn't see in any of my colleagues' slides was how do I look at every interface of slicing? I'm giving you 3 simple examples here. We're talking about V2X, we're talking about, let's say, a streaming data, and we're talking about, let's say, another MEC application. Remember, a lot of these slices have third-party applications sitting in the cloud. Let's give a simple example. Spotify. A service provider comes up with a new plan that says, I'm going to give you Spotify account. I've created a slice which gives you amazing music streaming service. It's a slice, right? We all know it's a slice. So I've created a slice. How are you going to check if, what are the touch points of Spotify? I'm just giving you Spotify as an example. What are the touch points of the web application firewall? Spotify may have a CDN network sitting outside your premises, sitting in a public cloud in Singapore or some other part of the world. Who's going to check the web application firewall? Who's going to check the APIs going out and so on? So remember, slice management is great. Radio can reserve resources. Packet core can reserve resources. Please make sure every interface, every application is also looked into, or you have a visibility to this. That's exactly what I've called out here. Visibility first, action next. All right, so some examples of visibility. It may not be very legible given the resolution of the screen and so on. So this is something you'll notice here that, various forms of visibility are available where you can look at application-based visibility, you can look at throughput-based, you can look at the number of sessions, suddenly something increased, right? So visibility is this chart here, quite obviously not very legible, but then the idea is to see the threat analysis that you're going to see, you're going to encounter and get more detail on this. All right, the most favorite topic, and we were also asked to kind of spend a couple of minutes on this in specific. A lot has been spoken about APIs and SOAP and REST and so on, and I think I was talking to some of my colleagues here before as well, that let's be honest, right, APIs is not something new. We've looked at this for 15 years now. Every 15 years back, if you want to do a transaction from one server to another, you'd send an API. They were flat files, and then there would be REST or SOAP APIs. So what's so great about it now? Why are we thinking it's a big elephant and we need to tame the elephant? The reason is that every transaction now is going through an API. The reason is that we've got a plethora. I think there was an example one of the gentlemen just said. He said they're deploying 17 different vendors of 5G SA. I think that was an example given by one of my friends here. 17 different elements talking to each other in different languages. Of course, they're going to be done through API. So how are you going to figure out whether it's the policy fellow that was the culprit, the billing guy, the VAS guy, who is the culprit here? We've got a very simple way to do this. The API Insights tool essentially ranks the APIs and gives you a weightage. Okay? So it first validates. There's something called shadow API. There's something called zombie API. A shadow API is something that has been deprecated. I used to talk to a person in this language. I no longer talk to him in that language. But remember, the API still exists. Once in 4 years, just like we spoke earlier, once in 4 years, I'm going to send that API call, and that API call is going to be detrimental to you. How are you going to find out? So that's a shadow API. A zombie API is where the API is dead, but neither party knows about it. So you're now masking an API and riding on top of the API and sending and receiving information. It's a simple get post message, but it can bring down your network literally. So API Insights, very simple tool that looks at all the 20 different interfaces, looks at the hundreds of API transactions and rates them and quantifies them, whether it's CI/CD or whatever, right? Whatever application you're using the API for. The moment there is a change in that API structure. So what does that mean? The authentication message to the UDR, UDM, you had 5,000 5G subscribers and you'd send an authentication message. now you had, at the rate of 2 messages per session, you had 10,000 messages going to the authentication system, AUSF. Now you've got 25,000 messages. The API gateway is going to come back and say, well, it could be perfectly fine, but the last 3 months or last 2 months or whatever, it's only been 5,000 messages or 10,000 messages. Now that's a flag to you. You can choose to do something about it. Maybe it's normal. Maybe you've come up with a new rate plan and hence you've got more subscribers and hence more API traffic. Okay. The second one is is API clarity. API clarity is specifically related to Kubernetes. All of the functions going forward in 5G, if not already, they're all CNFs. All of us in this room know this, but how are you going to protect CNFs from one another, specific to CNFs? Helm charts. A lot of those of us who worked on Kubernetes, we understand this is based on Helm charts, a common repository. If I'm supposed to go to a particular repository, pick up what is meant for me. Now I just go there, I start waddling around, I start figuring out what other source code is there, what other information is there, somebody else's YAML file. Can I look at it? I'm just curious to know. No, that has to be segmented. That has to be protected. Right? So that's what API lifecycle management lets you do. All right, real quick, just a quick time check. I've got about 10 minutes, or is that too much? Do I have about 10 minutes? 10 minutes is good? Okay. The first person who said yes, I'll go with him now. Okay. All right. So real quick, like I said, visibility is the key. Look at the number of policy violations. Look at the way the policy violations are created. You can see very simple call flow violation. What is a call flow violation? I just gave you an example of a call flow violation. DNS traffic violation. Just do a Google on the most number of issues when it comes to 5G, say security. Park 5G for a second. It's the first DNS request that goes out to a malicious site, and whatever you get back, you've clicked it, you've not clicked it, doesn't matter. You've already asked you made the request to get malware essentially. So the request has gone out. So what if we block the request itself, right? So right at the DNS layer, when the DNS request goes out, you can block it. Per IP, per slice, we talked about slice as well. If the IP belongs to multiple slices, what is the flow of traffic on each of those slices? So you can get to very, very detailed, granular measurement of traffic and actionable insights as well, essentially. This is my last slide. I was told 5 minutes, so I'm just in time to finish my slides. The way to read this chart, and like I said, not too many Cisco products on this slide, but the way to read this slide is look at the blue bar right here, right? The first bar right here. That's the end-to-end visibility, end-to-end monitoring of the network. Whether a particular device is getting a DDoS attack or whether it's doing a SIM MAC cloning, whatever is the issue, you'll be able to figure that out. And Cisco has a bunch of products, but you're going to see specific names. But the idea is to kind of take away the requirement of security and not as much the product itself. DNS and IP URL, we spoke about this. More and more 5G applications get created. A lot of these applications are going to reside outside the service provider domain, right? I just gave you Spotify as an example. Let's take connected car as an example. If Tesla is going to deploy a connected car tomorrow in India, Tesla's cloud doesn't sit in the service provider domain, but elsewhere. Could be inside the country, outside the country. How are you going to monitor the IP URL filtering for a particular stream of traffic? And that has to come from the beginning, remember, right? Because that's a SIM connected to a Tesla car, not a POS machine or whatever, right? So, and then the intermediate hops as well. We spoke about the need to kind of secure the transport, the need to do segmentation of traffic and so on. So, in a nutshell, right, there are plenty of solutions that will let a user configure, monitor, and take action, right? The idea is that you've got to have a great visibility to what is happening in your network end to end, what we call hop by hop visibility. If I give you a packet that exits the mobile or the SIM today, you should be able to find out, if you're a network admin, you should be able to find out till the GI and beyond the GI actually, on the BGP as well. We heard the BGP attack as well a few minutes back. Beyond the GI, post the BGP, where is that packet and is that packet being delivered safe and what am I getting back in return, right? And products, yes, we can discuss plenty on the product front and how that can help you configure microsegment and so on and so forth. So that's my slide. Thank you.
Do we have one or two quick questions for our speaker? We'll send you a mic. Yeah, so you can take the mic from there.
Hi sir, Shankar sir, this is Ravi Kumar. I know you long time back, you were in Nortel, I'm from BSNL and we take care of enterprise business. And I heard a lot of good things from you, basically that cyber security, anti-DDoS, maybe security is more predominant on the edge side. We do take care at core side, basically we have IZWs, we have probes or taps, whatever you call. The volume of traffic that is going to increase with 5G or maybe in 6G, I doubt how that maybe security angle is going to take place. Can you elaborate something?
Yeah, no, great question, and thanks. I should have actually started off with saying a lot of familiar faces here. I worked with BSNL in the past, back from your phase 4 of Motorola to Nortel deployments and so on. So a lot of good friends here in the room, and I happen to be the alumni of this college. So about 27 years back, I graduated from this college. So I don't know if I don't see any of my teachers here, but regardless, I thank them for keeping the spark of learning alive in me. So that's what gets us forward. Back to your question. Yeah, so absolutely true. I think even before we go to 6G, right? I like to keep things fairly honest and simple. 6G is a little far away for us. 5G has hit us already. It's not hit us from a data volume perspective still. We still don't see such large volumes of data, and I'm sure my friends from Jio and Airtel can kind of vouch for that. But we'll have to conquer this in phases, right? The first is the ingress egress. That's the first way to, so if my door is safe and if I can just open a peephole and let in people only I know. I'm just giving a kind of a parallel example. But in a nutshell, the volume of traffic, lots of solution providers, whether it's Cisco or any of my friends in the industry, we've got solutions that can scale from 5 gig to 500 gig. So scalability of the number of flows that you're monitoring, because everything is a flow, right? My IP can generate 4 flows, and each flow has to be monitored. So that does exist. The industry is going to come up with a product for it. What is more challenging is you as a network administrator keeping a tab on that. And that's where automation helps. You're not waiting for Juniper or Cisco or FI or whoever to come back and say, oh, you've got a threat attack. That's not going to work. What's going to work is you have enough automation in place so that you see a large spike in traffic. Large spike in traffic is fine, but is it healthy traffic? Qualification of healthy versus unhealthy. That's where you'll need to work with the right vendors and give you that insights.
I am Venkat Ramaraju Chelle, Director Quantum Technology, TEC. The SK Telecom, one of the attacks has mentioned IPS attack, where today the AI system predominantly spreading across the sectors and systems. What is the Cisco is doing and using AI, how the IPS tables are improving from these attacks? Can you clarify it?
Great question. So within the realm of whatever I can share, a lot of the times it's a little silly if you think about source IP, destination IP tuplet and decide that this is a safe one or this is unsafe one. Do you agree with me? If I decide that source IP and destination IP combination, this combination is unsafe, is that the only qualification? That's a very silly qualification, right? That changes like this, especially if you're doing large scale NATing or, if multiple ways to hide the IP and so on. We all know all those things. So the qualification of how you interpret a threat has to change. So what does that mean? a SIP call, let me give you a very simple example. A SIP call, does it generate any 1 MB data at any point? No. 200 OK or 100 a SIP initiation message and a SIP 200 OK message, all put together, SIP signaling takes probably, I don't know, less than a few KB of data. If I can characterize this and say, this is a SIP call, and usually it's taking, let's say, I don't know, 200 kbps, okay? Just hypothetically speaking. Today, I see that there are 25 SIP calls, each taking 1 MB. I don't care about source IP, destination IP, somebody swapped the IP, I don't care about that. So if you can characterize the data in a smarter way, add application awareness to it, add the knowledge that previously there are 25 SIP calls from this originator. Today there are 250 SIP calls. All these are indicators. So AIML comes into play exactly there, where we train our algorithms to not just look at tuplets of IP or tuplets of source port, destination port, and so on. That's fairly archaic. That's age-old systems. So multiple ways we can add and if-then conditions to make it smarter.
Thank you so much, sir, for that wonderful session. Can I request for the memento, please? May I request our moderator to please hand it over to our speaker, Sri Shankar Srinivasan. Thank you so much, sir. We'd also like to thank our speakers who joined us online for that wonderful presentation. Thank you so much. Thank you, moderator, sir. So we'll have a quick chai break. Please refresh yourselves and we'll see you back in 10 minutes. Thank you. And if you haven't visited the exhibition area, I think you must take this time to also, see them because they have some really nice stuff for you there. Exhibition area, please. Thank you. He's Deputy Director General in NCCS Bangalore. He's responsible for Telecom Security Testing Labs designation. May I request Shri Ashish to please present a bouquet? So please accept some flowers. We welcome you today. Thank you for joining us. And time to introduce to you our speakers. We have Shri Jagdeep Walia, General Manager and Security Consulting Lead at Ericsson, a world leader in providing information and communication technology to telecom service providers. He currently oversees network security engagements in the market area, Southeast Asia. He is an experienced telecom professional, joined Ericsson in 2003, member of TSDSI, Telecommunication Standards Development Society India, a standards development organization, and also GSMA T-ISAC group actively contributing on topics around network security. Welcome, Shri Jagdeep Walia. Can we have a bouquet for him, please? So please accept this. We welcome you. And our next speaker is Shri Nirant Amog, the head for 6G ecosystem and standardization architects, Nokia India. He is responsible for 5G, 6G services and architecture research and standards in global standardization bodies. He comes with 20 years of experience working with different global standards bodies, forums like 3GPP, GSMA, IEEE, ITU, and in India with TSDSI, TEC, COAI, MNOs, academia, and government organizations. He has held several leadership positions. His key focus areas include service API exposure research and standards for 5G advanced and 6G vertical industry applications, platforms for mission critical communications, edge computing, API service enabler frameworks, application enablement for V2X, UAV, smart factory, M2M IoT, and in NGSON. Welcome, sir. Thank you for joining us. With this, over to our moderator, sir.
Very good evening to everybody. So, in this last session, we have with us our member services, sir, also respected Sri A.K. Sahu. Sir, we once again welcome to for this valedictory session, sir. So, last 2 days, we had a very lengthy sessions, technical jargons and security stuff. So when we get into security, really we become a bit serious, I feel, right? Because it's a kind of a serious business. So last 2 days, we had a lot of serious debates and discussions. So with your permission of all of you, I would like to make this session a bit lighter so that we end up with a good. Of course, we have learned many good things, many aspects about 5G security, various dimensions, various issues, various strategies, how to mitigate it and all. And then it appears that industry is really gearing up for the challenges which 5G security is posing. So I hope everybody is ready to go with me in the lighter mode. Yes or no? Yes. Thank you. So let me tell me a small story about myself. My boss told me you have to moderate this session. I have not really, to be frank, I have not ever moderated any session. So when you do something first time, you get some self-doubt. Yeah, whether I will be able to do, I will not be able to do, what to do. So there is a story behind it. Before I go into that story, I would like to do some 2 controversial surveys. So, are you ready for those surveys? Yes, thoda आवाज जोर से, unless you participate, I can't make it live. Okay. So first controversial survey is, how many of you are married? Please raise your hand. So Usha says they are all lucky people because they are all looks to be smiling. So now next controversial question is, how many of you prefer to go to your spouse and ask, clarification, we are in a doubtful mode. Now you raise your hand again. One. Take one hand. Two hands. 3, 4. So there are 4 hands. It means the very less number of married people, they go to their spouse and they dare to ask a clarification when person is in the doubtful mode. They are all the risk-taking fellows. They are all risk-taking fellows. So we have 4 gentlemen here, and including myself is the 5th. So I went to my wife. My boss has given me assignment. So much work was going on, 1.5 months. And he said, you have to do this job also. I said, yeah, whether I should say yes or no, I'm not clear. So tell us, what should I do? Then वो उसका blank face, मेरे को समझ में आ गया, she is also in self-doubt mode. ठीक है. Then after some time, with a pause, she replied, see, you are not able to moderate mess at home. Many a times you create mess at an office and come with the grumbling face and complain about boss and all these things. I really doubt you will be able to do, but still I feel that most of the time you are happy, you are able to survive. So with this disclaimer, I feel you can do it. I said, okay, take a risk. So I am here in front of you with that risk. So let me allow to go ahead with the assignment given to me. So in this session, we have scheduled 2 topics. One is security issues in the RAN and possible solutions by Mr. Jagdeep Walia, direction. Second topic is service exposure challenges in APIs by Mr. Amog from Nokia. So as we all know that the RAN system have evolved from traditional RANs to distributed RAN, then it is moved to the virtual RAN, then it moved to the CRAN, etc. We have been evolving in this RAN technology over a period of time. And this evolution has helped to optimize the CapEx components as well as the flexibility in terms of deployment of the RAN solutions. At the same time, it has incorporated a lot of good amount of risk also. Security risk have been increased into the system. And that is how we are here to deliberate those issues. So today we have with us Mr. Jagdeep Walia, General Manager from Ericsson, who is having industry experience of more than 20 years. He will be taking us through this subject on security issues in RAN and possible solutions. So over to Mr. Jagdeep Walia. Thank you.
Could you start? Just tell me the... This is which time? Yes, sir. Are you sure? No, this is... This is on? Is on. Okay. You want to... No, I think I'll just use that. Am I audible? Yeah, I think so. So I just wanted to start by saying that, you don't have to be in doubt, I think we all are partners here. So I guess there's no fear, I would say, or doubt. So good evening, everyone. At the outset, I would like to thank DOT and CS to organizing such a important, relevant conference and bringing all the stakeholders on the common platform. And it's a pleasure from representing Ericsson and being part of this conference, I would say. A lot has been said and presented over the last 2 days and around the subject of security and on varied topics from let's say, telecom networks overall and then some other topics. From my perspective, I would be presenting insights on the security challenges on RAN and then how can we mitigate those challenges. So to start with, let me highlight the fact that security, I mean, that's one of the reasons why we're having this seminar, is that security has become a very important topic for operators and regulators worldwide, I would say, as we see networks transitioning from 4G to 5G. There have been a lot of insight that already been shared by speakers before me on this topic, and I think member services and member finance had already alluded to the fact for the reason, first starting with the point that today if we look at 5G, it's a game changer in the industry. It is not only for operators, but also from the perspective that it is enabling new use cases for verticals which were not possible before. This, at the same time, introduces new threat opportunities which need to be addressed. And from a 5G perspective, we need additional security and privacy measures to kind of mitigate these new threats that would come in from these new use cases and new use case deployments, for example, edge computing that we've been talking about, which was not possible before in the telco network. Then from a end user perspective, 5G would not only serve the end user, but also it would form a connectivity for a lot of millions of IoT devices, which could also be, could have a very weak security posture, because the form factor or for the reason that maybe security by design principles not being followed by the IoT devices. So that itself proves to be attack points into the network, and it increases the threat landscape. Thirdly, from a technology perspective, we talked about virtualization being used when it comes to 5G, though it brings in its own advantages of flexibility and scalability, but at the same time, it also introduces its own vulnerabilities, which then also needs to be addressed. And lastly, from a regulatory perspective, I mean, telecom infrastructure now being classified as a critical infrastructure, the security becomes paramount, and we need to ensure that the telecom infrastructure is secured and is able to provide services towards the end user at all given point of times. So we see that the security challenges and also the threat landscape has increased as 5G is getting rolled out across I would say across the world. That's because the challenges more or less would remain the same, which needs to be addressed. Now, here are some of those attacks that we've seen over the last 2 years in some of the telecom networks that I've picked up. We had the CNT, which is a state-owned operator in Ecuador, which had a ransomware attack. We had T-Mobile, which had, again, a data breach wherein there was loss of personal details of more than 50 million users. We had then Roshan, which is an operator in Afghanistan, basically, wherein state-sponsored threat actors had been exfiltrating gigabit of data, which over, more than a year, and they realized and they found it after a year. And then we had Vodafone Portugal, where again, they were target of a cyber attack, where there was a widespread network disruption, and the services were unavailable for 4 to 5 days. And then we had this year we had Optus, and then lately we had also T-Mobile. So what I'm trying to say is that we see that the attacks on the telecom networks are increasing, and they're going to get more sophisticated only and an increase, and they're not going to go away. So that, again, is why we see so much of importance being attached to the security of 5G networks. So, 4G or 5G, but then in general, moving on with 5G, it becomes even more important. And then here are some of the examples of air interface attack in mobile networks that have been seen of late. I mean, these have been happening, but these are the ones that have been in the public domain. There are a couple of more, but then I just picked up just to say that there are air interface attacks that are happening, and these are being carried out by state actors and the malicious actors both. And here, this is one of the examples where we have what we call as false base station attack, which is also called as Stingray IMSI attack, where a false base station emulate as a genuine base station and tricks the user to connect to itself. So these are some of those attacks that we have seen recently on the from an air interface perspective. And then I think it would not be wrong to say that the access networks are more at a risk compared to the other part of the network. And that is for the reason that for example, our radio sites, they may be located in a remote or location which are more physically accessible. You see when you talk about core, they are more in data centers which are more centralized and they are more secured. The other fact is also that we would have thousands of radio sites, which makes the attack surface also much larger in comparison to the core network. So that really then puts a lot of importance that we need to ensure that the access part of the network is secured from the attacks. And then here are some of the attacks. When we talk about RAN, then we're talking about air interface and the connectivity between RAN and the core, the transport. And here if we see if the network is not protected or they're not right level of controls that have been implemented, then it would let the malicious actors to actually exploit those and launch an attacks. And these attacks, what we're talking about, a man-in-the-middle attack, denial of service attack, eavesdropping, software image poisoning, could be physical and could be insider attacks. I'll go into a bit more details when we talk about certain specific attacks from or certain gaps from a security perspective and relating to these particular attacks. The other important aspect I wanted to talk about was that the concept of the impact and the access. So if we see in this picture below, I mean, if we see it's on the, if we go from the left, I mean from the core towards the radio network side, we see the ease of access increases. So that means the risk of exposure is more when we move away from the core. But when we look from an impact perspective, it is the opposite. That as we move towards the core, the impact is much more. Because, I mean, a radio site could serve a couple of thousands of users, whereas a core site would be actually catering to about thousands or let's say 1 million of users. So if a core site gets compromised, so that is an important aspect that we need to factor in when we're trying to see what type of controls do we deploy on the core or on the RAN side. So then how do we then protect ourselves? And this is more of a generic approach that I am kind of laying out over here, because I feel this can apply to RAN or this can apply to core, but then this is quite useful, I mean, in a way, to say that, there are 4 levels, that's how I see it. So you have to ensure, firstly, that you use secure protocol algorithm security capabilities that have been defined by these standards. Once that's been done, then you have the concept where we say that security by design needs to be followed by the vendors to ensure that the products are built with the security mindset and they have relevant security capabilities built from the start. And then these are managed throughout the product life cycle. Then when it comes to deployment, we need to ensure that we have secure deployments following security design principles to ensure security and privacy, which includes hardening, could include also defense in depth principles, so that, and also the configuration. And a lot of times we've seen the attacks are a result of misconfiguration in the network, which is then exploited. So it needs to be ensured that we have the right level of hardening, we have right level of configuration, and we follow the defense in depth principles to kind of protect the deployed network. And lastly, I mean, without secured operations, I wouldn't say it would be possible to then secure the networks, because with secured operation, what I mean is that there should be, you should get, as my friend from Cisco was saying, I think what's important is the visibility inside the network. So you need to have right level of monitoring, you need to have threat detection, you need to have, you need to identify and then recover from the threats that are ongoing in the network. So these are basically, let's say, the 4 pillars which would help you to ensure the overall security of the network. Then a few words, I mean, we have seen that it's not all gloom when it comes to security. Obviously, security has been evolving with every generation. I mean, if we start with looking at 2G, there we had the introduction of one-way authentication, and then we also had temporary identifiers that were being introduced, which was again from a perspective of protecting subscriber privacy. And then also we had the introduction of encryption, which is the 5x1, 5x2, the algorithm that we use today. That is obviously now those are pretty weak, but then those were introduced at that point of time in order to ensure to protect from eavesdropping, basically to ensure that nobody listens into a conversation. With 3G, then we had a concept of mutual authentication being, so until 2G, we had only the user getting authenticated by the network, and then in 3G, we also had the network authenticate the user, so that brought out more, a better level of trust between the user and the network. Then we had also stronger encryption for user plane being introduced, and also then we had the integrity protection of the control plane that was introduced as part of 3G. With 4G, we had then further advancement in the ciphering and integrity algorithms. We have now, earlier we had just one algorithm that was used. Now with 4G, we had 2+1. One was optional, but then it was basically 2 mandatory and 1 optional. And then we had elaborate key management support, and then NAS integrity protection was also introduced in 4G, which was not there with 3G. And then with 5G, we even have further enhancements in security to address the threat landscape that we saw that 5G get exposed to. And that's what I'm going to then discuss moving forward. So here I have listed some of the key, let's say, security challenges or gaps that we see in current 4G networks. We have the IMSI is basically sent unencrypted, and that leads to attacks like IMSI catchers. We have false or fake base stations, which can lead to tracking of users and also eavesdropping, depending upon if it's active or passive. Then we have also a user plane on the radio interface was not integrity protected. Again, that was leading to data injection and modification. Again, from a subscriber privacy perspective, this was an issue. And lastly, we had no protection of the secured exchange of UE capabilities, which led to the 2G, 3G downgrade attacks. So these are some of the key, I would say, gaps that from a RAN perspective, radio interface, and the RAN and transport that were existing in 4G. So then how do we address these when it comes to 5G then? So 5G, on a broader level, we have integrity protection of the user plane that's been introduced. We have enhanced subscriber privacy, and these are some of the capabilities, and we're going to discuss a bit later in detail. We had IPsec that was used for the protection of the traffic between RAN and the core, but now we have also additionally DTLS that has been defined, and I'll give you some background why DTLS has come in when IPsec was already existing. And then others, we have use of 256-bit algorithms, and then also security assurance specification for 5G nodes that has also been come in, which helps in terms of ensuring the security of 5G nodes. starting with the integrity protection of the user plane traffic. So basically, with 5G SA, we now have support for integrity protection of the user plane traffic. So there are three algorithms, which is the NIA1, NIA2, NIA3. NIA3 is basically optional. NIA0 is no integrity protection. But normally that is only used in case of emergency calls, but then not in generic. All the calls have to be integrity protected. The other point I would like to highlight is that this is mandatory for the vendor to support, but not for the operator to support. So operator could still choose. And there are scenarios where operator could choose not to use user plane integrity protection. For example, in case of ultra reliable low latency, where you have low latency use cases, wherein you would, if you introduce encryption of the data plane, that could introduce some latency which may not be applicable. So from that perspective, in certain use cases, this may not be recommended. But then it's up to the particular use case and the deployment scenario to see should this be enabled or not enabled. And the other question I get is, so which algorithm to use? Should we use NIA1, NIA2, NIA3? So basically, NIA1 is based on Snow 3G, NIA2 is AES, and NIA3 is the Chinese way, which is Zook. So I mean, all these algorithms are secured. But we recommend NIA2 because it's AES, it is more tested and validated. So that is what I recommend. But then point is that it is up to the operator. All algorithms are safe enough. It's just whatever you would like to implement. It's up to the operator to decide what they would like to use. Okay, then I'll 5 minutes. Okay, that's the uphill task. Okay. So when it comes to subscriber privacy, as I said, IMSI, which was sent unencrypted with 5G, now that is sent encrypted, and what we call as SUKI. And what it allows is that it makes the IMSI catcher or the Stingray attacks much more difficult to carry out. Further, we also have that SUPI-based paging is not used, or the permanent identifier-based paging is not used. We are basically using the temporary identifiers, which is the GUTI when it comes to paging. And this helps you to mitigate against the UE tracking attacks. Then this is another thing that was enhanced in 5G based on the limitations in 4G, wherein the UE capability message was exchanged before the start of the security mode command was completed. And with 5G, the UE capability inquiry is only sent after the AS security has been activated. So in this way, we are able to protect the bidding down or the from bidding down attacks or even the identification attacks that were possible with 4G. Then we have the false base station detection, which helps you to identify false base station attacks. And this is based on the device-assisted network-based approach, where the radio measurements are done by the device in the network, and then they are sent out towards the G node B, towards the network, and then the network would actually do the analysis of the measurements and also the configuration performance parameters that are available in the network, and would help you to identify if there is a false base station that is active in the network. And then the transportation protection, which was between the RAN and the core. Here we already know that we had IPsec before, but the challenge with IPsec was that you actually need an extra piece of equipment, which is a security gateway, to enable that. And that was kind of a bit of a challenge with certain operators, because that would increase the cost. And that is where 3GPP had come up with DTLS, which is an application layer wherein you don't need a security gateway. It makes the implementation of the securing the transport between RAN and the core much more easier. But then obviously it's a trade-off. Since it's on application layer, you will not be able to do the topology hiding, because your IP address on the G node B and the AMF would be transparent to each other. Then we have also the 256-bit encryption that has been mandated, or I would say that's been recommended in 5G. And this 256-bit encryption may be not needed currently, but may be needed when we talk about virtualized environments. And here I would say that 3GP has already asked HC Sage to basically analyze new 256 algorithm. And as of, I would say, 2 months back, HC Sage has chosen 3 algorithms, which is AES 256, Snow 5G, and Zook 256, which would then be introduced with this specification, and we see that not coming before R19. But then we see the current algorithms that are there existing, they are good enough from a security perspective to be used in the network. And then security assurance, I wouldn't like to have to say much about it. We all know that. I mean, so we have security assurance already introduced, and also we have the NCCS defining the ITSAR based on, with reference to the same, I would say, the specification. And then that provides an assurance that, yes, there are security capabilities which have been implemented in the right fashion in the nodes. So that, coming to my last slide, so just to summarize that, 3 points. I mean, first, we see an evolving threat landscape with 5G, and it's important that we have the right level of focus and controls in place to ensure the security of 5G networks. And here we need to depend on a 4-layered approach, wherein we need to ensure we have the right standards, we have the right implementation in the product from the start, we have secure deployment and secure operations. And then from a RAN perspective, I think we have 4 key improvements, which is the enhanced subscriber privacy, we have the protection of RAN and CN interfaces, we have integrity protection, and the security assurance. So with that, I would like to end. Thank you so much. Thanks for your time.
Thank you, Mr. Walia. So, Mr. Walia has explained about the various security threats emerging in the RAN part of the network, and also he has briefed about the telecom incidents, incident cases which have occurred in the network. And also he has suggested the 4-pillar based approach for handling the security risk involved in the RAN area. And then thereafter he took us through the various security challenges in the 5G network as a whole, and suggested for the various measures to be taken as a part of this. And it has been very insightful experience with your this one, sir. So we thank you for this information. And we would like to inform that NCCS also has come up with the 2 ITSARs on the RAN, and we are working on the other ITSARs also for the open RAN parts. So with that, I think we will be able to strengthen the network further. So moving to the next topic, we have with us Mr. Nirant Amog from Nokia. So he will be taking us through the topic of the service exposure challenges in the APIs. So as we know all that the API, which is essential part in system-to-system communication, which is gaining importance due to growing needs of the emerging technologies such as IoTs and M2M communication. There are variety of APIs like internal, external, public, third-party, composite APIs, beta APIs, and so forth. APIs have become attractive targets for the attackers due to their widespread use and possibility of access to the data. So today with us we have Mr. Nirant Amog from Nokia to give us light on the subject and enlighten all of us. Over to you, sir. Thank you.
Hi, good evening, everybody. This is tough. I was given a 45-minute slot, so I'll take those 45 minutes. Just joking. So I know all of you are tired since a long day's effort. So, but I still had slides for 45 minutes, and my target is to finish it in 20 minutes. So, so that itself is pretty tough. And sir, I just follow my boss, so I don't take any security risks. So what I'll be speaking about is, it is fantastic. First fantastic workshop. I'd like to compliment NCCS, DOT, and CDOT on organizing this, and also thanking everyone for inviting us. Thank you so much for inviting us on this topic. I was here yesterday, and also today I heard through many presentations, and then I was trying to figure out what else to speak, because when you're the last, let's say, technical presenter of the conference, then what is new that you're going to talk about? So everybody would be like, okay, वही बोलेगा जो सभी ने बोला है. So what I tried to do is I took liberty of changing some of my presentation. So even though I appreciate our organizers just to keep following me up on the presentation, so I took some liberty, and hopefully it strikes resonance with all of you, and maybe it might give something new. So in terms of so I'll take you through quickly on three aspects. So I hope none of them have touched here. So I'll, of course, on the context it is pretty clear. Then I'll talk about the API security top 10 aspects, especially from OWASP, which is also ITSR for NEF has been have discussed that. More from perspective from the northbound side. We have talked APIs, everything is about APIs there within the network, but I'm going to focus more on the northbound side. Exposure towards the external applications, like Srini also talked about how Spotify and plethora of apps that are going to use the 5G services. And also I'm going to talk about what is standardization doing in this particular space. So there is, I'm not very sure whether many of you might be aware, but just to re-emphasize, there is an API exposure framework standard, and I'll introduce you to what that standard means towards the end of this presentation. So usually I start with this, we need to always understand what is the demand supply part, and especially why we need to do all these things, right? So some studies that have occurred, especially in terms of how 5G has to be monetized. So CSPs, which are basically the mobile network operators like Airtel, Jio, BSNL, Vodafone, they have been, in India and worldwide, they're all continuously investing and building on networks, right? 4G networks and 5G networks. And this spending will continue further. So the whole point is, itna paisa dal rahe hain, what are the avenues to get some money back? Right? So kaise karenge? So one of the top 5 priorities, there are several other priorities with which they would like to monetize, but 73% in a study it reveals that the vast majority of CSPs, 73% view network API exposure as a top 5 priority. And that is the reason why I am here to even talk about this particular topic. And then now when we're talking about exposure on the northbound side, we are talking about a whole new community of users, which are the developers, the app developers, right? So when we're talking about these app developers, they were pretty much non-existent in the earlier generations of networks, but now we will see more and more exposure from the mobile network operators and their involvement in how they would like to build applications, and how even there will be an interplay between the mobile network operators and the external apps, and how can the services be more simpler so that it can add value to what the applications want to provide, how to provide slices more effectively, how to provide low latency services in a more easier fashion, and things and so forth. And the other attribute of developers are, we all know developers in the community are all IT. Everybody are familiar with web, right? And web applications, web application development, and so on. So if we want to entice that community, so then we need to keep them simple, right? So they are not network specialists. So that is very important attribute. We need to keep them very simple. So very simplified APIs, software development kits, and code development support. And 60% of developers are interested, at least the survey says 60% of developers are interested in writing these type of software programs. And from the forecast perspective, we see that the northbound APIs part, there is potential to grow in terms of 34 billion market that we're seeing in 2026. So that gives a lot of motivations to work in this area, and security becomes utmost important because it's almost like the web. So you open up, you have a framework like HTTP, HTML, and the whole world came into it, and you started seeing we also went through the bubble, right? We started seeing so many apps being created. So we are going to enter that phase of what we saw in the internet with 5G and also the future networks coming in like 6G. So what is the strategy? So CSP strategy to monetize from 5G and beyond, at least the survey says, they're all going to look into network API abstraction. There are going to be very simplified interfaces. On the left-hand side, what you see is certain type of services, and NPaaS means network platform as a service. Mobility, voice, video, location, data messaging, they were traditional services that were being offered on the top. But now with 5G, we will see slice management, data monetization, edge platform, analytics, all those being also exposed. So 76% of software developers believe that these need to be very user-friendly. They all look complicated, but then they need to be delivered in a very user-friendly manner and secure. So secure is everywhere. So CSPs also need to complement in the other way, because now they are looking into the new customer base. So the strategy for network platform as a service will be to ensure faster time to market, integration ease. So everybody are looking into web APIs, web style APIs, so RESTful APIs, and security at every level, and also performance and scale should also be considered with deployments of cloud and edge. And in this particular perspective, if you see, there are global bodies involved, 3GPP is involved, which is also working on this strategy. Camera, which is an open source project initiated by GSMA or supported by GSMA, they are working on open source APIs. Then GSMA itself has been working on open platform gateways and APIs. Etsy mobile or multi-access edge computing is also working on APIs, and TM Forum, of course, it's working on the management side of APIs. So there is a lot of motivation to go in this direction. Now, coming quickly onto the perspective of challenges. So we have 3 levels of perspective. One is the level of exposure, right? So one is, of course, the most important thing everybody thinks of is sensitive information ko expose karne se kaise rukna. How do we really stop that? User data, we know that user data can be compromised. We saw a lot of cases that even Jagdeep presented, Srini presented, that so much of user data is being compromised. Then how to achieve the right level of abstraction. Developer wants something very simplified. You can't expose the entire 3GPP system or any 5G system and say that, yes, our API, and say you can use it. No, they want some level of abstraction to how to achieve that. Then these APIs will keep changing because the business dynamics will also drive the CSPs to keep changing these APIs. So how to manage them. Then especially coming from a security perspective, of course, these also have light of security from exposure level. Then threat protection and access control, I think everybody have spoken on it. So how to manage that. And also very clearly it is known that one size doesn't fit all. And from standardization perspective also, we see that security should be complemented well first in the design. So when you're designing a new system or a system, how is security requirements addressed in the architecture, and how are these APIs evolved from that perspective, right? So maybe the challenging perspective is there is lack of understanding of API standards, or even lack of awareness of API standards. So now going towards more details, but given the time that I have, maybe I'll pick some of them, okay? So I'll not go through because I just have like maybe 8 more minutes or 9 more minutes to do that. So maybe I think these are the top 10 security issues that one could see when they're looking at API security. And these are also part of ITSRs, which says that any element which is exposing APIs, they need to have strategy to address these latest risks or the API security risk that has been identified by OWASP. And the link is provided on how they derive it. I'll not go to the background. Some of the new things I can probably touch upon is, let's say I'll go with the one simple one, and then I'll keep pushing on the slides very quickly. Of course, the first one is the broken object level security. This is almost everybody understands this. So there are going to be, let's say, descriptions I'll let you read, but the use case is that people have, when the APIs are designed, they're designed with a set pattern where things are predictable and guessable. Let's say user information details. So an API uses a user 1 and fetches the details, and then the attacker can replace it with the user 2. and sometimes with different guesses they can get that details, but it is more aggravated if the user pattern is in such a way that the CSP is organized the user resource exposure in an enumerated way. Then they just have to increment the counter and get the data, right? So these are the issues, and then there are ways to prevent it, like implement authorization checks with user policies, make them non-guessable, and check authorization each time whether these particular application which is requesting for this data over the northbound side, whether it really needs access to this, or whether it's authorized to access these. So this is the type of descriptions that you will find in terms of the attack and the use cases and how to prevent it. So what I'll do is, maybe I'll just skip to the ones which are more important, which we see as emerging. Yeah, I think most of this is new. So in 2019 and year on year, you'll see revisions of this particular OWASP attacks. One of the things that is coming up is when we are trying to achieve simplicity, right? So we are, एक call करना है, सब कुछ हो जाना चाहिए, right? It is that the idea is that. And when we are trying to achieve that, there is a risk that there is an unrestricted access to sensitive business flows. They know how to now procure a SIM with all the details given at one shot, and it easily goes through. So now, if you are not restricting this access in a way that these end-to-end business flows, because they can guess once they run through your API and they understand the API and what it all does, so they know that there is a business flow here, and they try to exploit this particular business flow. So end-to-end business flows can be exposed without any adequate checkpoints, and also making excessive requests. So you wouldn't make like 10,000 SIM requests in 1 second, right? So you need to understand what is the usage pattern for your APIs, and accordingly imbibe them in your API exposure strategy. So here, identify from business side and from engineering side, as well as to how to limit the usage of your APIs, and also secure the limit of access to, especially to the machine side, which is going to extensively exploit these type of business flows. Other aspects that we are going to see is aspects where server-side request forgery. So now we are seeing that there are ways in which to manage from the application side. Application architecture is very diverse when we look into the over-the-top applications. They'd like to have their applications in a distributed manner where they run their control logic and they do their monitoring in the other service instances. So what they will do is they will kind of give some callback URLs, and they will ask some information to be sent to some other endpoint. There could be attackers who could kind of do this modification of callback URLs where they show success to the sender, but the receiver is not receiving the information, some attacker is receiving that information. And there are ways in which also where there are some APIs are being designed where the URLs are embedded. Now you see, right, when you, let's say you go to a registration web page and you want to attach a photo, so the registration web page says that, can you give me a photo, upload a photo, or give me a link from where I can pick the photo, right? They now take URL within the body of the parameters, and these particular parameters can then be exploited. Let's say the attacker just changes this parameter not to a cross-domain or some other recognized store, but to a local store, so they can start getting information from the local store displayed onto the user without even the API provider knowing about these. So these are server-side request forgeries which we need to take care of. So here, see that when you're doing your API design, only allowed list of URLs are being made, parse those URLs, verify, don't send any raw data in responses. So these are the strategies that needs to be put into place. So some of them are operational, some of them are API design needs to be considered. So right from your coding of your API to operation of your API, and also to retire your API, right? Everywhere you need to see that you are taking care of these kind of API risks. Then I'll go, I think this is all clear. I think this is, unsafe consumption of APIs. So one of the things that are coming up with 5G is a lot of APIs are coming in. So CSPs are also looking into onboard new innovations. So they will also onboard third-party APIs which can be combined in interesting forms. And then there could be cascaded API information in invocations or mashup of services. So this could also lead to infinite looping of APIs, and it could be like some attacks on denial of service and so on. So we need to see that this can all be prevented right from your API design, and also when you're using some runtime redirections, so you need to also limit your redirections in this particular case. So now when we see all these risks, so what did industry do? Typically what did industry do, at least coming from research and then getting into developing the system, which is coming directly from standards. So 5G system was designed. 3GPP, focusing on 3GPP, which provides the 5G system specifications and the architecture. They also thought about providing, mitigating these type of risks, and also finding some way of identifying contingency plans for operator who operate on northbound side. So they specified something called as the Common API Framework, or CAPF. And the specification is 23222. So this is a rough architecture of CAPF. What it does is, it gives you a controller function called as CAPF core function, and it isolates the exposing function so that there could be centrally control made. And then on top, you could see there are API invokers. These are all northbound API invokers who could be in other trust domain or even in the operator's trust domain. And then there are plethora of functionalities that are put into CAPF core function, which allows you to, of course, publish and discover APIs, authentication, authorization, access control, API routing, topology hiding. All of these have certain details, but due to lack of time, I'll not go into detail of them. Please refer to the specification. This is one step forward for 5G that 3GPP specified to help operators, to help the community of APIs to make more simplified APIs and be able to safely monetize from northbound exposures. And also now they're also working on, they also specified some support for third parties and also interoperator APIs. So as you can see, there could be data, there could be own APIs, there could be third party APIs, they can all be composed, and there could be multi-region operators also coming together to exchange APIs. And this whole CAPF architecture will evolve into providing some kind of a secure API driven ecosystem. So that's the direction that 3GPP is also going towards. And CAPF also now provides saying that there should be some API consistency guidelines. So each API that 3GPP develops will now have some kind of a fundamental, they have to undergo, satisfy this fundamental API guidelines as well as support this API design and architecture specified by CAPF. So which is a common set, I think everybody have discussed, I'll not go in detail. Of course, security becomes prime important here, and how to do stateless services, how to support CRUD operations. Now we will also go into towards developing what are the best practices and standards for intent-driven abstractions, how to provide intent-driven API designs. So that is the next phase of work that will begin in, let's say, going forward in the end of release 19, that is 5G Advanced, and also culminating into 6G. So in summary, so I'm very sorry I had to rush and it was quick, but I hope this is a little different than what you heard in the 2 days long presentations. So key message is APIs will play a very key role in monetization of 5G and beyond. It's not only 5G, it's also 6G, and for all the deployments of CSPs. And of course, API security is imperative and very center to it. And we will also see a standardized API exposure framework like CAPF, which enables the consistent definition of secure APIs. So this is the message that I wanted to give you as part of this, but of course the other speakers have done wonderful job of treating API as a topic. But from a northbound side of APIs, which we'll see that there will be a lot of monetization going forward, which we have seen with models of Amazon, Google, and others. So CSP will also, or the mobile network operators worldwide will also try to monetize their networks with more value-added services offered from themselves, where applications will enrich, they will benefit by low latency, they will benefit by slicing, and all the qualities of demands. So with that, I wish the fraternity and the organizers all the best in terms of the next wave of networks coming up. And as a community, we all work together in securing it. It's also the northbound side. Thank you.
So thanks, Mr. Amok, for giving a very good insight on various aspects associated with the vulnerabilities in the API and strategy of the CSPs, GSMA, and other forums. And also you have highlighted about the top 10 vulnerabilities highlighted by the OWASP. And lastly, you have given the strategy of the 3G forum also as a CAPF and all entire landscape about the API security. So if you take the overall spectrum of this APIs, the number of APIs they are really, the count is very, very high. And in fact, with the addition of the 5G technology in the network, in future, the APIs are expected to multiply very exponentially. If you take the figures of the Google Play app alone, there are 3 billion APIs, 3 billion APIs. And if you see the market of API security is around $750 million industry in terms of the API security, which is expected to grow to around 3,500 million of your dollars in the next 3 years, 3 to 4 years, around 33% of the growth is expected. So if some of the startups and some of the students, they are really, it's an area where a lot of growth is expected to happen. So thanks for your all this valuable inputs and sparing your times for our this event, and we look forward to have further interaction with you. In fact, NCCS is also analyzing the 3GPP framework which you have explained, and we also will be coming up with our own version of this standards for our usage in the country. So with this, this session comes to this one. I request you to take over.
Thank you, sir. We have time for 2 quick questions. Somebody wants to ask, please raise your hand, and we'll request you to please keep it very quick.
You have mentioned in your slides about 5G standalone deployment. However, as we know, most of the networks, commercial networks across the world are NSA deployments. So are we really secure because the protocol stack can be downloaded to 4G, 3G, 2G, and all the RAN attacks that you had mentioned can be used?
So I would say that obviously it's about what is the probability of it, because the attacks that I'm talking about are not very easy to perform.
No, I understand that, but,
attacks, I mean.
but if you look at like Iraqi General Soleimani was attacked, it's quite possible his location was determined through network resources itself.
So yes, I mean, point is that you can always have controls in place, but then there would be somebody who would come back with something which even is able to go around those particular controls. But I would say that yes, these are. I think there is a realization that there are these attacks happening and these are increasing, and that is where now we see with 5G that we have this ability to kind of address these attacks. So every previous generation had certain.
I completely understand your point, but what I am trying to say is as long as 2G exists, as long as operators support 2G, we are still vulnerable.
But then again, so we have, that's where I'm saying, when we come with 5G, we can actually, and then going forward, maybe even the standards may include for 4G also certain capabilities that have been included in 5G that you could actually protect against these beating down attacks.
That would be really great if something like that happens.
But then we have, at least with 5G, that capability, and we can see in future with 4G also.
Okay. Thanks.
Hello. Yeah, so my question is for Nirant. Yeah, you can see here. Okay. So you told in API, no need of we should not send raw data. Okay, mainly. And one more thing, yeah, you really did a very good session. In that, you told API securities and all. So now we are communicating with the northbound, we have some EMS, NMS, with other northbound we are communicating. So now how we can secure our API? Now usually we are using other REST APIs and all, but still we are not yet confirmed to how to secure. We are using API key and all, but still that is not more secured as we are communicating or with the northbound and all. So as it is in a different network, so if it is on the same network, yeah, we can agree. Only API key is fine, but we are communicating with the different network. So I had actually 2 questions. So first one is how, if we are not sending raw data, our body or response, so how we can send the data. Second one is how we can secure our API.
Yeah, thank you for your question. So one is when we're looking into API security, right? So one is there are best practices, security best practices at coding level, right? How do you design the logic of your API? So all the 10 risks that we have shown, right? So those 10 risks have some best practices at engineering level, and there are some best practices at runtime level. So best practices at engineering level, when we say raw data, right? So it's basically you have some tables in your database, and you don't create a proxy for the table via an API and just package them in a format which can be delivered to the application. So there are ways in which they can attackers can guess the table names, they can guess other table names, so they could just exploit that. So formalize the schema. So in your engineering side, you have to formalize your API schema to the level of details of every attribute to see that this is what you're exposing, which is necessary to be exposed, which is consumed by the application, right? Just don't give them any raw data. Formulate them in a very specific schema and then provide it to your application. Second is from security perspective, there are multiple dimensions. As I said, one was the design time of API. Next is runtime. Exploit frameworks like CAPF, which allows you to hide your APIs, see that you're going through multiple layers where there is some API topology hiding. So you get an interface, you apply your logic of AI ML to see that whether this can also be, I mean, some of them can also be looked into if there are aspects in which it can be, AI ML can be applied at the gateway level and then sense information in terms of whether this is a write request or is it a hacking request, right? So as I said, one of the examples given was looking into the size of the API. Don't really look at the endpoints, but also characterize your API traffic. So these cannot be done by AI and ML. But more traditionally, there have been like some of the traditional systems which have already allowed you to do rate limiting, right? Then enforcing policy, even based on endpoint. So there are multiple mechanisms like this, and also standards available not only from let's say I only spoke from a 5G perspective, but from an API domain perspective, if you refer to ITU specs, but what our Korean speakers spoke today, X.series, right? So you'll find many security best practices there, which needs to apply on the runtime as well. So there are two folds, engineering aspects as well as the runtime aspects, and there are multiple tool sets today which allow you to apply those best practices in your runtime. So now, which are those tools? There is a full market for it, as Sir just mentioned. There's a $50 million market for API security, and that market is full of these tools addressing many of these areas.
Okay, thank you.
Thanks to both the speakers here, Shankar. Thanks to both the speakers. Good session. Just last week, to your point of bad API exposure, one of the largest government companies here in India, NSDL, which generates the cash statement of all our investment. Everybody in this room generates a cash statement. I think all of us have an NSDL cash statement that we get. Last week, they sent out an update saying cash statement can also include your PRAN transactions. All of us have PRAN accounts, right? We have a PRAN transactions. Click on the PRAN link. It takes you to another company through which they've opened the API call, and that's where you put your PRAN number and your date of birth. You can see everybody's PRAN number and date of birth there. Just try it out this evening. This is exactly how we're still learning the whole API journey, and we're just exposing data like crazy.
Thank you so much for that wonderful session. Can we hear it for our speakers, please? May we have the mementos? May I request our moderator, sir, to please hand over mementos to our speakers, sir. Please do the honors for us. Thank you so much. So we have some bags as well to give. Yes, we must take a nice group picture. Thank you so much for that wonderful session, and I must thank the audience for being so interactive and asking such amazing questions. It really helps you and it helps everyone else as well. So with this, it's time for the valedictory session. We are ready to close. So I'd like to invite our dignitaries on the dais. Please join us. Welcome Shri Ajay Kumar Sahu, Member Services, DCC. So please join us. Welcome for our... Okay, we are just taking a 2 minutes short break and then we'll start. Are we ready? Shall we, sir? Okay, so welcome to the valedictory session. We've had a wonderful and very insightful 2 days. So with this, I'd like to invite our dignitaries on the dais. Shri Ajay Kumar Sahu, Member Services, DCC. Please join us, sir. Can we hear it for him, please? So we'd like to welcome you with some flowers, please. Thank you so much, sir, once again for being here. Shri Prabhas Singh, ex-member technology. Thank you so much, sir, for joining us and sparing your valuable time. Sir, some flowers for you, please accept. Ladies and gentlemen, please join us. Welcome Shri S.N. Ramagopal, Senior DDG, NCCS. Welcome, sir. Some flowers for you. Please accept this. Shri K. Shri Krishna, DDG, SAS, NCCS. So please join us on the dais. Welcome, sir. Please accept some flowers. So I'd like to welcome our dignitaries on the dais, and may I request Ms. Monica Adepu, ADET NCCS, to please summarize the sessions of the last 2 days for us.
Hello. Respected dignitaries on the dais, a very good evening to you all. They say that some endings are the new beginnings. I hope this ending will let us all strive towards the development of a reliable, secure and trustworthy telecom networks for us and the upcoming generations, as mentioned by member services on the inaugural day. As we have come to the conclusion of this 2-day-long international conference on 5G network security, which is organized by NCCS, DOT, CDOT, I would like to take some time of yours and present the closing remarks to the delegates, dignitaries, and the participants. To begin with, the International Conference on 5G Network Security commenced on 9th August 2023 at 10:00 hours with the inauguration ceremony in the presence of the dignitaries from DOT, CDOT, LSA field units, and other industry stakeholders and academia. The welcome address was delivered by Shri S.N. Ram Gopal, Senior DDG, NCCS, and the inaugural address by Manish Sinha, Member Finance, DCC. The keynote address is given by Shri Ajay Kumar Sahu, Member Services, and added with that, the special address by Shri Vinod P. Abraham, Special DGT, Karnataka, LSA. The inauguration ceremony ended with the vote of thanks from Dr. Rajkumar Upadhyaya, CEO, CDOT. The 2-day conference is scheduled as 7 sessions, which includes 16 lectures covering various topics on 5G network security. We have had the opportunity to listen to the major industry OEMs, telecom service providers, academia, Security Council of Korea, and also the NIST. Now let me take you with a quick round of summary of the 2-day-long sessions. The key concepts discussed and the major security threats that we all have to mitigate working together. To begin with, on day 1, session 1, we had evolution of security challenges in public telecom networks from the speaker, Sri Narendranath, Joint Secretary, NSCS. Starting from the evolution of the term telecom security to the shift of the cybersecurity era, he discussed everything with a blend of his own work and personal experiences. He quoted that security is a functional requirement and not an add-on feature. He stressed that security by design approach should be considered while designing the network elements. He has also left us with some recommendations to proactively participate in this domain to make the core network secure from the attacks. We would definitely look up to the matters pointed out by you, sir, and a heartfelt thanks to you. And then, day 1, session 2, the risks associated with the use of open source software components in telecom, taken by Sri Anish Kumar, Joint Director, CDAC. He began with the state 5G networks transformation into the software and major network components, how they can be deployed in software within hours now. And he also discussed various topics like SDN, MANO, and orchestration. Then he discussed the risks associated with the open source components, challenges and strategies to mitigate the risks with open source components. Followed by day 1, session 3, exposure to COMSEC scheme by our beloved DDG S.H. P.K. Singh sir. He introduced the audience to the mandatory testing scheme of DOT MTCT, followed by the COMSEC scheme and its objectives, only because of which NCCS is existing today here. And day 1, session 3 was on implementation of 5G networks in India by Mr. Hardik Bhavishi from Reliance Jio. He has shared with us the India story and the Jio story to 5G and the Atmanirbhar initiatives by Jio in development of 5G core and RAN in India. And day 1, session 4, we had on vulnerabilities in 5G core and mitigation approach by Professor Manjesh Hanawal by IIT Bombay, wherein he has explained the vulnerabilities in 5G core, vulnerability mitigation approach in the 5G core. Day 1, session 5 was on cryptography for security of 5G with focus on FIPS 143 and its adoption by Lily Chen and Dr. Tim Hall from NIST Cryptographic Technology Group. They have discussed the NIST cryptographic standards and journey from FIPS 142 to FIPS 143 and the standards that are already published and the post-quantum cryptography research that is going on in NIST. And he also shared the FIPS 143 standards and the validation methods. Day 1, session 6 was about weakness brought in by IoTs, CIoTs. It is by Sushil Kumar sir, DDG TEC, and Arindam Bhattacharya, group leader from CDOT. Sushil Kumar sir has discussed about the TEC initiatives in M2M and IoT domain, TEC tech reports on M2M and IoT security, proposed IoT devices classification for India. Whereas Arundam sir has covered the 1M2M way IoT threat assessment and 1M2M workflow security in 1M2M security framework, enrollment and provisioning. And he also spoke about the National Trust Center idea. Day 2, session 1 is followed by deployment of 5G in cloud technological options and management and orchestration by Uma Mahesh Mudigonda from Microsoft Azure. He explained as how evolution of operator virtualization platform has changed over the time and how a hybrid cloud services can save a lot of time and effort without compromising with quality and security. Day 2, session 2 was on challenges of 5G edge computing by Saro Velrajan from Jinkos. He spoke about the 5G multi-edge computing growth, advantages, challenges, and how it is unique yet complex, and the solution to adapt the zero trust framework to execute multi-edge computing. And on day 2, we have session 3 on security challenges of COTS and possible solutions from Professor Chester Ribeiro. He has discussed about COTS devices, threats, both software and hardware, and detection of the threats in COTS. Day 2, session 4 is on implementation of 5G RAN and security by Mr. Sanjeev Dhallam from Airtel. He has discussed the 5G use cases, 5G global landscape, 5G NSA versus SA RAN coverage comparison, key factors for successful 5G services, and key principles for the design of 5G security. Day 2, session 5 was on architecture and challenges in Open RAN by Mukesh Taneja, Vice President Mavidya. He discussed about the ORAN architecture, G-Node B, ORAN including RIC and network slicing, and also about security of 3GPP and ORAN. Day 2, session 6 was on experience on 5G security assessments in Korea by Professor Hyung Yul He is also the chairman of ITU-T Study Group 17, chairman of Korea 5G Security Council, and Ms. Sangshe Park, a research fellow. They spoke about introduction for 5G network in Korea and the 5G Security Council in Korea, information security products evaluation and certification schemes in Korea, and also about the ITU-T SG17 security work. Day 2, session 7 is on challenges posted in adopting cloud technologies for telecom networks and mitigation approaches by Mr. Shankar Srinivasan from Cisco. Guiding principles of security. He discussed about guiding principles of security threat landscape in 5G, zero trust in the access, securing 5G core, 5G APIs, visibility and impact. Day 2, session 8 is on security issues in RAN and possible solutions by Mr. Jagdeep Walia from Ericsson. He discussed on RAN security attacks and impact, ensuring network security requires mitigation on 4 levels, and 5G air interfaces, 3GPP standard security improvements introduced in 5G, and the key security improvements also have been discussed. Day 2, session 9 is on service exposure challenges in APIs, which was the last session of the day and the conference. It was delivered by Shri Nirant Amog from Nokia. He discussed about OWASP API Security Top 10 2023 and API Exposure Framework Standard. I really hope all these sessions have helped you out in enriching your knowledge and will definitely help you in carrying your jobs. Thank you so much.
Thank you so much for that, Monica. May I now request ex-member technology, Shri Prabha Singh, to please address the gathering. Sir.
Hello? It's okay. I'll call the Mr. Sahu, Honorable Member Services, Mr. Sahu. Senior DDG NCCS, Mr. Ram Gopal, and the DDG from this one. In fact, it was a wonderful session. This NCCS, of course, I don't revisit the history, but just for one thing, I had a close association with NCCS. This project was lying under the dark of some bureaucracy. Then, though member services was supposed to do it, but we have a suo motu function among the members. So I took it over as a challenge. And the basic issue was that the electrical and the civil infrastructure was not ready for last 10 years. They have done an excellent job with ISC Bangalore, but it was not moving. They were doing something dilly-dally is there. So I took it as a challenge. Every Saturday I used to come here, and Sunday I have to go back because the instructions from the Secretary of Telecom Commission and Minister was there, I should be present during the office hours. Anyhow, we took it as a challenge, and by the help of our colleagues in the Department of Telecom, after my post-retirement in October 2018, it was commissioned by Mr. Manoj Sinha, and Secretary Aruna was there, and they have also honored me at that time. So it was a wonderful one. Again, I have come back, and with a lot of new avatars in this one, I am really surprised that what we designed with the IC Bangalore, it was basically for 4G. Now it has turned the complete table to 5G. And in fact, the team which, for Sahu Saab, is one of the best teams which right now you are having. And they have delivered well also. Mr. Ram Gopal and Mr. Atul Karelia, they have done well in ITPC. They know the IT, they know telecom, everything is there. So it is a big resource which has been created. Now, again, now I come to the main thing about this one. As we know, friends, that the prosperity and the technology doesn't go northwise, it goes westwise. Started from India, went to west, again further west to Japan, to China. Now it has come to India again. So now the young people of India who are less than 65 years of age got a privilege to become the drivers for this technology, not only within the Indian home space, but outside Indian home space, for the world, for the civilization. So the honors rise upon we Indians who have been interested by the civilization to drive the facility to the max, to the next higher order. Maybe it's 6G, maybe 7G. India, because of the sheer intellectuals available there, sheer other things, the diverse cultures we are having and all those things are there, they are contributing to like that. And of course, the democracy is the biggest factor, which has provided us the opportunity to move ahead of that. Now, only I have to say about 2 or 3 take-ups, if acceptable, but I feel like is that about the NCCS, the digital infrastructure of NCCS, my wish list is, of course, it should be there. It should be customer-centric, it should be resilient. By customer-centric, I mean that let's implement the citizen charter. Whosoever are the customers or the stakeholders, all should be made inclusive of that one, not exclusions. And of course, some wish lists are also there as far as customer-centric is there. If possible, if remote testing is possible to be introduced, because as we know in COVID, a lot of things, exams and other things we are doing, it can do some remote testing also possible. So that will give a lot of help in, what I'm going to say, commutation, going for less commutation and the way the things are exploring. So it will give a help to them. Second thing which I want to say about is that we have talked about a lot of about the core, the RAN, the NMS, but there are certain active elements which are going to come in near future, and there is the power systems. These power systems plays a very crucial role as we go for the IoT devices in the power system, for the next generation power system, which are gradually coming up. There are the potential risks also. So that can be also a part of the 5G or 6G ecosystem. That is my recommendation. This is my thought process. Then about 1M, 2M standard, it's a wonderful standard. We started in 2016 or 17, CDOT has started these things. Now we have to take it to the max. We are a very good designer as far as Indians are concerned, but implementation somewhere is haywire. Only one suggestion is there that let's in a private domain, the industry, because the industry dons are here also, they can create themselves, they can create a group or they can call it a forum of 1M, 2M in the private domain also. And that can also work as a lobbying these 1M, 2M standards within the country and outside the country also. So these are the few small take-ups I can give about it. But yes, future is ours. And as we know that we wish that our India also becomes one of the leading leading economies in the world. Maybe as maybe 6% of the world GDP comes from this one. But I aspire that by opening up all these things, my thinking is that about 1 trillion of the GDP can come if we try like this by 2029 from telecom, IT, and AI. This is my vision, and on this I'm working out, and I'm sure that something will come out. If not 1 trillion, maybe it is 800 million or something like that, 800 billion or something like that. It's a big job. Only very few countries are more than 1 trillion. So with this, I thanks the organizers to provide me this opportunity for meeting you. Thanks a lot.
Thank you so much, sir, for your kind words. With this, I'd like to request Shri Ajay Kumar Sahu, Member Services DCC, to please deliver the closing remarks, sir.
Respected our member technology, friends, this 2 days seminar is definitely benefited to the society of our society, and in past if you see the threats are there for public, government institutions and private also. So what I've seen here, that all the three, like government departments, academia and private sector also, all three together have come here and definitely deliberated on security, network security, and how to overcome this problem. Definitely our network should be secured, and whatever suggestions or whatever deliberations have been took place here, that will give the future recommendations and our NCCS, what we are preparing the ITSAR and other things, security norms, that will strengthen. And I request our team that such type of seminar we should have in future also, and we should have a good support from all the corner of the industry, government and academia to again further strengthen our security system. One important thing is that endpoint security is also important. We have discussed the network security, but endpoint, the user end security is also very important. That also we have to think of whatever the elements are connected to our network, customer end equipment, UE end equipment, that also to be secured so that no malware function should be entered into our network. I hope that our this 2-day seminar workshop should give the future secured system new dimensions to the telecom network and to secure our country. Thank you.
Thank you so much, sir. May I request Shri K. Shri Krishna, DDG, SAS, NCCS to please deliver the vote of thanks, sir.
Good evening to all. Respected member S. Sri Ajay Kumar Sahu sir, ex-member technology Prabha Singh ji, Senior DDG Sri S.N. Ram Gopal, Special DG Sri Vinod Abraham sir, Senior officers from DOT, BSNL and industry, academia and other dignitaries and participants. We have come to the last part of these 2 days deliberations, that is acknowledging the efforts put in by various dignitaries and various other stakeholders who have become part of this conference. Initially, when this conference was conceived, the first deliberation was whether to keep for 100 participants or 200 participants. But because this is being organized for first time by NCCS, we thought we should go in a big way, and 200 participants it has been decided. And the DOT headquarters has supported us all through, right from the conception stage until it has become a reality. And now we are able to successfully organize this international conference on 5G network security for the last 2 days with the help of a good number of eminent speakers from reputed institutes across the globe. And participants also quite a good number are there. Around 180 to 90 are there in offline, and online also around 200 to 250 participants were there. And the webcasting what has been made, there were almost around 1,300 views yesterday, and today also it must be equal number of views must have been there. So that way this conference can be considered as a successful conference, and we hope that all the participants will be benefited by this conference, whatever deliberations that have happened. Just to make sure that we don't forget anybody's contribution, I just jotted down all the stakeholders in the conference to acknowledge their contribution. The inaugural session was attended by a good number of dignitaries. Member Finance has inaugurated the session. We are thankful to Member Finance Sri Manish Sinha sir for kindly consenting for inaugurating the session and attending the session on attending the conference on the first day. And Member S sir has delivered a keynote address and inaugurated the exhibition. We are grateful, sir, for delivering the keynote address and inaugurating the exhibition. We express our gratitude to you, sir. Then the other dignitaries during inaugural session, CEO CDOT, Dr. Rajkumar Upadhyay was there. Now he is not available here, but he is also a co-organizer. CDOT and NCCS together, they have organized this conference. We are thankful to CDOT to join with NCCS for organizing this seminar. And Special DG sir has addressed special address on during the inaugural session. Thank you, sir. Sri Vinod Abraham sir, we acknowledge your presence in the inaugural session. And we have eminent speakers. Each individual speaker was acknowledged by Maunika during her summarizing the 2 days deliberations. Acha. NIST, we have 2 eminent speakers. Madam Lily Chan was there and Dr. Tim was there. Tim Hall was there. We acknowledge their contribution, and of course, NIST has become the highlight actually in the yesterday's deliberations, because everybody was waiting for the outcome of the finalists who are going to take our lightweight cryptography, who are going to finalize for the IoT devices, as well as everybody is waiting when the post-quantum cryptography standards are going to be published by NIST, and they have given quite insight about these 2, lightweight cryptography as well as the post-quantum cryptography, when they are likely to be published and all. They have given some indications. They were very useful. And the eminent speakers we have from different sources. DOT headquarter senior officers have spoken and moderated also some of the sessions, Mukesh Mangal sir and PK Singh sir. And we have eminent speaker from NSCS, Sri Joint Secretary Narendranath sir is there. Then we have speakers from GEO, NIST, then so many other organizations, Nokia, Ericsson, Cisco, Microsoft, TEC, CDAC, CDOT, Mavanir, Jinko's Consultancy, and IIT Bombay and IIT Chennai. Those lectures were very, very insightful, and they have really thrown light on the latest on the 5G network security and all. We are thankful to all the speakers who have contributed as part of this conference, and without them, this conference would not have got so much attention from such a large number of participants. We thank each and every individual speaker and moderator who have become part of this particular conference. The value has been added to this conference by 6 exhibitors who have exhibited their products. IIT Bombay Vajra product they have displayed in the exhibition, and we have from CDAC, Gigayasa, Extent Networks, Lekha Wireless, SecNurex. All the 6 companies have exhibited 5G network security products. We are thankful to them for agreeing for our proposal and exhibiting their products on these 2 days by taking the pains of bringing their data and equipment here and displaying them for the benefit of the participants in this exhibition. We thank you all. And of course, no conference can become successful without having effective participants. We have seen, especially in the question answer sessions, even from the online also, many participants have raised so many queries, and some of the questions the speakers are also not able to answer, but they are able to give some insight into the topic, what they have dealt based on the questions raised by some of the participants. We are thankful to all the participants offline as well as online who have participated from across the globe. As I have mentioned, around 400 participants are part of this conference. We are thankful to all the participants who are responsible for making this conference a great success. Thank you all. And I should mention the contribution of SCI section from DOT headquarters. Right from the day the conference has been conceived based on the directions received from earlier Secretary Sri Rajaraman sir and member services, earlier member services Sri Uma Shankar Pandey. And right through all these processes, Sri PK Singh sir and his staff in SCI section, they have really worked hard and guided us to decide the topics and making the itinerary for this program, and who all should be the speakers and all, and Korean speakers are brought in by PK Singh sir based on his acquaintance in ITUT study group 17 and all. We are thankful to you, sir, for guiding us throughout this conference. And of course, we should not forget that the NCCS team has been continuously motivated and led by Senior DDG Sri S.N. Ramgopal sir. And because of his motivation and guidance, almost all the staff, because I am seeing in the last 2 days, some of the staff who are very like passive spectators in the office, I am seeing them that they have become lot of energetic people and contributed so much in this conference. Whether it is RAs or any staff member you take, they were very active and organized everything so faultlessly and impeccably that the conference has become so successful because of your efforts. And I must congratulate NCCS team, even though I am part of the NCCS team, but I should mention the contribution made by the RAs and other junior staff members who are part of NCCS for their contribution for the success of this conference. And I should not forget to mention the contribution made by the event management company, that is International Conference and Event Management Company, who were all through with us once we have finalized the conference arrangements and all. They were there all through, and last 2 days they have worked hard to see that all the arrangements are in place and all, along with the NCCS staff. We are thankful to ICE, including MC Madam, who is with us for the last 2 days and for arranging this conference in a successful manner. And when we have met Dr. S. Muralidhara, principal of this institute, for looking for the venue of this conference, he has readily agreed and offered that we are ready for students' sake. If you please allow some of our students to become part of this conference and please use our conference hall. And in the last 2 days, their staff, and I should specially thank the BMS management and the trustees who have agreed to spare the services of the institute and as well as this auditorium for the arranging this conference. And we did not find any difficulty in the last 2 days for arranging this conference and all. We are thankful to BMS management as well as the principal of the institute, Dr. S. Muralidhara. And caterer has given us good food in the last 2 days. He has taken care all snacks, lunch, everything he has taken care. We are thankful to Bandari caterers for making our conference deliberations and all such a progressive and healthy things by feeding us good food during these 2 days. We are thankful to our caterer also. We are thankful to all those who have directly and indirectly contributed for the success of this conference and making it a great success. And every detail has been taken care by all the people who have been directly involved in this conference. We thank one and all for the cooperation they have extended for the successfully organizing this international conference on 5G network security at BMS College of Engineering. Thank you. Thank you all.
Thank you so much, sir. This event has been very successfully led by a very efficient team from NCCS. We'd like to thank our senior DDG, NCCS, Sri S.N. Ramagopal. Can we hear a big round of applause for you, sir? Thank you so much for bringing all of us together. Sir, I know this is not in the agenda, but 2 words of wisdom from you would really be nice before we go. Okay, shall we take a group picture before we close? May I request all our dignitaries to please come together? Shall we hear it for everybody, including all of you, ladies and gentlemen, for making this event a very successful one? Thank you so much. I would like to thank each and every one of you for being so patiently listening to every detail of from yesterday up to now. Thank you so much for being here with us, and we hope to see you at our next event very soon. Thank you so much, everyone. My name is Usha Milwani. Thank you once again for being here on behalf of NCCS. I would like to thank you. Wish you a great evening and a great weekend. Goodbye and God bless. Thank you. Yellarigu dhanyavada. Requesting NCCS team to please step on stage. We're going to take a group picture. The entire team from NCCS, everyone please join us on stage. Right now we are doing this. Please step on stage quickly. We'll take a group picture. NCCS team. RAs also, please. RAs and NCCS team, please on stage.